There's something really special about the Android community. As we travel around the world and meet developers, we're really struck by the spirit of innovation and helpfulness, and really how everyone is working together to build a better Android.
I'm so excited to go to Android Dev Summit and meet the developers I've been following online since I started learning Android.
The Android Developer Summit for me will be my first. I'd like to hear about all the awesome new libraries and things that Google has planned for us as Android developers.
As a platform, we build the foundations, the building blocks, the tools, but really the way that developers take those technologies and create new businesses, new apps, new games on top of it in ways that we could have never imagined is just so special to see.
I didn't have a degree to back me up, but I started participating in Android meetups. With this little community of people online, I felt more and more confident on my skills. I wouldn't have thought that in 7 years you would be running your own Android meetup. I would have said, you're crazy.
The Android community has been hugely influential to where I am today. You've got a massive community of people to reach out to, something that you actually depend on for your career. It's not all about take, it's also about giving back.
It's so inspiring to hear stories about developers like Zara and Nick who have had a chance to join the community, grow through it, and are now giving back and helping others grow.
Giving back to the community and being involved in it as you can is vitally important to this whole ecosystem of Android.
This is a really good feeling to be with people who speak the same language as you, even though we're all from different countries, but we all speak Android.
Welcome to the stage, Dave Burke.
All right, hello everyone, and welcome to the 2019 Android Developer Summit. It is awesome to have so many developers here to talk about the hottest topics in Android development. So in addition to the many Google engineers we have today, we have over 700 developers in person from 65 countries, as well as thousands of you joining on the live stream. So welcome, everybody. Now, computing has gone through a pretty amazing evolution in my lifetime. I can clearly remember my first computer. I was 8. It was a BBC Micro from a company in the UK called Acorn. And I can still recall that feeling of wonder, of possibility, where I could dream up ideas and bring them to life. I remember my primary objective being 8 was to build a defense system to protect my bedroom from my older sister snooping. And so I rigged a photoresistor to the analog joystick port, and then it could detect an intruder breaking a beam. And then I used, I think it was a cassette motor relay to fire a peg gun and then shoot intruders. I get on a lot better with my sister nowadays, so that's good. The company that built the BBC Micro, Acorn, it went on to design one of the first commercial RISC PCs. It was called the Archimedes. And then in the early 1990s, they set out and created a startup, little known at the time, called ARM. And of course, today, billions of phones around the world are powered by ARM's RISC processors. And the other ingredient you'll find in these phones, of course, is Android. And this is the part of the keynote where I usually mention the 2.5 billion devices. But when the Android team began, the team didn't know for the first couple of years if there would even be one user, let alone if the project would continue. And there were many companies thinking about and working in this space at the time, and it wasn't clear that Android was the one that was going to shine through. But 14 years later, here we are, and Android's powering not just phones and tablets, but auto and wearables and TV and so on. And part of why this happened was, one was a team that worked, really, really hard on this platform. But a lot of it was also timing, right? It was a convergence of hardware capability and an industry that needed this kind of platform. But a huge part of it was the ecosystem that built up around Android, from the device makers to you, the app developers. And building an ecosystem is just a really hard thing to do. It's something we strive hard to do well. And it's why we get excited by events like today, where we get to spend time together and to envision a future together. Because for many reasons, you are all a reason for why Android has 2.5 billion devices. Now, usually when I talk about Android, it's typically an I/O setting, and I'm talking about the next release. What I wanted to do today was just talk about 5 distinct work streams that I think are important for Android for the next 10 years. So first up is something we call helpful innovation. So when we design features, when we're thinking up ideas for Android, we want to build features that help users feel empowered and productive, and that simplify things in ways that are easily understood. And so one recent example of helpful innovation is Android's emergency location service. And today, 80% of emergency calls, unsurprisingly, originate from mobile phones. And historically, the challenge has been that the location that the emergency responders get from such a call is limited to cell ID, which has a radius of several miles. And the FCC in the US estimates that if you reduce the response time of an E911 call by just 1 minute, you can save 10,000 lives a year. So we set about building this emergency location service into Android, and it's available now on 99% of Android handsets. And what we do is we combine all of the location technologies in the phones, so Cell ID, Wi-Fi, GPS, et cetera, to dramatically improve the location accuracy. And now British Telecom estimates that for their emergency calls on their network, they're now seeing radiuses of about 50 meters for their emergency calls, which directly translates into saving lives. Speaking of safety, just last week we launched a new feature initially on Pixel 4 that detects if you're in a severe car crash and helps you call for help. And this feature uses high G accelerometers and audio machine learning. And we were motivated by the fact that car crashes are one of the top 10 causes of death, certainly in the US, for most age groups. By the way, if you were wondering how we tested for true positives for this feature, here's a quick video. So this car is armed with 20 Pixel phones. And before you think we're being wasteful, I just want to point out that we reused the same car for multiple crashes, so it gives a whole new meaning to my phone keeps crashing. I'll be here all week. Anyway, so we're exploring ways to bring this to the ecosystem more broadly. So another example of helpful innovation is around the hardware itself. And today there's an overarching trend in the industry around maximizing the screen area. And broadly, there's two paths being taken. So on the one hand, device makers are sort of striving for this holy grail of edge-to-edge glass. And it's a really hard problem because you got to find a place for the front-facing cameras, the earpiece, the proximity sensors, antennas, so on and so forth. But year on year, it's getting there. The other path takes a step back and uses novel technologies such as 360-degree hinges and foldable glass. And recent examples of this are the Samsung Galaxy Fold and the Microsoft Surface Duo. And we're working closely with the teams at Microsoft and Samsung to optimize Android for these form factors. Already, Android 10 takes advantage of dynamic displays by adding the ability for apps to indicate if they support resizable activities, and as well as enabling multiple simultaneous resumed activities. And these features enable a key experience that we call app continuity. So the idea is you're using the app, and then you can unfold or open the device, and then the app stretches to fit the larger display. And of course, all these features help your apps perform better on larger screen devices, like the 175 million Android tablets, as well as Chromebooks. So the second work stream is something we call updatability. So Android's a unique project. It's not a single product, as you know, but it's an open source platform that runs on devices of all shapes and sizes from different manufacturers at wildly different price points. And Android doesn't have a challenge of running, initial versions of hardware typically run on the latest version of Android. But the real challenge for us is ensuring that devices already in the hands of customers continue to get timely updates. And it really boils down to economics. So thanks to efforts like Project Treble, which separates the hardware-specific code from the operating system, we've reduced the cost of updates. And we're starting to see progress here. So for example, Android Pie grew at 2.5 times the rate of Oreo. And Android 10 is projected to grow at 5 to 6 times the rate of Oreo. And you can also see the effect of Project Treble in our beta program. So this year, we had 21 devices from 13 OEMs participate. Security updates have also improved. These are the smaller patch updates. And today, almost 90% of devices that have launched since the beginning of 2018 receive quarterly security updates, and we're working on improving that further. In Android 10, Project Mainline, now called Google Play System Updates, standardizes modules across different manufacturers, as well as provides a channel for that code to be updated through Play Store. And Android 10 has several updatable modules, everything from cryptography to aspects of the media framework. And this was a really huge foundational undertaking for us. First, we had to create a new packaging format called Apex. If you're wondering, that stands for Android Pony Express. It's the best thing we could come up with. It's like an APK, but it runs at boot. That's the main difference. Then we created file system snapshotting. So the idea here is if we inadvertently pushed a module that caused a battery regression, we can roll the module back, but then also revert the file system back to its original state. And then third, we had to create new release machinery so that we could do stage rollouts, A/B updates, long and short window telemetry, and so on. And so we think this progressive software deployment approach is going to be a huge benefit for Android over the years. And as the number of updatable modules increases, developer fragmentation reduces as the devices get more consistent. The third multi-year effort for us is around security. Now, Android uses layered defenses to keep users safe. For example, Android 1.0 launched with kernel-level app sandbox protections. And then we later added SE Linux on top to provide access control to separate apps from the system and apps from each other. And then ASLR adds address randomization on top of that. Then we introduced hardware-enforced verified boot to prevent devices from being tampered with. And then Google Play Protect adds an anti-malware layer of protection on top, scanning billions of apps every day. But probably one of the strongest aspects of Android's security story is that it's open source and cross-platform. And that means it's open for scrutiny by people and organizations, and as a result, gets a lot more people looking at it than a proprietary OS. And code that runs on heterogeneous hardware is, by definition, more robust. So then it comes as no surprise, certainly to us, that the bug bounties for full-chain exploits on Android from companies like Zerodium now exceed that of iOS. And by the way, if you can find such an exploit in Android, it's worth $2.5 million to you today. And it's also no surprise that in Gartner's 2019 security report, Android Pie scored the highest possible rating in 26 out of 30 categories. So security is all about protecting your data. The other side of the coin is privacy, so giving users control of their data. And when Android first launched in 2008, we deliberately designed the platform to be very open and customizable. And this led to a ton of innovation, which has been fantastic. But along the way, we also learned of some unintended consequences of some of the APIs. And as users, as we become more dependent on our phones for our digital lives, and as the apps themselves get more sophisticated, our expectations of privacy are shifting. And for that reason, in Android 10, we added over 50 features and changes related to privacy. And I wanted to call out one in particular, background activity starts. So there are, of course, lots of legit reasons that you would have background activity starts. For example, the dialer when an incoming phone call is received. But we also found that this capability was open for abuse. And it's really bad when it happens. So here's an example of the problem. You're navigating in your car, and all of a sudden a pop-up ad appears and forces the navigation system to go into a picture-in-picture. And if you think this is a theoretical scenario, here's some real-world feedback that we received from somebody who actually saw this happening on their driver's phone, rather. And so it's pretty scary. And this is an incredible stat, but we estimate that phones running Android 10 blocked over 17.8 million advertising pop-ups in the last week alone. So tackling privacy is super important, but it's also really hard, right? And so we want to make sure that we do changes in a thoughtful way without breaking the app ecosystem. And we've heard from many of you that these changes can be painful, like scope storage. And we took your feedback there and made some changes. And we're also planning on soliciting your feedback earlier in the release for the next coming year. The fifth work stream is really the theme of this whole summit, great developer experiences. And perhaps, as a consequence of Android's flexibility, we often get asked, what does the Android team recommend when building apps? And we call our recommendation modern Android development. And modern Android is opinionated and powerful with a more complete platform. And it's all about helping you focus on what you do best, which is building amazing experiences. And you can see it in investments that we're making in Android Studio, in Jetpack, and Kotlin and Compose are two especially great examples. So Kotlin is a modern, concise language, and it's something that you asked for and is now the recommended language of Android. And Compose is a modern declarative UI toolkit designed for the next 10 years. This might sound a little strange, but we chose and designed these tools to also be enjoyable to use. We think that's important too. Both Kotlin and Compose also have this really critical property. They're designed to be compatible with your existing apps. And this means that you can phase them in on your timeline. So you can bring in Kotlin code and Compose views when you're ready. In fact, we just reached a milestone where almost 60% of the top 1,000 apps now are using Kotlin. OK, so that's a quick insider peek into how I'm thinking about Android. It's time to get this thing started and dig in a bit deeper. And so I'm excited to invite Steph up to the stage to take it from here. Thank you.
Hi, everyone. So Dave started us off with a window into some of his long-term thinking and how it's shaping Android. Today, I want to shift gears now, and let's focus on developers and what's coming for you today. So today, Android's momentum is amazing, with over 2.5 billion users, as Dave talked about. But today also marks another new milestone. There are over 116 billion installs on Play in the last year. It's a platform that's making so many developers successful. Now, at Google, we see our role as shepherds of the platform. In the beginning, this was all about protecting Android's openness with a powerful, flexible operating system. But more recently, that's changed. Developers have started to ask us, what does the Android team recommend when it comes to building apps? Now, you've told us, keep the openness. But you also want us to become opinionated about the right way to do things, and to make the right way the fastest way. So the fastest and the easiest way. And so we are. The team calls this modern Android development. Modern Android is all about helping you focus on what you do best, opinionated and powerful for fast, easy development. Taking away everything that slows you down so you can focus on building incredible experiences. It also means being open to new ideas that can make Android better for you. Each one we want to consider carefully before we bring it to the community, because we have to make it work at scale for millions of developers who have billions of lines of code. You can see modern Android at work in Jetpack, in Kotlin, and in Compose. Kotlin is a great example of something that you asked for, we adopted, and this year we're moving to a Kotlin-first design in our APIs. Compose is a modern UI toolkit that really leans into the idioms of Kotlin, giving you a great UI development experience, together with direct platform access, backwards compatibility, and the performance that you need. Now, all these ideas originated in discussions with our community. And you told me it's obvious how much Android is listening to you. I am glad, because we are. Modern Android is really about working together, from ideas like this to working in the open completely, like Compose, to the more than 50,000 bugs that have been filed this year by you across every area of Android. In fact, we flew one of our top bug reporters here from Europe today. Marius, can you please stand? To give him a round of applause. In today's keynote, you'll see how modern Android and this thinking is shaping all three platform pillars. We'll talk about development tools, distribution, and the OS itself. First, modern Android tools and APIs. I want you to hear from Ramon and Karen about what's new in the IDE, in Kotlin, and Jetpack, as well as Compose, the new modern Android UI toolkit. Next, for modern distribution, I want you to hear from the Vice President of Play and his hard work to help apps and games succeed and grow even faster, as well as do it safely. And finally, I will be back to talk about the future of the Android operating system. So with that, can you please welcome Karen to tell you more about our developer experience? Thank you.
Thanks, Steph. Hi, my name is Karen, and I run the product team for Kotlin, Jetpack, and Android Studio. Modern development starts with a language, and we added Kotlin officially because you wanted it, and it was the right choice. We're seeing incredible adoption across the world. Almost 60% of the top 1,000 apps on Play are already using Kotlin in production. 53% of pro Android developers use Kotlin. And since May, we've seen 20,000 developers attending Kotlin Everywhere events in 75 countries around the world. And Kotlin just won Breakout Project of the Year at OSCON. If you haven't tried Kotlin yet, it's a really good time to try it. Whatever you can write in the Java programming language, you can write faster in Kotlin with less code. You have fewer bugs. There's full null safety built in, so no more null pointer exceptions. Idiomatic data classes, code routines for asynchronous code, which is super key for mobile apps. And all our benchmarks show that an app written in Kotlin is just as fast as an app written in the Java programming language. Because Kotlin is fully interoperable with the Java programming language, you can mix and match the two. So you can start using Kotlin in just a class or just a new part of your app. That's also what we did at Google. There are several major apps that are already in production: Drive, News, Nest, Playbooks, Google Home, and even more are coming. We're committed to making Kotlin better for the long term, and we're partnering even closer with JetBrains to do that. Faster Kotlin compile speeds, incremental annotation processing with KAPT, better IDE typing latency, more lint checks, and even optimizations in R8 that are aware of Kotlin-specific bytecode patterns to make your app sizes smaller. And today, we're releasing full IDE support for Kotlin build scripts. We are growing a global community of modern Kotlin developers. If you're just starting out and just learning, wouldn't it be cool if you could learn Kotlin today without downloading any tools? You can with the Kotlin Playground by JetBrains or the new Kotlin Hands-On. If you're looking to grow your skills, we have a number of courses on Udacity, and we're also launching a new advanced Android course. If you want to test your skills and you want something to prove for it, we're offering an Android developer certification with Kotlin. It normally costs $149, and if you're watching on the live stream, you'll get the code to get it for $99. If you're with us in person, we're giving it to you for free. And one more thing, if you think that you're ready to be a Kotlin expert and you want to join our extended team, we're expanding the Kotlin Google Developer Expert Program, which is sponsored by Android, Google Cloud, and JetBrains. And it means you'll have even closer interaction with the engineering teams at Google and JetBrains. We are having so much fun with Kotlin and Jetpack, and I'd like to invite Roman to tell us more.
The introduction of Jetpack marked a huge shift for us. We're investing in crafting an API layer on top of the foundations the Android team has been building for years to help you build high-quality apps more easily. Jetpack can now be found in over 84% of the top 10,000 Play Store apps, and 70% of pro Android developers use it. It is designed to solve real-world issues that you face every single day. And to that effect, we've expanded Jetpack significantly, and we're now offering over 70 libraries, from architecture components to Kotlin extensions to camera and a lot more. But I would like to share with you some of the progress we've made over the past few months, starting with benchmarking. It was first unveiled at Google I/O and is now available as a release candidate. This library makes it easy to measure the performance of your application with confidence, and we even use it ourselves to measure the performance improvements and regressions of several Jetpack libraries, including Jetpack Compose. View binding is an easier way to access views from your code. It is a type-safe solution with minimal build-time impact. There's no more find view by ID, and there's no more annotation processor. And you can start using it today if you download Android Studio 3.6 Beta 1. Camera X will be available in beta in December. And by addressing the differences between the many devices that are part of the Android ecosystem, Camera X lets you focus on what you do best, building your application. And we already use Camera X in two major Google apps, Google Lens and Lens Go. And those two apps have seen a 10% reduction in camera-related crashes thanks to this library. But beyond core camera functionality, Camera X also offers extensions such as night mode. And many manufacturers like Samsung, Xiaomi, Oppo, Motorola, and LG are committed to supporting those extensions. But the key to the success of Jetpack has been listening to you. And we heard you loud and clear. You love Kotlin, you want simple APIs, you want declarative APIs, and you want state-of-the-art tooling. And that's why a few months ago at Google I/O, we unveiled our most ambitious project to date, Jetpack Compose, the modern Android UI toolkit. Jetpack Compose makes it easy to build beautiful native apps. It offers a declarative way to build UIs. It makes your code simpler and more intuitive. And we're inspired by Kotlin. You can adopt Compose at your own pace, thanks to seamless compatibility with the existing UI toolkit. But let's take a look at a demo. So here I have a simple app that I'm trying to write. It's a photo gallery. I want to show a list of my photos. There's not much yet on screen, so let's write it. You can see here in my activity, I already wrote a photo card composable function. So a composable function is a component. It's a visual component. We're not going to look at this one just yet. But before I write the actual UI of the app, I want to make sure that my photo card works correctly. And the best way to do this in Android Studio is to create a new composable function. This is a preview, so I have some test data that's already there. I'm going to add a material theme scaffold, just to make sure I have the proper colors. And then I'm going to invoke my component and give it my test data. And if I use this new preview annotation, I'm going to give it a name. I can just hit build and refresh. And in just a couple seconds, you're going to see a preview of the component right there in the IDE. I said a couple seconds. All right, here it is. But what makes this really powerful is that you can create as many previews as you want. So for instance, if I create a second one and I change the theme to be the dark theme, I can just hit refresh. And then I'm going to see two previews with the two different themes right here, again, in the IDE. And of course, I can change the test data. I can refresh again, and you're going to see the bottom card update with a different photo. So let's build the rest of the app. So I want a list of those cards, so I'm going to use a vertical scroller. It's going to contain what you know as a vertical linear layout. We call that a column. I'm going to add some spacing around it to make it look pretty. And the beauty of this declarative model is I have this list of photos as a parameter to my composable. And all I have to do is iterate over it like you would in any other place in your code. And for each photo, I'm just going to add a photo card and some extra space at the bottom. And now I'm ready to run the app. But I don't know about you, like going back and forth between the IDE and the emulator can be a little annoying. So I just want to show you something that will come to Android Studio at some point in the future. It's the embedded emulator. So now, of course. It worked yesterday. All right. Let's fix it in real time. No, wrong tab. This tab, this tab. No. All right. All right. We're going to try it one last time. Wrong version of the emulator. There we go. All right. Let's see if it connects this time. View, tool window, emulator. No. All right. So of course it worked in every rehearsal. You would see the emulator running side by side. So this is really powerful because it's fully interactive. So you could see the real app running next to your previews that are effectively your unit tests for the composable next to your code. All right. So Compose is a lot of fun to work with, but until now, if you wanted to try it, it was a little difficult. You had to download several gigabytes of source code, and you had to build everything yourself. And I know you're not used to it. That's what we do every day. So it's painful, but we're aware of it. So today, to make your life easier, we are releasing the Jetpack Compose developer preview. All you need to do is download the latest Canary build of Android Studio, and you'll be good to go. We've also added a Compose section on developer.android.com, and it includes a beautiful tutorial. We also have sample apps that you can see on screen that have been built with Compose. It gives you an idea of the support we have for material design. And Compose marks another drastic shift for us. It is developed entirely in the open. All the work happens in AOSP. And the team engages in daily discussions with the community. We're present on the Kotlin Lang Slack channel. You can join us if you want. And we also run monthly developer studies. And thanks to all the feedback that we're getting continuously, we've already made many, many API improvements. So I would like to thank all of you who have been helping us and supporting us. Things are only getting better thanks to you. And because of that feedback, our current plan is to ship Jetpack Compose as a beta next year. As you just saw in the demo, when it works, Compose is designed in close relationship with Android Studio, but I will let Karen tell you more about the IDE.
Thanks, Roman. I am personally really excited about Compose. But one of my favorite things about Compose is that there's full Android Studio support. Android Studio is the official IDE for Android, and we've come so far since our 1.0 release. It has full support for Windows, Macs, Linux, and also Chrome OS, with Chrome OS app usage growing 4 times in the last year. So the team has been working on way more than just Compose, and I want to show you some of that. So we want to make iterating on code faster, doing things like the preview or the embedded emulator, doing things like apply changes, creating faster deployment speeds, or even showing a preview of Chromebooks where you can deploy your app directly onto a Chromebook so you can test and develop on the same exact machine. We're also looking at existing pain points, and we've heard that animation is hard. We've heard that looking at resources is hard. So I'm going to pass it back to Roman to show you a little bit more about some non-Compose stuff.
All right, because before I get to the fun bits, I just wanted to show you a Gradle script written in Kotlin. And of course, you have access to the full power of the IDE, so you have a code completion. Go ahead, code completion, you can do it. There we go. And you have quick fixes. All right, so this is the visual editor using constraint layout. If I click on the widgets, if you're familiar with constraint layout, you know this is what you expect. And we have this panel that we want to open from the bottom, and we want to animate that. And you all know that sometimes doing animations on Android can be a little challenging. First, you have to choose which API to use. So we decided to make it easier in the tools. So if you have a constraint layout, you can just right-click on it. You can click Convert to Motion Layout. We accept. And now you can see that we have a start and end state. And from here, what you would do is you would change the position of your widgets in the different states. You can create your own states. And from that, we can create animated transitions. So I'm going to switch to a different files where I've done most of the work. So you can see my start state where everything is collapsed. You can see my end state where everything is open. But you can animate more than just constraints. If you look at the color of the app bar and the fab, you can see that they change between the two states. And now if I select this transition arrow, I can play the animation right here in the IDE. And I can even scrub back and forth, so it makes creating animations a lot simpler. So another thing I want to show you is right here. So I'm going to run this app. The app itself is not super interesting. What's interesting is this new live layout inspector at the bottom. So it just connected. And you can see that when I play with the app, if I change the screen, the inspector updates in real time. And of course, now it's stuck. OK, here we go. I can select any of the views, and it's going to select them in the hierarchy on the left. You can inspect all the attributes. If I select the submit button, it does something that I find awesome. Look at the text size. It says 50. And we all know that themes and styles are a little complex, and sometimes it's hard to know where the value comes from. So if I expand this, it's going to tell me it comes from this fragment. And it came from that dimension value. And you can see that we're overriding the original value of 18, which is defined in the style and the theme. So you won't have to spend hours anymore debugging themes and styles. Before we go back to Karen, can we switch to the other demo mission, please? I fixed the demo. All right. There you go.
Thanks, Roman. That was great. So it's just as we talked about seamless compatibility with Compose and how you'll bring it with your existing code. The same tools team is working on both. So a lot of what you saw here is going to work in the Compose world. So we know that the IDE, though, is where you spend all your time. So if the IDE is hanging or your builds take too long, it doesn't matter how cool a feature is. And we heard you loud and clear. Make our IDE rock solid. We spent 8 months on Project Marble, focused on stability, performance, and fundamentals for Android Studio 3.5. We saw double-digit improvements, 60% drop in UI hangs, or freeze times, 40% drop in UI hangs, over 50 memory leaks fixed, 23% drop in Gradle sync failures, and a 57% faster deployment speeds. We took the time to get some features that we didn't get right the first time, like Instant Run. We rebuilt them totally from the ground up. We relaunched them as apply changes, and then we deleted over 50,000 lines of code. And we know that we're not done yet. We're committed to a focus on quality, and we built the infrastructure and the dashboards that we needed to keep getting this right. OK, let's talk about build speed. It's been the #1 request for the last 5 years. We kept chipping away at build speeds, our Gradle build speeds, but total build times weren't getting faster. Code bases were getting larger, custom plugins were adding to build times, annotation processors were negating the benefit of incremental build. So we broadened our focus, and we tackled the top annotation processors. Glide, data binding, Dagger, they're all incremental now. And we didn't stop there. Resource processing, multi-module dexing, generating only a single R class, they're all faster. And those average build times, we're seeing 24% drop, and they're improving every release. And finally, we're helping you spot issues in your own builds by helping you visualize what's time spent across the build pipeline, so you can see if it's a custom plugin, if it's build configuration, and then choose what to do with your own build. Okay, just moments ago, we released the first canary of Android Studio 4.0. It contains the preview of our compose tooling that you saw with Roman. So that live preview, the code completion, a full sample, it has the project templates. It's way easier to try out Compose. It has Java 8 library desugaring. It has the motion editor. It has full support for KTS files and Kotlin live templates. And now I'd like to invite Tien to tell us more about modern distribution. Thank you.
Hi, everyone. I'm Tien, and I run product and UX for Google Play and Android App Safety. Today literally marks my second anniversary at Google. In that short time, I've met many talented and creative developers around the world. And it's been especially inspiring for me when I visit markets like Brazil or Nigeria and meet developers who've been able to build global audiences or build businesses that solve real local problems. As you heard Dave mention earlier, user privacy is foundational to what we do. If users don't trust Android and Play, then there won't be anyone to download your apps. Trust and safety has always been a top priority at Play, with human reviewers, constant improvements to Play Protect, and policy updates to evolve with the threats that we see. As a result, apps that are downloaded from Play are an order of magnitude safer than from any other source. This year, we've been increasing all our detection capabilities for impersonators, repackaging, bad content, and other forms of abuse. But we know there's a lot more that we could be doing. We've seen SDKs that seem well-behaved, but later try to do nasty things like enlist a user phone into a botnet or exfiltrate personal information. We're up against some really sophisticated bad actors, but I'm also very proud of the way that we've taken action. With your help, we've reduced access to sensitive data and made Play even safer for children and families. We restricted SMS and call-out permissions to only apps that need them as part of their core functionality. As a result, 98% fewer apps now access the sensitive data. This is thanks to your hard work. Users are now safer, and they know they're safer when they download apps that request fewer permissions. Now, to help protect children and to give parents more confidence when choosing apps for their children, we updated our families policies. They're more stringent with regards to content, ads, and PII. And we're asking you for more information on who your app is for so we can better surface the right content to the right age groups. We're not stopping there. We're working with teachers to better identify quality apps for children. We're working on rules to ensure users understand their subscriptions. We're working to ensure developers access background location data appropriately. And we're working on better protecting your intellectual property. We're also starting to work with SDK providers to help them improve their quality and help app developers know which SDKs are safe. Just to give you an idea of the scale at which we have to operate, we recently took action against a malicious SDK. It affected 200,000 apps. As you can imagine, it's kind of hard to reliably reach out to 200,000 developers. Now let me pause there. I know that's a lot of change. And changes like these are really hard to make gracefully on such a large ecosystem. We understand the burden that it places on you to have to constantly adapt to new policies. especially when the vast majority of you have done nothing wrong. You've told us that our change process could use some work, that our communications are too vague, impersonal, or that you might have needed more time. That is absolutely on us to fix, and I promise that we will continually improve in this area. Now, I get a lot of questions about app reviews and developer bans. I want to give you a sneak peek behind the curtain. Every day, we have humans reviewing 30,000 new and updated app submissions. Even though some of the more complex reviews may take up to 7 days, most apps are reviewed within a couple. And as always, all appeals are reviewed by humans. Now, developers that repeatedly break policy are banned from play. These developers use many tactics to get new accounts and try again. Our systems are really good here. The vast majority of accounts are banned correctly, and many are banned before the bad actor has a chance to publish. Sometimes we get it wrong, though, and we know that those rare cases are super painful. Any developer ban can be appealed. It'll be reviewed by our global team, and if a mistake is found, they'll be reinstated. We'll continue to improve here. We're also working to include more useful detail in the Play console, with information on the status of app reviews, policy changes that might impact your apps, and other critical information. So look for some big changes in the coming year. We have to keep our users safe. It's in our shared interest. It's the only way we're going to keep this platform growing and thriving. So please keep working with us. Please keep providing feedback and help us through this period of change. Now, let's talk about some of the ways we're helping you reach users and build your businesses. It has been 18 months since we introduced the Android App Bundle as our vision for the future of app distribution. Over 250,000 app bundles are now in production, covering 25% of all active installs. Developers that switch see pretty substantial decreases in app size, and as a result, some have seen an up to 11% uplift in installs. Based on your feedback, we're making app bundles and dynamic delivery much easier to test. Internal app sharing lets you test builds of your app bundle as easily as you share APKs. And what's cool is that you can grant anyone on your team access to artifacts without giving them console access. We're also making it possible to get download links for old versions of your app, whether they were bundles or APKs. Finally, a lot of you have been asking for this. We're launching offline testing of dynamic delivery today with the Fake Split Install Manager. Another way that we help developers is by helping them launch successfully. From beta testing features to technical quality testing to staged rollouts, we have many features to help you take your idea to market. Recently, we've been focused on creating demand. Pre-reg is a best practice for building excitement around your app or game. We launched to general availability at GDC, and many developers have been using this to great success. Based on your feedback, we've been adding features to the program. A couple of examples. Nexon, a Korean dev, used pre-reg rewards to offer users 300 diamonds for pre-registering. Players who pre-registered had almost 50% higher day 60 retention and 70% higher ARPDAU. Edermax, a Brazilian dev, ran a pre-reg campaign with milestone rewards, with 4 milestone levels, each unlocking a unique in-game item. And users who pre-registered played 30% more daily minutes. We also just finished another successful launch, a little title you may have heard, Call of Duty Mobile. That saw almost 60 million installs in the first 10 days. With our new store merchandising capabilities, we were able to build hype all over the world and drive tens of millions of pre-registrations. We actually also worked directly with them to enable custom beta groups so they could test their game on specific devices in specific locales. This exclusive beta program is something we hope to scale out to more developers real soon. Another long-term bet for us is PlayPass. At $4.99 a month, users get access to hundreds of awesome apps and games completely free of ads and in-app purchases. I'm personally incredibly excited about this. I've been in the games industry for more than 20 years. I've shipped game consoles and games. I know the industry needs to have business models that work for all kinds of apps and games. Android has more reach than any other platform, and I want it to be a place where creative indie breakouts and shorter story-based games can be successful alongside free-to-play juggernauts or innovative apps. PlayPass only succeeds if developer succeeds. So we'll be doing that by compensating developers fairly for the value they provide to the users, whether it's a daily diary app, or short game that can finish in a few hours, or a game that you might be playing for weeks on end. We'll be using many signals to reward developers fairly, and we'll continue to tune that model and curate the best possible catalog for users. We've been working on PlayPass for a few years now, and I wanted to thank the hundreds of developers who joined us for the initial offering. Now, I'd like to invite Steph back up to talk about the platform. Thank you.
All right, so we've talked about tools and APIs, we've talked about Play. What about the operating system itself and what's coming? Now at I/O, this would be the cool new stuff for users part of the keynote, but today is Dev Summit, and it's all about developers. So I want to share with you important things you should know about how we're evolving OS releases with a developer lens, and information to help you prepare and take advantage of what's coming. First, I want to give you a glimpse in some of what we're working on for the operating system, a focus on how it impacts developers, and some recommendations for how to optimize your apps. Second, I want to talk about a new way to get involved and where the platform's going. And third, I want to talk about release schedules. No dates, but key developer milestones and how we can think about each one, so you can plan ahead. So let's start with what we're working on. You heard from Dave, you heard from Tian, security and privacy is a foundational commitment across Android and Play. And what's happening here is really important for us as developers. Now, Android's leading in everything from industry reports like Gartner to Zerodium announcing they'll pay more for Android exploits than any other mobile OS. But privacy and security is not one feature or moment. It's a continuous commitment and investment. I want you to know you should expect to see more protections coming. That's why we decided to preview here at Dev Summit. We'll have 4 dedicated sessions, so you can preview OS enhancements to permissions, storage protections, connected devices, and one more thing. For users, these give more transparency and control. For developers, they should be straightforward to implement. Your feedback on features like scope storage in Android 10 was fantastic. And learning from this, what we want to do is share this kind of information earlier than ever. We want to explain our reasoning, we want to get your feedback, and then give you as much detail as possible so you can plan ahead. So second, I want to talk about a new way that you can get involved. Dave talked about helpful innovation as one of the new work streams shaping the future of Android. On-device machine learning and federated learning are driving incredible breakthroughs, like the live caption that we talked about earlier this year. For the 500 million people who are deaf or hard of hearing, something like live caption can bring content to life. Now, these are the kind of innovations that we want to invest in. And we thought about it and decided we want to do this together with our developer community. Over 10 years ago, we announced our first Android Developer Challenge. Today, modern Android is shaping a next-generation platform. And so it seemed kind of fitting to announce the Android Developer Challenge is back. And the first Android Developer Challenge we're announcing will be helpful innovation and machine learning. We're asking all of you to submit ideas. We'll pick the top 10. We will then bring those teams to Google. You will meet leading experts in machine learning and Android from across the company. You will get an exclusive look at Android 11. And once your apps are ready, we'll share them in a collection on Google Play for billions of users to see. And yes, you will get insider tickets to Google I/O, because we'll bring the teams back to Google I/O to showcase your work. So we're very excited to see what you build, and I hope you join the Android Developer Challenge. So finally, I want to talk about how we release Android's operating system. Now, we've been rethinking this in order to make it better for you. What I hear from developers is, operating system changes have a huge impact on developers. And it's great that the platform is evolving, but you want to see us be very careful to minimize developer impact and also get insight into schedules. So here is a look at Android's new release schedule. For the next OS release, developer previews is where we'll begin. And this is because we think everything starts with developers. It's the best way we could think of to give you the advance notice and the time that you need. We started the previews a few years ago, and they have been great. So here's the point where we'll be actively adjusting APIs and features. Now, during developer previews, you should be kicking the tires and filing feedback. We'll give you a public release to flash your device, updated developer tools, and crucial docs. OK, then comes beta. Now, beta is when usage grows dramatically. In Android 10, we had 21 devices from 13 OEMs, and users can easily enroll online. And all of this means a lot of users. That's why at Beta 1, you should test and convert your app. Now, we thought about what we could do to help, and we decided to commit to giving you something we're calling a stability milestone, a close to final SDK by then, as well as the tools you need, including emulators and more. We're also committing to close to final APIs so you can convert efficiently on a stable platform. We'll move to API freeze and final SDK shortly after beta. Now, there may be a few exceptions to API freeze, but expect us to share those as fast as we possibly can. We've also recently added a new app compat feature to the Play console to help you analyze and migrate. Now, after beta, we move to RC and final release. And the final release every year is when we'll bump Target SDK. The SDK target requirement is N-1. So that means at Android 11, you'll target Android 10. This is designed to give you a year's notice. And wherever possible, we want to place developer impacting changes behind Target SDK. The goal is to move Android forward together while giving you the maximum time we can to adopt. So, OK, let's wrap up. That's been a quick tour of modern Android and the road ahead across our developer experiences, Play, and the platform. I really hope you download and try everything you heard about today, from Android Studio 4.0 to Compose and more. And we are very excited to have you here at Dev Summit today. Our goal is to share as much as we can of everything you need to know about Android. There'll be nearly 60 sessions. There are 100 speakers. We'll cover modern Android development from Compose to Kotlin. You can learn more about modern distribution. And we'll deep dive on platform changes, including things that are in the works in important areas like privacy. At the Sandbox, you will find over 250 members of the Android team. They're all here to meet you. And you can find out when your favorite team will be here just by looking in the Dev Summit app. The live stream will cover everything that happens on the main stage, plus interviews and more. So I'd like to thank you for your time today and ask you to enjoy Android Dev Summit. Thank you.
Okay, and I think we're live. So hello, welcome to the Android Dev Summit 2019 and very first ever Ask Android livestream. I'm Lila Fujiwara, and I'm an Android developer advocate.
And I'm Dan Galpin, also an Android developer advocate, and I'm Lila's manager. Which means I'm ultimately responsible for everything that I say and everything that she says.
Yep. All right, so let's get to it. Also a bit long, the hashtag AskAndroid team will be answering your questions on form factors, Jetpack Compose, Kotlin, coroutines, CameraX, community, architecture components, Android 10, and so much more.
How about tools? Yeah, Android Studio.
And tools, which is happening right now.
All right, so if you already have a burning question or you're excited about something you saw in the keynote, well, there's no need to wait. Tweet at #AskAndroid for a chance to see your questions answered live during the Android Developer Summit.
And you can also put your questions on the live stream, so either way. Okay, so finally, a big shout out to everybody that's participating on the live stream from around the world. I have a few countries here. Bangladesh, welcome, Kenya, Congo, Brazil, Indonesia, Germany, Netherlands, Pakistan, India, Nepal, Mexico, and the faraway land of Palo Alto.
We have a jam-packed show for you today, so let's get rolling.
All right, so first up, I think we already got a sneak peek, but we're chatting with Chet and Tor.
Now, in that order. Chet.
Yes, Chet and Tor.
So Tor is the tech lead for Android Studio, and he's our demo master, while Chet leads scalable outreach for Android after a long stint leading the Toolkit team and is an expert in graphics, UI, performance, and donuts. You can catch both of them regularly on the Android Developers Backstage podcast, which means they both love to talk. So let's, welcome Chet and Tor.
Okay, so go ahead and start asking your questions. We got one right off the bat. So keynote just happened. What was the favorite thing that you saw from the keynote?
I like seeing more about Compose on the screen, seeing a little bit more code and how stuff is put together.
That's it.
Well, I figured you were going to hour-long.
How it's composed.
You can add the other part of it, which is, but what about?
Well, clearly Android Studio 4.0.
Okay.
Right?
So you're going to talk about the tools for Compose. You're like, what is Compose without the Android?
Right, it is one of the many features in Studio 4.0. So we actually bumped major versions, right, from 3.6 to 4.0, and it's because we have a lot of awesome features. Compose is one of them, but there's many other things as well.
All right, so both of those things, if you want to check them out, you have to download Android Studio 4.0.
That's right.
All right.
Yeah. And people can play with the motion editor, is that true?
Yes, I think the motion editor is enabled in Canary 1.
Wow, that's exciting. All right, so we have a question from Andref Sousa, which is pronounced something like that. Is there a way to change the default Android emulator phone number and country code?
No.
That's a good question. I like that.
I asked the team. There isn't, and their question was like, why do you want that? So if it's a
when you tweet back at him, why do you want that?
They know this is not like a back and forth conversation, right? It's kind of
well, it's more, if we add a setting for every possible one user request, it will be kind of a mess of a UI. So we try to make sure that there's a really good use case for it. So if someone would make that case, then we would consider it, of course.
But I mean, mess of a UI, to me, that describes ADT.
Okay, so next question. Sorry with the names. Okay, so Hatorix asks, when are you planning to have a stable version of ViewPager 2?
Good time to ask that question. So it has been, it was alpha for quite a long time. It's been in several beta releases, and the hope is that it goes RC real soon now, which means exactly that, real soon now. And then at RC, the expectation for RC in general is that is basically the stable build. We want one last sanity check, so I would expect stable to fast follow sometime after that.
All right, sweet.
Okay, so we've got some questions that are coming in from the live stream. Any app security measurement tool coming in Android Studio?
Generally, we don't talk about future plans that we haven't announced.
Oh, okay, there we go. So, maybe not. That was from Amar D.
I have no announcement at this time.
That's a very secure way of putting that. I like that.
The advice that I tend to give in the fireside chat, which we're going to have another one of this afternoon, is if your question has words in it like, will you, or is the team going to, or will there be a feature? Like, it's
or
not
when.
something, you're not going to get joy out of the answer to that question.
Okay, so with that in mind, Jonathan CPS asks, are you guys working on a tool to show a preview screen for Jetpack Compose?
Yes, so I guess that question was submitted before the keynote because we just gave a demo of it. And so yes, preview is one of the core features of our Compose tooling in Android Studio 4.0.
All right, cool.
Okay, so here's a question. What is your favorite feature in Android Studio 4.0?
Can I reinterpret that to what are your top 5 features in 4.0?
Yeah, absolutely, please.
Because it's very difficult to choose one. Plus, I'll probably make some enemies on the team.
I was going to say, well, plus this way you can actually pitch multiple features to our audience. This is great.
Exactly. So in my top 5, the first one I would say is the build profiler, which we didn't show in the keynote. So there's going to be a demo later today, but it's basically going to let you see, profile your build to find out what your potential mistakes are, and how to optimize it to run faster.
So I assume, just to get a little more information, I assume that builds on what we've been seeing for a while, which is as it's doing builds, it's actually telling you how long it took to do each of those steps, right? So you're just getting this in a more visual way?
Yeah, but it's not just about showing how long each task took. We are looking, for example, we've instrumented more stuff into the build system, and we're looking for potential mistakes. So we can tell you, for example, hey, this task is, not is always running. It's not looking at its inputs. So that means that it'll always run even incrementally. So we're basically pinpointing a lot of analysis saying, here's a problem, here's how to fix it. So build attribution is one, motion editor is another one. You saw that in the keynote. It's a pretty great feature that people have been waiting for. Compose tooling, of course, is there. My second most favorite, I would say, is having the embedded terminal, the embedded emulator. So we had a little bit of a slip up in the demo in the keynote, but it's a really great feature, and it's just so much more convenient to be able to have the emulator participate in the window management of the IDE than having to sort of juggle top-level windows.
Yeah, I have an emulator that opens up on like a separate screen a lot of the time. So
and then Layout Inspector, which is has a lot of new features for. It's a bit like the Chrome DevTools, where you can sort of track down why is this font size the way it is, or what is the paint hierarchy looking like? Why do I have a clipping bug?
Yeah, I like the 3D thing. We saw a little bit of that in the demo in the keynote, right?
Yeah, and there's more as well. So we're going to do a 25-minute demo later today of a bunch more features in 4.0.
Awesome. And while we're still going, if you have questions about any of that, please post them to the live stream. Speaking of which, Nor from the live stream asks, is Kotlin good for enterprise?
Of course. Yeah, actually, I gave a talk about Kotlin, just Kotlin language in general, at a conference a few weeks ago, and it was a conference with mostly non-Android developers, and the room was packed. I would say probably a quarter of the people in the room were doing Android development. The rest of the people were using Kotlin on the back end. Enterprise, web, whatever.
And of course, I use Kotlin on the desktop, right? So Kotlin is not just for Android. So Android Studio, we have a lot of, basically almost all the new code we write is written in Kotlin as well, which runs, on your desktop.
Awesome. Yeah, and we actually have a Ask Android segment about Kotlin and coroutines that's coming up later. And the person who's basically helping organize Kotlin everywhere is going to be a part of that, so we can answer much more of those questions.
Yeah, so we have another question from the live stream, comes from Lulama. Has Android Studio improved in terms of speed?
I think clearly yes, right? So we spent the last year or 9 months working on something called Project Marble, where we focus exclusively on performance and stability, right? So there's many aspects to speed. I mean, if he or she means build speed, okay, obviously we're working on a profiler. But the things we did in Project Marble was reducing UI freezes, reducing memory usage, optimizing the way we were handling a bunch of calculations. Overall, speed was a big concern for us.
There was some specifics called out in the keynote as well, I think in Karen's section, talking about things like, well, incremental annotation processing got faster. Was that part of Marble?
That's build speed, yeah. It was. And I think another one that is maybe not so obvious is that Studio is happy if you give it more memory. Most users actually run with the default, which is about, I can't remember, 1.2 gigs of RAM. For large projects, that's just not enough. And so we actually give you suggestions as part of Marble. Hey, you should resize your heap to something bigger based on your machine and your project size. And if you accept that suggestion, you'll actually find Studio running much better.
Yeah, cool. All right, so I was going to do this one.
Oh, this one goes right into that last thing he was saying, though.
Okay, cool. So from Twitter, Pranay asks, with more and more features getting added to Android Studio, is there anything done to reduce the IDE memory footprint? Which, with each new release, AS is hogging more and more memory.
Requesting.
Kindly requesting more and more memory.
Right. So I just answered that. We work.
Wait.
So, that's what I thought. Yeah, so, all right, cool. All right, so
down
like
to our last
one.
questions. Yeah, so this one this one here.
Yeah.
Okay, so Adrian asked, in single or multiple activity implementation, which one is better?
Tricky question to answer. We are recommending that people move to single activity. So originally, Android was all about multiple activities. You go from place to place in your application flow, and new windows pop up. It's better user experience if you can stay within one activity. If you have deep links, maybe that's a multiple activity navigation situation.
Okay,
all right.
Cool. So I think that we are about to wrap up, but just with Chet and Tor, so thank you so much for joining us. Any last things to say to the live stream?
Hi.
Try Studio 4.0.
Okay, try Studio 4.0.
Check out the Android Developers Backstage podcast and submit your questions to #AskAndroid.
All right, so we're about to jump into, I think, like a 1 minute long break, and we are going to then be joined by Dave Burke and Steph, who are fresh for the main stage right after their keynote address. So please stay tuned.
If you're just joining us, welcome to the Android Dev Summit 2019 and the very first hashtag Ask Android livestream. Next up, coming straight from the main stage where they delivered the keynote address, are Dave Burke, Android's Engineering VP, and Director of Developer Experience, Steph Cuthbertson. Sorry,
Okay.
I know. You've been not saying it. I actually tried.
All right, so if you have any questions for the keynote or either of these folks, please remember to use the hashtag AskAndroid tag in the live stream. We have somebody who is actively grabbing your questions. All right, so with that, first question.
So what is your favorite announcement from the keynote?
Ooh, that's a tough one.
That is a tough one.
Can
I do an umbrella one, like Android Studio 4, I think? Because there's just so much good stuff in there. Like, I'm excited because it's the first time that we actually have Compose easily accessible, right? So you just download it and use it. There's also the style inspector or the layout inspector. I always call it the wrong thing, where you can actually find out why different styles are being applied. That's pretty cool. The build profiler. What am I forgetting? There's just some like motion editor.
Motion editor is really
We
cool.
just had Tor and Jet on, so Tor was talking about a lot of this stuff. I think we're pretty aligned.
Remember we had that discussion that was like 2 weeks ago, and you said to me, it was like, hey Dave, I think like there's a lot in this release, and like because we're going to call it 3.7.
That's right.
And
Yeah,
you were like
3.85 or something.
Yeah.
And we finally said, there's so much in here, we should just call it 4.0.
So I think that's the big one.
Yeah. I mean, obviously the announcements around Compose going to developer preview, like that's a very big deal. And I think it would be really exciting to have people try that out and give us feedback. So that'd be probably the easy one. I also, there's a bunch of other really cool things in there, I agree with Dave. Little things like the layout inspector, I think really speak to the attention to detail from the team. I think people have been asking for something like that for a long time when you're coding themes and styles and you're trying to figure out what the heck just happened. It's really, I think things that are both very big and then small. And also, I don't know, I'd say I'm pretty excited about the app bundles work too, because that's one of those things where just by adopting it, you get a bunch of goodness by default. Like just making your app smaller, that's pretty awesome.
Yeah, I'm actually really excited about the build profiler. Like that's been something we've been asking for a long time. So that's really, really cool too.
Yeah, that's super cool. Being able to find out like where your build time is actually getting eaten up, and it's really neat.
Okay, so next question, and this is, I don't know, I'm interested to see what your response will be. So Burhan Rashid 52 asks, why do we have a new Android OS version every year? Can we slow down a bit?
It's
an interesting question.
It's job security. Do something
for all of us.
Well, I mean, the first I would say, more seriously, it's like we got to understand why the question was asked. But I would say, technology evolves at such a fast pace, right? Like, so you've got to constantly keep up with that. And so, for example, we talked today about foldables, right? And so this is actually a really exciting space. And I think over the next few years, you're going to see some pretty amazing devices. It's early, and I think it's one of those things where some folks are like, oh, I see something there, I'm not sure, but it's going to be exciting. And so we have to evolve the operating system to make sure that we keep up with technology or even lead it. I think the question probably gets more to the fact that like when there's a new operating system release, like it can be sometimes effort to update to it. And
I think that's what developers are really asking. Is I think the question is, how can you make it easy for us to adopt and not disrupt us? And I do think that is a really important consideration. It's a big part of why we did something that was a little unprecedented today, which is we wanted to share, look, here's how we think about the platform milestones for people to prepare, as well as starting to talk about things like OS resiliency and where we're going with permissions. We've never talked about those so early. And the reason is because we want to give people a chance to give us feedback as well as adapt. Because I think it's a question of both being very thoughtful about any breaking change, keeping them to an absolute minimum. I think of it as few as possible and no less. Because as Dave said, there is also, with the evolution of foldables, what's happening with machine learning, like the platform is going to evolve, and that's a big part of why we love Android. It's just about finding the right balance.
The only constant is change. That's basically what's happening here. But I think that's exactly right. And we spend a lot of time on app compatibility. That's our phrase for like making sure that we haven't broken anything, right? And we're getting better at it. I'm not going to pretend we're perfect at it, but we're getting better at it and putting more effort into that. But it's a great question.
So another question we have is from Puneet99. What is Project Mainline, and how is it different from Project Treble?
Okay, so it's they're orthogonal in a graphical sense. So, so Project Treble was all about putting a horizontal line between the hardware-specific code, and when I say hardware, I mean silicon-specific, so what SoC you have, and then like actual the peripherals that your particular device may have. So it's a horizontal line between the hardware-specific code and then the operating system code. And that was one of those things that, ideally, when we created the operating system, like in 1.0, you would have put that in place, but Android was moving so fast, and it wasn't worth doing. It was better to go quickly. Later, we put this foundation in, and it means now when a new version of the operating system comes out, it will work on the older code from the hardware, and it just allows developers to move or device makers to move much more quickly. And you saw that with the beta program for Q, Android 10, where we had like 21 devices from 13 OEMs, right? So it works. Mainline, think of it as, and this is why I meant orthogonal, think of it as vertical lines. And so they're like pieces of the operating system on top of Treble that you can then slice out and then update. And I'm excited about, so they're complementary. I'm excited about mainline because it means we can take sort of, I would say like boring parts of the operating system, like cryptography, which, there's some cool math there, by the way, but it, boring from a typical developer. You just expect it to work. And so I think this allows us to basically update those components and have uniformity across different devices.
Okay, and I think we are literally just about out of time. So I want to, we have a little bit of time to really thank Dave and Steph for coming on and talking to us, talking to all of you. Is
there any last thing you want to say to the live stream?
We should
so much.
So much. We can talk for hours.
Very short last thing.
I want to talk about. Thank you for being here. I think I mostly would just be wanting to say thank you so much to everyone for being a part of Dev Summit, for all the feedback. We're really grateful.
Yeah.
All right, well, that concludes this portion of the hashtag Ask Android live stream. Our next speaking session is about to start, and another Ask Android will follow. So next time we'll be answering your questions about Jetpack Compose.
All right, so remember to post your questions. Bye.
Thank you.
Good morning and welcome to What's New in Jetpack Compose. I don't know why it's called that because this is not really what the talk is about. It's more what is Jetpack Compose. Anyway, I'm Romain Guy. I manage the Android Toolkit team at Google.
I'm Clara Vallarri. I'm a tech lead on the Toolkit.
And I'm Adam Powell, and I'm also a tech lead on the Toolkit.
And the Toolkit now is also Jetpack Compose. My clicker, I need that. All right. So what is Jetpack Compose, the real title? So according to developer.android.com, Jetpack Compose is a modern toolkit for building native Android UIs, and it simplifies and accelerates UI development, blah, blah, blah. So in Kotlin. So instead of trying to tell you what it is, I think it's more useful if we try to tell you what kind of problems we're trying to solve, what kind of goals we're trying to achieve with Jetpack Compose. We did some of that, and look, it's me again, same shirt, same pants, different watch.
Consistency, it's good.
Yes. Adam and Jim were with me on stage, and they did most of the talking, so we explained some of the reasoning, and I wanted to go over other points. The first one for us is to simplify the development, and we all got used to the complexity of Android development, and the complexity can mean many different things. Some of our APIs are really awkward to use, you have to manipulate different files, different languages. So I want to show you an actual example. So that's something that Jim works on the Compose compiler and runtime came up with to try to convince a bunch of people internally that Compose is a good thing. So the idea is to build a simple app where you have a list of names and you just want to type something at the top and it's going to filter the list. So how would you do that with the existing UI toolkit? You start with a simple XML file. You're all used to that, a recycler view, edit text, linear layout, all that good stuff. Then you need another XML file for each list item in the list. So we already have a couple files in XML. Then you need your filtered list view that's just going to do the find view by ID, find the edit text, set up the listeners, find the recycler view, set up the adapter. I'm not even showing the activity here. Finally, you need the adapter itself. So actually, it's funny because when I put that on the slide, I'm like, wait, is that the best way we have to filter a list? So I Googled it, and turns out, because I did write some of the filtering APIs for adapters, so I thought there was a better way. It turns out there's not really, and there's a lot of blog posts, articles, and even Stack Overflow questions on how to do this. I'm proud to announce that this is one of the simpler ways. And then you can use RxJava or fancy frameworks to make this happen. Anyway, that's a lot of code. It's annoying. It is not simple. So this is the entire Compose version. All the code you need is here on screen. Much easier. It's going to be a lot easier to find bugs. And more importantly, when you read the code, it's pretty obvious what the intent of the code is. Like whoever wrote that code, what they wanted to do. So you say, I want a scroller. I want a column of text fields. I want a column with a text field at the top, and for each row, I want an image and piece of text. And as soon as you change the content of the list, the contact list, everything updates as you would expect. Another thing we want to do is fix what's broken. So that's our API regrets. We talked about this at Google I/O. I invite you to watch the talk if you want to know more. We had a few funny anecdotes. One of the good ones, of course, is Vue.java that now clocks at around 30,000 lines of code. Sure, there's a lot of comments in there, but still.
I think it's down from some point.
Yeah, but still, it's a lot. So the plan for us is, also we have a lot of baggage and history. So there are things that we just cannot fix. We know there are problems, but we just can't fix them. We could introduce new bugs, or apps may be relying on the current behavior. So we're kind of stuck. We can't really do much more with the existing UI toolkit. We want to stop cheating. This is something we did originally, and I think Adam recently, you said on the Kotlin Like Slack channel that you really, really want @hide to disappear. So if you ever looked at the source code of the Android platform, we have this magical annotation called @hide, which turns public APIs into very private APIs. And super useful to us. It was a way to work around some of the limitations of the Java programming language, but it led over the years, it led to an issue for us. For instance, let's say you want to do something with TextView that TextView doesn't do out of the box. The obvious answer is like, write your own TextView. Well, you start pulling that thread, and then you're grabbing like the entire text package, and you're running to private APIs all over the place, and you can't do anything about it. So that's an issue for us, and that's an issue for us. So what we want to do with Compose is we don't want to rely on private APIs anymore. We kind of have to at the low level to interact with the platform, but all of our widgets are built entirely using public APIs that are available to you. And I'm going to show you actually an example of that.
And the good news is that it's kind of forming a forcing function for us to open more things in the platform itself along the way.
And we have to think a little harder about what we open. Material and animations. I had a pretty heart emoji on the slide. It's gone. Anyway, I like hearts. Anyway, so we want, now we're in the material design world. The existing UI toolkit was built before material design was a thing. So the good news is now we can take material design into account. This is what Clara and her team do in London. And we also are building animations, in strong collaboration with the rest of the Compose UI toolkit. So we expect it's going to be easier and more powerful than it was in the existing one. Tools plus Compose, same thing. When we built the initial UI toolkit, the existing one, there was not that much interaction with the tools team because the tools team was very small. So a lot of the tools came after the fact. So the visual editor, the motion layout that you saw in the keynote. And we want to change that. And you just saw that we're building things like live previews of your composable right now as we're building Compose itself. Kotlin, we adopted Kotlin. We announced that we want to go Kotlin first. So that would be one thing for us to tell you to go Kotlin first. And we thought that maybe it was a good idea to do what we say that you should do. So Compose is written in Kotlin. And Kotlin actually unlocks a lot of the things that we do in Compose. The way we design the API is possible thanks to Kotlin. We rely heavily on lambdas, for instance. And we plan on using fun features like coroutines. Adam is chomping at the bits to add coroutines all over Compose. And finally, compatibility is something that we deeply care about. We are not asking you to rewrite your entire app. If you want to adopt Compose, once it's ready for production, we don't expect you to just delete all the code like we did for Instant Run and to start from scratch. We want you to write your next activity or your next fragment or to be able to reuse some of your custom views. And chances are that some of the existing views we won't even rewrite ourselves. So things like Surface View or Web View. I don't think, if any of you wants to write a new Web View, please come help us, but we're not going to do that. So we're going to use the existing web view. All right, and finally, this is what the technical stack of Compose looks like. So on one side, we have the build time stack, so that's on the host, what runs on your machine. So we use a slightly modified code version of the Kotlin compiler. So we work closely with JetBrains. We just added a couple of compiler extensions in collaboration with them. And we use those extensions to enable our Compose compiler plugin. So it's funny because last week, people saw that we had the artifacts on Maven for Compose, and people started using them, and they're like, oh, great, it works. We're like, no, it doesn't work. You need the compiler that we haven't released yet. They're like, no, it works. The reason it seems to work is because the syntax is just pure Kotlin, so it's just invoking functions. It was just not very reactive at all, which is kind of a bummer. Anyway, so we also have Android Studio, and then on the runtime side, so Compose at the bottom is a runtime that just deals with trees. It knows how to produce trees. It doesn't know anything about UI toolkit, so we could reuse it to do other things than UI. Then we have the UI core, the UI foundations, and finally on top, all the widgets. So that's pretty much it. And now Clara will tell you more about how Compose actually works when you write code.
Thank you. So I want to walk you through, sorry, get your applause. I want to walk you through some of the things that you need to understand to really be able to play with Compose, some of the basic concepts. The first one is composable functions. I know Roman has kind of thrown this term out a few times, but a composable function is just a function. It's a function that takes some input and just decides what UI to show based on that input. So in a way, it transforms your application data into your UI hierarchy. Creating a composable function is very, very easy. So for example, we have this greeting composable. It takes a name as a string, and it just decides to emit a text element that uses that string. Text is one of the components that we will provide for you. It is the equivalent of a text view, so it shows a text on the screen. The interesting thing here is because we have the runtime and the compiler behind us, whenever you change that input to say the name you're going to pass through changes, well, then we take care of figuring out what change, re-invoke the function, figure out what we need to change in the UI hierarchy for you. So at any point, you are just describing what you want to see, and we'll take care of the rest. Say, for example, we want to build a news story. We can actually emit several composables within a composable function. So we can emit, say, a title, subtitle, and a date, and we're just going to build our news story. This is absolutely fine, but you will find you kind of need to have an opinion on how you want your UI to show, because if you just do this, you will end up with something like this, which is not really what you wanted. So this is where concept number 2, layouts, come in. We are building out a bunch of layouts for you out of the box to make sure that you can place things on screen as much as you want. So for example, we can wrap those 3 texts in a column. Column is the equivalent of a vertical linear layout, so we'll just place everything one on top of the other. So then suddenly, this looks more like what we were expecting, right? So we have our title, subtitle, and date. Still, Android developers are used to being able to customize a lot of things. You'll be like, oh, you know, this is nice, but my text is really stuck to the side of the screen. So we can go a bit further, add some spacing. And what that will do is just create the spacing around it that we need to make it look a bit better. So until now, we've built this entire UI just with like one function, right? Going a bit further, like column doesn't just take text. I know I used 3 texts as an example, but we can throw anything in there. So for example, we can just display an image by using an image composable, and then build up our UI in this way. Oh yes, sorry. We're providing a bunch of layouts out of the box. There you go. We have row, which will place things horizontally. We have column, which will place things vertically. Those are easy to understand. We have more advanced things. For example, we've introduced flex, which I believe is new to Android. We're building a bunch more. There's a bunch more in there that you can go and play with. And we are working on constraint layout, but it's just not there yet. So look forward to that coming. And then, well, we've built a layout, but really what you want is for us to build components for you, right? So Compose comes with a bunch of built-in components that should make it really easy for you to get kick-started. First of all, we've partnered very heavily with the material team, because we want to make sure material is out of the box, just there for you. So we started creating the material components. They're not all there yet, but the team has already been hard at work to be able to create those beautiful UIs, and we already have things like buttons, checkboxes, and a bit more complex things, app bars, drawers. Some of these pieces are in there. In Flux, we'll get there, but you already have the basic pieces to build something like a sample app. So say we want to build this material card, building up on the example we had before with the image and the 3 texts. Well, we'll take the code we've had before. I haven't changed anything. We wrap it in a card, and we can give a card a shape, because it's a material thing that you can choose what your corner should look like. So for example, I want rounded corners on my card. we can style the text to look prettier than it was before with the 3 same styles. And you'll say, here, you're reaching into a theme text style. This looks a bit weird. So let's take a step back to the material spec. So in the material spec, there's a definition of all the typographies that you could define in your app. So how you define all the styling of your entire app. There's a preset amount of text styles that you could use, just like they have a color system and a shape system. We've built this out of the box for you. So if you buy into the material system, we have a material theme composable that allows you to configure all of the colors, all of the typography, all of the shapes you need for your app. And then when you put this in your hierarchy, any other material component you're using will know how to read all these values by default, so you don't have to actually style them. Similarly, you can reach into these values, and that's what I'm doing in this example. So I'm saying, out of these 3 texts, I'm reaching into the style and saying I want H6, subtitle 1, and body 1. And it's a very easy way to style if you've set up all your styling for your app correctly. And finally, to finish the app, I can add a row with a couple of buttons. Again, we've provided the material implementations of buttons. So material defines 3 different kinds of buttons. There's contained, outline, and text buttons. And you will find that we keep the same terminology to make it easy to find things. So we have contained buttons, outline buttons, and text buttons available. So all of the material components we provide, we've built purely on the public API from layers below us. So Compose UI Core provides some foundation for us, and we've built everything layered up on top of that. So we've tried to not cheat with any private APIs. This means that Material should be a showcase of how you can build components. So we're hoping they're samples, right? Like, they're very useful components, but at the same time, it should be code that you can go in and read and see how we've done it and take those examples for yourself. We've also tried to break everything down into multiple layers, because you can break everything into more and more functions to make sure there's as many reusable bits in there as possible for everyone. And as part of that, we've created this foundation level in the middle. The main idea there is there's a lot of material that is not necessarily design specific. There'll be a bunch of gestures, accessibility that we've implemented to do a button, so we can put the actual button in material, but then we can put the internals of the button in foundation, so all the gestures, accessibility, other things that we've built that are not UI, so that you don't have to start from scratch. You can already start from that layer and just build your UI on top. And then no matter how many components we give you, there's always going to be custom views that you want to do. There's always going to be that designer that asks for a very strange thing that we had never anticipated. So in the existing toolkit, you have to extend view. You have to take care of a bunch of things. It's a lot of work to create a custom view. In Compose, it's extremely simple. You just have to create a function. And there's some building blocks that you can do to help you build up that custom view. The two basic ones are draw and layout. So draw will give you a handle into doing any kind of custom coding that you want. Say, for example, we want to do a checkbox. And a checkbox is just a square with rounded corners and a check mark, right? Let me walk you through the code to do this, because it's quite simple. To draw the box, we open a draw tag. We get access to a canvas and the sizes we've been measured to. So we can easily calculate how much do we want our square to be, apply the rounded corners, and then just draw the square. Same for the checkbox. For the check mark, we'll open a draw. We have access to the canvas and the size. We can calculate the 3 points that make a check mark, and then just draw those on the screen. So surprisingly simple. The next part is layout. Of course, we will try to provide as many layouts as we can out of the box. There will be always something that you want to do that is extremely custom. Well, you can reach down into the layout component. I've tried to show here an example. The most simple example I could find is a stack or a frame layout, right? Like stacking things one on top of the other. So you will create a function that takes a bunch of children that it needs to place. We open a layout tag. We get access to these children that are measurable pieces and all the constraints we have. And then we just have to go through 2 easy steps. We measure each of the children to make sure we know what size they want to be. And then we decide what size we want to be. So for example, in a stack, I'll probably want the maximum of the children to make sure they all fit. And then I'll place them each at the 0, 0 coordinate, because that's what a stack would do. So then we'll end up with an effect that is something like this. Hand over to Ramon.
All right. So what we have today. Like mentioned in the keynote, we just released our developer preview. It's called 0.1.0-dev02. So if not fair enough, it is not quite ready for production. But I want to show you some code and a demo. So if you can switch to the demo machine, please. All right. So one of the sample apps we have is called Jet News. You can see it on the right in the emulator. So it gives you a good idea of the kind of things you can already build today We have horizontal scrolling list, vertical scrolling list. The text stack is already pretty advanced, so you can do a lot of complex text layouting and styling. So this is a very interesting app to look at. It's not a real app, like it's not connected to a database or web service to keep the sample simple, but it's a very good example of how to create your own widgets and to use the existing widgets. So what I wanted to show you is what you see here. So yesterday, I built this little to-do list app. So I have a little fab icon in the bottom right, and when you click on it, I just want to add list items. And each list item will have a little bookmark icon that I want to be able to toggle. So the way it works here, my data model is a simple data class in Kotlin. Is the text big enough, by the way, on the screen for everyone? All right, I'll assume it's a yes. So we have a data class. It's immutable. Everything's a val, and you can see that an item can be a favorite and just has a description and an ID. Then the actual model for the app is just this empty list of to-do items. And it's going to be an immutable list. And I wrapped it into this object. That's probably not how you would do it in a real app, like using an object like this, a global object. But I use this @model annotation. And the @model basically turns this object into an observable object. So whenever I change the item's property, the UI will recompose automatically, and Adam will tell you more about this. And if you want to know even more details, Leland has a talk tomorrow where he explains how it works internally in the compiler. This is the main part of the application, so very similar to what we saw earlier in the keynote. I have a vertical scroller, I have a column, I just iterate over all the items, and then for each item I create a row. You can ignore the layout parameters. But I have this bookmark icon, so this is a composable I created. And one of the things I really like about Compose, and that was one of the things we really wanted to do, we wanted to make it easy to create your own widgets. Like very often in Android applications, we end up with very large XML files because it's very cumbersome to create all those XML files, doing the find you by ID, doing the includes and the merge and all that stuff. And here, all you have to do is, like when I first wrote this application, I wrote everything into this items composable. And then when I saw that I had this bookmark icon composable, I just selected it, I extracted a method using a refactor in IntelliJ, and I just added my @composable annotation. And that's all you need to do to create a new component. You don't have to extend from view or view group and override methods. And then I just have a small spacer, and finally the piece of text that describes the item. So the bookmark icon is here, and here you can see another interesting, oops, I'm revealing what I'm gonna type. That's my cheat in case I forget what to do. So my bookmark icon is pretty simple. It takes one of those to-do items. It's wrapped by a clickable, so that's how you create a click listener, really. And inside, all I do is I have this branch, and I say, if this item is a favorite, then I want to show the image that corresponds to the favorite state. And if it's not a favorite, I want to use the other image. So it shows you that it's not just about using for loops, for instance, for each. You can use like any kind of control flow you want, and it makes the code extremely easy to read. And you could do this piece of code in different ways. Anyway, so I have two callbacks in the app. I have this toggle favorite when we're going to click the bookmark icon, and I also have one when we click the fab. So I'm going to try to write them. So when we add an item, I'm going to take the list of items, and I'm going to add a new item that I conveniently have in my clipboard. So we just give a default string and an ID. So if I rerun that, and you can note that's all I did, right? Like there's no listener, I don't call relayout, request layout, or invalidates. And when I click the button, a new item appears in the list. And that's all you have to do. And that's thanks to this @model right here, because we observe that the items are changing. But now I want to be able to toggle those little bookmarks. Like when I click right now, nothing happens. So the way I'm doing it is because it's an immutable list. Let's see if I remember. So I'm going to do a map. I feel so fancy when I do functional programming. Let's see. So if it.id equals the item we clicked, ID, then I will return a copy, and I will do favorite equals not to do.favorite. So I'm just toggling the Boolean. Otherwise, I just leave the item unmodified. All right, that should work. Relaunch the app. So add a few items, and now when I click, it toggles the icon, yay. Oh. And that's why Always be prepared. All right. I will make it work. Oh yeah, you used the wrong item. All right, add items, bookmark. Yes, all right, now it works. So again, like the point here is to show you like how easy it is to manipulate your data and to build that logic and make it interact with the UI. And more importantly, like you can keep like both kind of separated or more separated than you could before. But Adam will tell you a lot more about that. Can you go back to the slides, please?
Thank you. All right, so this is the part of the talk where we talk a little bit more about kind of our design thinking behind Compose and kind of what's on our mind. So in addition to the team's ongoing work with Compose, we've also been spending a lot of time talking with the community. Some of you have probably been part of that conversation, as well as running some more formal user studies. And so here are some of the things that are really sort of top of mind for us that we're excited about or that we think is really kind of important as you take it for a test drive. So be careful that some of this isn't implemented yet. This is just kind of how we're thinking about some of these open questions. So please join us in kind of participating in some of the design process. So the first thing that really kind of hits you as soon as you start working with Compose is the data flow. And while some of the tools available for managing that data flow came into Compose very early, or they existed before Compose did in the case of just some of the standard functional and reactive systems that you might be used to, the best practices and teaching materials around all of this is still kind of a work in progress. Like we really are building something new here. So the Android architecture components libraries have been really successful so far, and it set the stage nicely and established patterns that we've continued with in Compose itself. So let's go ahead and distill down some of those ideas and kind of see where they lead us. Next. There we go. So we showed this diagram at Google I/O during our talk on Compose there. Data flow is really kind of the first thing that you encounter, like I said. The shape of the API more or less enforces this top-down one-way data flow approach. It's just functions calling functions. And most people like this so far, so it's always good to have a single source of truth in your UI. And it's kind of frustrating when your views have a different idea about the state of your app than your application model does, which is definitely the case when you're working with views in the average Android app. So what do we mean when we talk about single source of truth in a UI? Well, it's about avoiding conflicts or making sure that you're not showing inconsistent data, but it's also kind of about who has write permissions to that state. So with Compose, you prevent inconsistencies by having the owner of a piece of state pass that state to the other composable functions that need it. So the parameters that we call our composable functions with, they have to come from somewhere, and the source of that data is kind of our source of truth by definition. And the interface that we use to pass those parameters really kind of determines what the composable functions can do with it, just like with any other function. So you see access control layering like this in Kotlin frequently in the standard library. You've got the list interface here, which only defines the read methods, but the methods to actually change that state are defined in mutable list. So even if I have a mutable list, if I pass it to a function like the aptly named doStuff over here, as the read-only list interface, I can be reasonably sure that doStuff isn't going to change my data out from under me. So from a certain point of view, source of truth has to do with who has access to a mutable reference to that source of truth and what kind of mutations a caller can perform with that reference. If you can change the source of truth, or if you can change the truth in any way that you want, are you yourself a source of it? Well, kind of. So we use event handler lambdas kind of liberally throughout Compose because it's kind of a more restricted way to express a very specific mutation that you can make to state without actually giving away the keys in the process. So here's kind of what I mean by that. We can show this just by using views with some of the APIs that you're used to. So here I've just added a click listener to the view, and inside that listener, I'm using the fact that I have access to this myList variable from the example before, and that's our mutable list. So that's in my lexical scope, so I can capture it as part of the listener block and just use it directly. I haven't actually leaked a mutable reference outside of this code snippet. Like the block where this appears is the only place where mutable list is accessible from anything. I haven't permitted mutation in any sort of uncontrolled ways by giving out a reference to it. So all my view can do is just tell me that a click happened, and I've defined how this higher level will respond to those clicks given this layer's access level. So this is a really simple example, and we're just kind of using lists, and we definitely did so in the demo as well, as sort of a hand wave for, hey, this is the rest of the app model. I mean, clearly you'll be doing something a little bit more sophisticated than direct mutations on lists, so bear with us a little bit. So a more real example might do something kind of like this. So in this sort of sample view binding method, I'm setting a click listener that makes some requests to my app based on the parameters that I was passed when the bind happened. So just like before with the mutable list, I didn't teach buttons how to add and remove bookmarks. I defined what a bound button should do when the button raises a click event. And I used the context that was available to me when I bound it, that's just the lexical scope, to form that definition. So this is all pretty standard stuff, so what's actually new here? I mean, this isn't unique to Compose here. But it's kind of the framing for what comes next, which is that Compose code is really, really dense. Like, we think that this is pretty great that you can remove so much boilerplate, but the trade-off for that is that sometimes the distinctions of what you're really doing become kind of subtle when it's compressed into such a small space. So let's look at the same pattern that we just saw using Compose. In this case, it's not actually that much smaller. It doesn't look that much different. We're declaring the actual button as an implementation detail along with its properties. So what its text is and what will happen when it's clicked, same thing. But the syntax here is kind of interesting. We said before that state flows down and events flow up, but we're passing both text and the onClick handler to button in the same way. They're both parameters. So in a way, event handlers are just another kind of state that flows down. It's state that the bookmark button created and that it owns. So as far as button is concerned, it's just this opaque token that can be invoked. So when it is clicked, we make a request to this bookmarker object that's not yet defined here to please add or remove the associated bookmark in response. So the bookmarker might be backed by a local database, API calls to some backend, really whatever. I can fake it or test it outside the context of my UI. But I've defined how the UI itself interacts with the bookmarker in one place here, along with the structure of the UI that's being manipulated. So bookmarker can be written to expose whatever operations that are appropriate to its clients like this one. So the single source of truth here is preserved. So that's a single snapshot of that truth. But the real power of a declarative UI framework like Compose is that it can keep up with changes over time. So it'd be really nice if my code was always this straightforward, even when time is involved and when changes over time is involved. So we saw a little bit of that in the demo so far. So if you want to update the UI in response to changes, well, you need your data to be observable. And Compose is ready for that. We saw in the demo that when you annotate a class with @model, that Compose will know when its properties change. But why did we add something new here? The Android ecosystem has a lot of existing observable constructs, so what gains do we get from this that justify adding something new? Well, we think that the answer lies somewhere between the ease of understanding of the kind of code that we can write this way, and also just kind of the ergonomics of actually using it in practice. So let's talk about live data for a moment, because it really has some neat properties for building UI. Fundamentally, live data is a single value holder that'll tell you when it's updated. So for our purposes in a UI, only the latest value matters. Live data will conflate its values and only keeps the latest one. There's no such thing as missing an event. You don't actually have an event stream. There's only the latest state. And @model behaves much in the same way in this regard. Maybe? There we go. So let's take another look at an example, kind of like the bookmarks code from before. If you've worked with Android architecture components, view model, and live data, you've probably seen something like this before. The view model sort of becomes this hub for a bunch of different observable data, along with some operations to request some changes to that data. So we can reflect the same sort of structure with @model, but you can see something kind of different here. So the hasBookmark method that we used in the example before, it isn't returning a mapped live data that has to be individually observed. It's just accessing internal object state. The list of bookmarks itself isn't even public. @model has turned any normal reads of the object's properties that happen within a special scope into observable subscriptions, even if that read happens layers down the call stack. If I called hasBookmark through some other helper function that I extracted in a refactoring or something like that, even in a completely different class, this would still work. We don't have to turn it into a stream or live data mappings each step of the way. So if we take a look back at our bookmark button from before, we see that our UI can be expressed in terms of these snapshots of state and time, and Compose can help manage the complexity of wiring these subscriptions together for us, even if the actual @model objects might be several layers away across the call stack or across an object reference chain. So Compose will automatically insert these observable scopes for us in composable functions. We don't even have to think about it. So let's go ahead and recap on that. So we need observable data. Compose will add @model classes as a new tool that we have available. But the cool thing about it is that it allows for this sort of cross-cutting observability. So we can write less plumbing and subscription management code in our apps. But The thing is that all these other observable and reactive systems are great. You don't have to leave them behind if they're a natural fit for what you're doing, especially if it makes sense in other layers of your application. So if it makes more sense for the bookmarker at this particular layer that I've defined it to return a live data or flow or something from hasBookmark, then we can still support automated but explicit subscription management by using an effect function, kind of like this. One more. There we go. So that's kind of the tour of the background behind some of that. So really what's left for us around data flow is kind of documenting recommendations for the question that's kind of left that you're probably all asking yourself, which is, which of these tools should I use when? So kind of establishing some of these guidelines and best practices are still kind of a work in progress here. So more things that are work in progress. I hear a lot of questions about how to work with resources in Compose and kind of what we plan to do there. So let's talk a little bit about that too. Again, this is current thinking, subject to change, but this is kind of where our heads are at the moment. So when it comes to using resources in a UI toolkit, we kind of think that we've learned a few things along the way, and this is kind of a big one. So really, we need to avoid too many overloads. Some of you might recognize where these are from. We have a lot of ways to set an image.
It's a convenience.
It's very convenient. But the thing is that this makes the view in question huge in terms of its own implementation, but even worse, it means anything that tries to wrap or reuse one of these in a composable fashion has to reflect the whole capabilities of the API surface. We don't want this. So it's annoying for us to maintain, and it's even more annoying for anyone who wants to build something on top. Now, there are a lot of reasons why you might want to offer overloads for your own composable functions, and we would really be doing you a disservice by asking you to multiply that by the number of overloads that you might need to cover for this form of completeness, because some underlying piece that you're relying on offered all of these different ways of doing a single thing. So that's something that we'd kind of like to avoid. So we've also seen a lot of other libraries appear to fill the gaps in between what Android views offer and what you need in your app. So image loading libraries are a really great example of this. There's a bunch of great ones out there. And they apply different loading and caching policies for images, tie into lifecycle, so on and so forth. But really, this is because a lot of resources are dynamic. They might come from the web. They might come from a disk cache or plenty of other places. And tying into the appropriate lifecycle events as signals, it's really not always fun. There's a lot to get right. So by focusing so much on static resources in what we offered, we kind of created this privileged type of data. It created a blind spot for us when we were looking at the system kind of from the inside. And it should be much more straightforward to write these dynamic resource policy layers, and static resources should have to play by the same rules, so using the same public API surfaces to operate. So coroutines are awesome. Ramon mentioned sometimes I won't shut up.
Yeah, you never shut up about it. You're not the only one.
There are more. So we still have a few issues to work out with the experimental compiler around generating suspending code. So we haven't done a whole lot here yet, but our intention is to standardize on coroutines as our async primitive for working with resource loading, whether that's static or dynamic. So Android's R class is also pretty convenient. Having a bunch of symbols that'll autocomplete for the resources in your app is pretty nice. We'd like to keep that sort of convenience, but really all of them being ints is not so convenient.
And I ran into that yesterday while building that demo. I would get a crash because I had the PNG files and an XML file with the same name, so the runtime would pick the XML file and try to load it as a bitmap, and
yeah, you had some fun with that.
It took us 5 minutes to figure it out, and we wrote the goddamn thing.
All right, I think that we might be able to squeeze one more into this list if someone will get out of the way there. OK, so layering is a pretty great idea, too, because once we start talking about type safety and resources and avoiding overloads, the natural question comes up, why should any of this be specific to Compose? We're really kind of looking at how working with APK resources might be made better whether you're using Compose or not. And while we're talking about things that are great whether you're using Compose or not, let's go ahead and talk a little bit about view compatibility. So we like Kotlin itself so much because you can adopt it in an existing project at your own pace, incrementally, just a little bit at a time, one class at a time, one test at a time, et cetera. So we're designing Compose to be used in the same way. So if you have an Android app today, you probably have a lot of views, layouts, maybe even fragments that you've extensively tested, so they work. Even once Compose graduates to a stable release, rewriting your existing and working code up front probably doesn't sound so great, so you don't have to. So let's take a look at a couple of the things that we have in mind here and how this might look once we spend a little bit more time here. So the first step in interop for us is being able to use just a little bit of Compose inside an existing app. The API for this is about as simple as it gets. It's just one annotation. And this may look familiar if you saw our talk from I/O earlier, that you'll be able to annotate a composable function. It'll ask the Compose compiler to generate a Vue subclass for you. This will host an instance of that composable function with appropriate setters, so on and so forth, that you can use to feed it data in the same way that you would via its parameters. So this will let you use Compose alongside your existing Vue-based UI. So this still isn't implemented yet, but we're pretty confident that this is the way to go. And it's kind of the way that things always go, right? It's like the things that you're most sure about are the things that you do last. So.
Well, someone has started working on this, it's just not finished.
Right. So the next step is a little bit less certain, and this is something that we're going to be doing some prototyping on. You can follow along with us in AOSP as we kind of play with some different ideas. So even if you dive into Compose head first, you'll probably still need to use views within that UI at some point. Maybe you're integrating a third-party SDK that doesn't offer Compose integration yet. You still want to be able to use it. So one idea that we've had is to leverage the new view binding feature that you might have seen in recent Android Studio builds. So if you're not familiar with it, if you have a layout XML file that looks something like this, view binding will generate some code that lets you consume it like this. So you get a type-safe object generated for you that you can use to bind values and listeners to it in code. So you could imagine that turning into something maybe like this when you use it from Compose. While this might be nice for giving life to some layouts that you've already set up, it implies some additional work if you just want to use one custom view. Another idea is that we could use the composition system itself to directly manage a view hierarchy. The Compose compiler and composition runtime were originally designed to manipulate the view tree directly. So here, rather than reusing layouts, you could use any existing view subclass as if it were native to Compose UI. But a limitation that this has is that it might make things look a little bit too similar. There's really a lot of mismatches at the boundaries, and some things, like most notably edit text, comes along with a lot of gotchas when you're trying to use it in this sort of reactive style where the single source of truth lives outside of that view. So the existing view implementations still fundamentally want to own their state, and layout contracts work differently, so on and so forth. So we're trying to figure out like what the right balance is with some of these things. So this, like some of the other design spaces that we just talked about, are going to be occupying a good bit of our time over the coming weeks. So we want to be sure that interop with your existing code is as straightforward as we can make it while not leading you down a path that ends up creating additional work if your constraints change. So we'll keep you updated as development continues, but hopefully by now you're asking another question.
So you've heard what we can do, you've heard what we're trying to get to do, but how do you play with it? Well, today we've published a brand new website, so d.android.com/jetpackcompose. We've updated the content in the Jetpack Compose website, including, for example, how to file bugs, so please go check that out. As part of that content, we've published a tutorial, and the tutorial will guide you through the basic principles of Compose, kind of similar to what we've done today, but much more in detail, so please go check that out. You can read through it, and it will make sense. Or you could go and download the new Android Studio build that supports Jetpack Compose. It should be up soon, I think. You will also get a new template. We have a template for a Compose activity that will set up all your dependencies and everything, so you don't need to go read random blog posts that will tell you how to set it up. You can try the new preview that we showcased at the keynote. You'll be able to preview what you're building with Compose. You'll be able to see the sample. So we published Jet News as our sample. It showcased everything that is there now and how you can use it to build this news article app. And then other things that you can try while you're here at the Dev Summit. There's 2 Code Lab sessions happening. The Code Lab is also available online if you're streaming. And we have 2 talks that you should go check out. What's new in Android Studio, where Tor and Jay will walk through the tools that we're building for Compose as part of that. And tomorrow we have a talk from Leland, who's in our compiler and runtime team, and will explain a lot more on how the insides of Compose work and kind of demystify the compiler and what we're doing behind the scenes. Thank you very much.
Thanks.
Thanks.
I'm Florina Montanescu, and I'm a developer advocate.
I'm Daniel Santiago, and I work on the Android Toolkit team.
Room was created to simplify working with databases in Android by adding compile time check queries and an easier way to implement migrations and an easier way to test. But since 1.0, Room added more and more features. In Room 1.1, we extended the RxJava support, and we've added the raw queries. Room 2.0 just meant a migration to Android X. But then with Room 2.1, we've added several advanced features like full text search and views. But then you told us that there's room for improvement. So then in Room 2.2, we've been listening to some of the features that you've asked, and we've implemented them. So today, we're going to talk about what we've done in Room 2.2.
Thanks. So since the beginning, Room has always given you the capabilities, to define a DAO and a query, and then get some data back. And you've been able to do this synchronously in a blocking way, but Room also shipped with live data, and it was a way to get observable data set results. So if something changed underneath it, you would get a new set of results. But it didn't have anything for like one-shot operations. That was mostly up to you. As development progressed, we added support for Rx, and this was a complete story. You had types for both observable queries and one-shot operations. Room also supports Guava, and this was a little backwards from lifecycle, no observability, but there was one-shot operations. In Room 2.1, we started going the coroutines route, and we added suspend functions, and these fall into that category of one-shot operations. But in Room 2.0, we added support for Flow, and this completes that coroutine story, so you can have a full coroutine application. But what is Flow? Let's do a quick rundown on what Flow is. Flow is basically kind of like a relatively new Kotlin coroutine primitive. The cool thing about it is that it's lazy, so you emit some data, and there has to be someone on the receiving side for more data to be emitted. The API itself is split into two kind of operations. There's those that transform the data. They're intermediate operators like map and filter, and there's those that consume it. But let's see some code and some examples. So imagine we're making the best puppy finding application, and we need to provide an API for finding some dogs and pet them. This has to be asynchronous because sometimes finding dogs is tricky and might take some time. We also have a parameter here that limits the amount of dogs we get. If we were to build this, we would start with a flow builder. And the flow builder takes a lambda. In the body of this lambda, you write the logic to be able to provide that data, in this case, to get our docs and emit them. The receiver type is a flow collector. It only has one function, emit. So the interesting part here is that emit is a suspend function. And it is because that means somebody on the receiving end must be collecting the data before this function completes and your body continues. If we were to call this function, we use one of those terminal operators like collect. If we execute this, we'll be getting a bunch of puppies and petting them, which is amazing. On the other end, if we use a limit of 3, we would only get 3 dogs, and 3 dogs is still pretty cool, in my opinion. In terms of Room, in your DAO, you can now basically have a query function that returns a flow, and it'll behave like expected in the sense that you'll get a list of your result, but then it's observable. If we visualize it, imagine we have a Room database. On the other end, we're trying to display our puppies. When we get it, we get a list of puppies. But then if something changes on the database, like we download docs from the cloud, you get a new emission, and this emission contains both the old result set and the new one. The cool thing about Flow and supporting Flow and coroutines is that you can start combining it with the rest of the effort we've been doing with regards to coroutine. Especially, you can combine it with the lifecycle extensions that will basically allow you to launch a coroutine when the fragment is started. you can start collecting those dogs and start showing them, which is pretty neat.
So you've told us that you want to be able to pre-populate your application. So whenever your users install your app, you want to be able to already display the best dogs. So in order to do that, you would use a pre-packaged database. This database would either be part of your APK or would come from a backend. So if you would have to implement this by yourself, you would have to do a lot of things, from opening the database, validating the schema, locking the database file, and a lot of things, taking away from what you actually need to do, the features that you need to build. So in Room 2.2, we've added 2 new methods on the database builder, create from file and create from asset. So create from file will get as a parameter a file. This would be the downloaded file that you have. So one important thing here, you should make sure that you set view permissions on your file, so Room is able to read that file and copy the data. And then if you're prepackaging your database in your APK, make sure you put it in the assets folder. In terms of working with migrations, things are not very different. So in general, Room looks at 2 things. It looks at the database version installed on your device and at the version that you declare in code, so in your @database annotation. But now, with prepackaged databases, you have one more player. You have the prepackaged database. So when you're talking about migrations, for example, if the prepackaged database is version 1 and the one that you put in code is version 3, Room will also have to handle the migration from version 1 to version 3. So just keep this in mind whenever you're working with prepackaged databases. Next feature is relations. So this is not something new for Room, but what we did in 2.2 is to increase the support for relations. So today, let's do a crash course on what this means. So let's say that an owner can only have 1 dog. This is a sad world, but let's say that this is where we're living. So this means that we have a one-to-one relation between the owner and the pet. And this can be translated into database in like this. We would have 2 tables, a pet table and an owner table. And the pet table would also have a reference to the owner ID. For Room, this means that you would need to create 2 entities, one for pet and one for owner. And then if you actually really want to enforce this constraint between the pet owner ID and the owner ID, you could use a foreign key. OK, but how do we get a list of all the owners with their pets? Well, if you want to do this just using SQLite, you would need to select first from owner, and then you would need to select from pet based on the owner ID. So this would be put inside a data class, a pet and owner class that has the owner and the pet. With Room, you would annotate the owner with embedded, and you would add the @relation annotation for pet. So while this @relation annotation isn't new, what is new in Room 2.2 is the fact that you are able to add this annotation to an object that is not a collection. So for example, here, we're just adding it to the pet, and we're telling Room that there is a connection between the pet owner ID and the owner ID. If you want to, when writing your query, in your DAO, you would just select from owner, and you would return the list of pet and owner. OK, so we said that an owner has a dog. What if an owner can have multiple dogs? So this will be a one-to-many relation. And this is mapped in the same way in your database. So you still have a pet and an owner. And then when we want to get the list of owners with all of their pets, the queries that you need to write are actually the same. You still need to select from owner, and then you would need to select from pet. But we don't want to do this by hand. We want to use Room. So we will write our data class owner with pets, where we would still have the owner embedded and the @relation annotation on the list of pets. So here in the @relation annotation, we're saying that there is a connection between the pet owner of the pet table and the owner ID column of the owner table. Our query is simple. It's just select from owner, returning a list of owner with pets. OK, so we have an owner having multiple pets. But what if a pet can have multiple owners? Well, in this case, we have a many-to-many relation. And unfortunately, this can't be expressed simply with two tables. But rather, what we need to do is to create a junction, a link table, a pet owner table that contains the IDs of the pet and of its owner. So the pet owner would be an entity with a composite primary key, the pet and the owner. But now, if we want to create a list of all the owners with all of their pets, things look like this. So first, we would need to select from the owner, and then we would need to write a query that creates an inner join between the pet and the junction table. So this is quite a lot of queries to write for this amount of data. So now, with Room, we can write things differently. So we would still use the same owner with pets data that we've defined before with our owner and our list of pets. Also annotated with embedded and at relation. But what is different is this associate by tag in at relation. So this is the one that tells Room that, OK, you should connect the pet and the owner based on this junction table, pets and owner. So now in the DAO, we need to just write our query, select from owner, and return the list of owner with pets. So this means that now in Room 2.2, with one annotation, at relation, we can support one-to-one, one-to-many, and many-to-many relations. OK, Danny, is there room for more features?
Yes, there is. There's more features. Another thing we added in Room 2.2 was default values. Not Kotlin default values, schema default values. And you can define this in the column info annotation. There's a new property called default value. And this actually takes an SQLite expression. So you can use themes like that current time, which is a keyword on SQLite. Another thing we added in Room 2.2, or we made Room 2.2, was a Gradle increment output annotation processor. And this is basically a change we did so that you can get some build benefits when you're continuously building your application. You have to opt into this feature. It's an annotation processor flag. We want to enable it by default in the future, but we're in this phase where we're trying it out, hashing out any issues. So please try it out. Let us know if it works or not. The last feature we had room for was kind of like a long-lasting bug, or not a bug, but like a long issue of dealing with a sub-list of columns. So imagine we had this entity dog. It has a bunch of properties and a smaller POJO for it, which has a subset for it. If you try to query the dogs table, but return a puppy, you will get a warning from Room telling you, hey, your query has too many columns, or it's returning too many columns that you don't need. And the reason this is happening is because we're using that start projection. With Room 2.2, we added a feature that will actually take that start projection and rewrite it just to the columns that you need. And you get that build benefit, that performance benefit, kind of for free. We call this expanding projections. It's an experimental feature, so try it out and let us know how it goes. To enable it, you have to go to your annotation processor options and also opt in via a flag. Expanding projections also tackles the long-lasting issue of conflicting column names. And you could see this a lot if you try to do a join of two tables that had two columns with the same name. For example, here we have dogs and owners, and they both have a column name ID. Expanding projections solve this because you can define a POJO, and you can use embedded with prefixes. And if you combine the prefix along with the SQLite operation to rename the table, then Room will figure out which column goes to which entity, and he'll be able to rewrite your projections so that there's no conflicting columns. So this makes it easier for those queries with big joins that have conflicting names. As you keep adding more things, you can keep your start projection, and Room will be able to figure out the rest. So to recap, we added flow support for Room that completes the coroutine story. You can go ahead and use Kotlin and coroutines everywhere. You can actually also replace live data with Flow. We feel it's a nicer API, especially because it has better error handling. Prepackaged database is a feature that's been asked for a while. You can have that too. We expanded relations, the annotation to have one-to-one and many-to-many. If you still have to do some pretty complicated relations, there's always the fallback of writing your own queries. You get some sweet build speed with that incremental annotation processor. Schema default values and expanded projections are also very useful. So try it out. Let it know. If you have any issues or problems, come talk to us. We'll be in the sandbox. Thank you.
Thank you.
Android Dev Summit 2019, and welcome back to the Ask Android livestream, where we're going to be taking your questions and turning them into delectable Android answers. My name is Lila.
And I'm Dan, and next up to answer your questions about Jetpack Compose are Anna Chiara Bellini and Adam Powell. Now, Anna Chiara is a PM on Jetpack Compose, while Adam is one of the engineering leads.
Okay, and I just want to give a quick shout out to our live stream. Gokul is staying up late to watch us, so thank you, Gokul.
Yay.
All right, first question. Nick Forzed asks, is this going to be, and this being Jetpack Compose, the preferred way to make UI in the future?
I mean, it's my preferred way.
My preferred way as well.
Okay, not biased at all, right?
Okay, a question that came in from the live stream from Jason Ostrand. Most pressing question on my mind, how does Android app architecture change with Jetpack Compose?
So hopefully not as much as you might think. I mean, the intent is for Jetpack Compose to kind of slot in right next to all of the things that we've been doing with Android architecture components so far. If anything, we're kind of hoping that it brings UI development a little bit more up to that sort of standard that we've set.
Okay, so from Twitter, okay, I very much apologize in advance. Yekta Sarioglu asks, okay, so they say, I hate XML for design purposes. When is Jetpack Compose going to be released for beta or alpha stage at least? Do you have any date on your schedule? I'm really keen to try new code-based UI design.
You should try it right now anyways.
You can try it today because we are in developer preview. It's available, and so please download and try. But if you listen to the keynote, you know that we should be going beta next year. So just stay tuned.
Excellent. So one of the questions that came in from the live stream from Diaz is, will Compose handle like recycling logic for us, things like recycler view, or is the idea for us to just use it for static kinds of views?
No, dynamic views are definitely within what Compose is trying to do. So we don't necessarily have like a list view or recycler view widget in there in the preview that's available today, but that's coming.
Great.
Okay, so from I'm Shreyas Patil asks, okay, so we've been getting a lot of questions about performance. This is sort of a multi-layered question. So what will the future of layout XML be after Jetpack Compose? And can we rely on Compose, like will we be able to rely completely on Jetpack Compose in the future? And then how's the performance difference?
All right. So can you rely on Jetpack Compose completely?
Yes.
The intention is yes, that you can write an app from the ground up with it. But if you go watch the What's New in Compose talk, I talked a little bit about how you can use existing XML layouts from within Compose and sort of vice versa, and kind of how we're thinking about that problem space so far. We definitely want it to be interoperable with any of your existing code that you have today.
Okay, cool. And then the performance question, if we haven't tackled it.
Yeah.
I'm asking the hard-hitting questions here.
Yes,
for you.
Reporter job.
Right. So basically we're relying on a lot of things in the experimental compiler right now, and there's some things that we've kind of had to turn off or turn on. So for example, inlining of inline classes within Kotlin is something that has kind of come and gone so far, but we're kind of counting on that for a lot of things in terms of like we use like real units for things rather than the @intdef annotations and just kind of like cram everything through primitives for things. Instead, we're using Kotlin's and counting on that being available for Compose. So right now we're doing just kind of like allocations everywhere. in terms of just like very, very simple sort of things. So you might see on some older devices, like you'll see a little bit of stuttering in there. You'll also see a few cases where it might be easy to cause like whole-scale recompositions in ways that like cause your app to jitter or jank, et cetera. So we're working on smoothing those out and making it so that those are things that like you don't bump into in your day-to-day.
Yeah.
If you take a look at some of the demos that we've got today, I think our performance is in a pretty good spot. I mean, like you can get your lists, get them flinging, et cetera, and it's looking pretty good.
Awesome.
The PM short answer is yes, we're working hard on it.
That's great. So we have a question from the YouTube live stream from Maximilian. Is Compose a better or cleaner approach than using something like data binding with live data?
You want to take it? I take it. With live data, you can use Compose. We've tried it. It's a different approach to data binding, right? With data binding, you use the views, and with Compose, you just recompose automatically. So it's just a different approach. I'm not sure if we can. For us, we like it better, but it's a bit like the first question.
Yeah, I would say if you're trying to decide between some of these things, give it a try. I think that we're putting a lot behind Compose right now, and I think that it's something that like we're trying to make sure that we're at least as nice to use as data binding is today.
So you were talking a little bit about the interoperability between XML and Compose. Can you talk a bit more, if you know, what the migration story is going to look like? What are your thoughts about that?
Well, so you're saying migration story in terms of like, do I want to do like some sort of a direct conversion? I have a direct XML layout. So this is something that we've really kind of talked about a lot in the team, and I think that part of what we were trying to do is we're trying to build on a different set of primitives. So like everyone's kind of familiar with what's there in Android.widget, and I think that at this point we look back on how we've kind of built that system out over the years. And there's things that we would do differently, and so that's kind of what we've expressed with the Compose UI components so far. But what that means is that there's not generally always going to be a one-to-one mapping from something that exists in the view system and something that exists in the set of composable functions that are available. So while you might be used to being able to take like a snippet of code from the Java programming language and paste that into a Kotlin file and have like some sort of auto conversion there, the machine translation there can actually be 100% accurate. With Compose, we're kind of expecting that may not be the case unless you still sort of appeal to the views that you started from in terms of making sure that it actually works the same way. It's one thing to get something that looks the same. It's another thing to say that like, okay, all of your logic wire up that kind of sits around this. When you're dealing with existing view code, you're talking about code that, again, you're doing find view by ID, you're doing data binding, you're doing view binding, you're doing all of these other things that sort of performs this wire up for you. You've got custom code and list adapters everywhere, recycler view adapters everywhere. So as soon as you have all of these things in the mix, trying to say, okay, take all of that and then do the immediate conversion as sort of a machine translation for me. I think that would be a fascinating project to try to work on, but it's not what we're targeting.
Well,
right
I mean,
now,
and a lot of those things are actually just trying to, allow you to create and use reactive UI patterns on Android, and that's what Compose really is a full reactive toolkit. Right. So one of the questions that also came was in terms of like interoperability between existing Android UI. Can I take a composable and can I put it into the middle of an existing view hierarchy, or vice versa? Can I take something like a web view, which is an existing thing, and put it into my composable hierarchy?
Yeah, in fact, you can take a look at the repository that's there today, and you can see some of the work that we were doing to sort of put a web view in a wrapper. This is kind of one of our very early proof of concepts that we did in the project that sort of lays some of this out. And if you check out the What's New in talk again, I'm just going to keep plugging that. Then I talked a little bit about where we're thinking in terms of compatibility in both directions. So consuming Compose from within a view hierarchy and also consuming views from within a Compose hierarchy. So we want both of those things to be really seamless.
Cool. Anything from the live stream that's good? Because I could ask this. You take a look at that. Okay, so I think a good question to ask is sort of, all right, people are excited about Compose. At this moment, what's the best way to learn Compose, get started? What would you suggest for that?
Wonderful question. We have a brand new website. It's developer.android.com/jetpack/compose. Okay. And beautiful new website, and it links you directly to a tutorial. So the tutorial takes you through the very first steps, building a simple UI, a a composable function that has a picture and 3 lines of text and styles them nicely. And that's kind of your first step. Then if you want to take a step further, you can look at the JetNews sample that we published, which kind of shows you all the components that we have at the moment, and hopefully the code should be clear enough to follow up, and so you can start and play with it right away.
And you need 4.0, which I'm
you need
assuming
4.0, yes. It's all explained very well in the tutorial and on the page. You need the Canary version of 4.0.
Okay.
So Marta asks,
a sticky note on the back of your laptop.
Marta asks, does Jetpack Compose support building dynamic layouts using constraint layout instead of linear layouts?
So, good question. So for constraint layout, it is not there yet, but we are working on it. I think this was mentioned in the What's New in Compose talk as well, just to plug it in for you. Yes, we're working on it, so constraint layout will be available. A linear layout, not exactly. We already have row and column, which are just a bit better maybe than linear layout, because yeah, they're more like the Flexbox, but you basically already have them there.
Okay. So obviously one of the messages is like, we want you to try this. We want you to see how it feels. So somebody, our viewers out there, try it. What's the best way to get feedback to you besides showing up at ADS and, grabbing you and giving thoughts? What happens if you're, tuning in from Haiti or many of the other places that we've got viewers right now?
Yes.
On the webpage there are a few links that you can follow to get in touch with us if you play with Compose. One of them is getting involved in a Slack group. There are links to apply for that one. Then we have our Stack Overflow, but probably the best way to get feedback to us is the Slack group, or filing bugs, or the issue tracker, or filing bugs as well.
And there's directions to how to file bugs for the issue tracker there.
It's everything on the webpage. We put all the links for you guys to play with.
So like if you have feature requests, for example, please file those. We'll go ahead and work our way through those too.
Is there a way to upvote issues that you're particularly passionate about?
I think we can start issues still, right?
Yeah, I think so. And I think that one of the important messages is that we want that feedback. We are building Compose with the feedback of users, and we're very keen on getting it.
Yeah, I mean, I think Compose was started partially because of feedback or things that we were seeing in the community. Right?
Yeah. So one of the questions we have from the YouTube live stream from Carolina asking about Adam's response. If Compose is going to be the preferred way to build UI, is it my preferred way? Is that the official answer? that it's Adam Powell's preferred way to build UI?
Answer of the Compose team.
Are we going to put that on the website?
Adam Powell's preferred way to build Android UI. So is that our official answer?
Compose is a new way of building UIs, right? Views are there. Views are staying there. We're not scraping them.
Right,
but
exactly.
Compose is a different way of building UIs, just like, we're becoming a bit more opinionated, and this is one of the things that we are proposing to developers.
Right. And ultimately, it's going to come down to what developers think. If all developers start using Compose, then it will be the preferred way.
Yeah,
I think that's
actually the right answer.
Yeah.
It will really depend what people think more than what we
Vote
think.
with their dependencies.
Exactly.
All right, cool. So Alexander from the YouTube live stream asks, how is Compose going to handle different screen sizes?
Beautifully.
If we know that.
It's going to be fantastic.
So I guess if you know, what are the developers' sort of responsibilities in that?
Beautifully in the sense that as you're using, there are two things actually here. One is, as you're using a declarative UI pattern, if you have breakpoints and you are doing things that are particular, you can just take care of that in your code in a very simple way. The other thing is that the tools help you build that because the preview helps you see directly what happens with different form factors, different font scaling, different themes, so you can see exactly what you can iterate very fast on that. So Compose itself, I think, is going to handle different screen sizes very well.
Yeah, if you want to know something a little bit more concrete, so for example, Clara showed the layout API that we have, that's sort of our very low level, how do I make a custom layout, something primitive that everything else in Compose is based on for layout. We've got another one that we just call with constraints right now that gives you the ability to essentially change the composition of your children based on the measurement constraints that are coming in. So that allows you to you have a very low level primitive for creating your own breakpoints, however those need to be. And we can sort of start building up a library of useful components that we can offer out of the box, just kind of based on what people find most useful. If the question is more about you're used to a lot of the resource qualifiers that are there. Yeah, you'll have access to the configuration object. You can switch on those however you like. Kotlin's when statement is very powerful.
Yeah, I was going to say.
But I think that the core answer there is that yes, you will write some code there, and it will end up being pretty reusable. So hopefully you won't have to always refer back to the d.android.com page, the providing resources page that even I have to go to every time I want to know what the resolution order is if you have to specify more than one qualifier at once.
Exactly.
So no, you'll be able to just take a look at your code. It's like, no, it happens in this order because this is the way that I wanted it, rather than trying to figure out like, oh no, this is just kind of the way that the Android team set it up 10 years ago. So.
Nice. So one of the questions that came from Rizky is navigation component in Jetpack Compose.
Question mark.
Question mark. We like it. So it was one of the earlier kind of explorations that we did on the team was a member of the team actually created a custom navigator for the navigation component where you just provide a composable function call as like this is my navigation destination within that. Fragments are not like the only language for the navigation architecture component. We designed it from the very beginning with very much that in mind.
Right.
Like it turns out that some people don't actually like using fragments in their app. Can you believe it?
Shocking.
Yeah. So we designed the component to be a little bit more pluggable for things like that, and it's really paid off with Compose. So I think that it's going to make these two things slot together quite nicely.
All right, so I want to make sure that we hit on it. You had mentioned the editor in Android Studio.
Yes.
So we have a couple questions just about whether the editor exists, which it does. Anything?
So if you're looking for layout editor,
layout editor.
We don't have that.
Okay.
At the moment. We have a preview.
Okay. Yeah.
We have a preview that helps you see almost in real time what is happening to your UI. So.
Cool.
Yeah, one of the questions that actually Zed asked was how does Compose relate to faster apply changes?
I would say that apply changes is there. I'm not entirely sure it's faster. I think it's apply changes. But the thing is, apply changes is important that it's fast because it's how you iterate on development, right? So we go back to the root of the problem, which is not just get apply changes faster, but what do developers need, which is develop faster, iterate faster. That's why we have the preview, because we tested it ourselves. It's much easier to work on a component in isolation and just see how it works and iterate faster on that. And that's why you have the preview. It's just a way to work even faster.
And if you're watching kind of the stream of commits in AOSP, you might see some things where we have added some hooks into the Compose runtime so that a tool like apply changes can go ahead and give it a kick, recompose after some code changes have been applied, so on and so forth. So we're starting to build some more of that stuff.
Well, and the nice thing is if you're using the preview in Android Studio, you're not even relying on apply changes. You're just watching the previews just being updated dynamically. And then you can actually also apply the changes really quickly when you're actually doing your code. So you're actually got both things working for you to help you compose.
We're kind of approaching the developer velocity question from kind of up and down the entire stack. We want to make sure that, like, based on the use cases that you have for like what you're trying to test and do, that we've got you covered.
So Steph asks from Twitter. They're wondering about the layout inflation. So basically, where and how do these layouts actually get inflated? Is anything changing?
So if you're using an XML layout and using it from kind of one of our interop paths, then the inflation happens basically in the same way that it does today, or will happen once we build some more of that stuff out. If the question is, where does this stuff actually get instantiated when you're using the native Compose UI pieces? It gets instantiated by the runtime itself. So like those actually are just the composable functions running. Those are sort of constructing the UI hierarchy live, more or less. So there's no like separate from a file stream inflation process. I mean, I guess if you wanted to write like kind of an interpreter that goes through and does something like that from a file on disk or something, you could. But.
Yeah, I think that maybe, I'm not sure if I understand where that question comes from, but I have seen some of these as well. What Compose is doing is not under the hood creating layout XML and just hiding these things from you. It's a completely different approach. So it's not just reusing the same way. It's not just a way of expressing the same things.
Are there any performance gotchas related with that you can think of, or things that people should know, given that it's changing a little bit from writing it in XML?
For what?
Sorry, in Compose.
Well, I mean, so for Compose, if you look back at kind of what performance for layout inflation always was, and performance for not just that, but view creation, performance in view creation was kind of bound by a couple of things. It was bound by kind of the process of reading that stream off of disk, or just kind of from the mapped resources of your APK, but it was also part of instantiating the views and running all of the view constructors for the entire type hierarchy of the views that you were instantiating. So some of these things could cause a number of like repeated styling passes over and over for each layer of hierarchy that you have. Like the view constructors are not particularly cheap. So when you write like a recycler view adapter or a list view adapter or so on and so forth, we split this step out and we say, okay, here we're going to separate out the create and bind steps as being something separate. We handle that kind of under the hood for you. So we want to make sure that whenever we can, we will just apply those same changes that you've made to your UI to what's already been kind of constructed under the hood for you.
All right, awesome. So I think that our time is just about up. Thank you so much, Anna Chiara and Adam, for stopping by to answer our community's questions about Compose. We're going to take a super quick break right now, and we're going to be right back with our Camera X experts.
Excellent. Thank you. If you're just joining us, we're live in Sunnyvale, California at the 2019 Android Dev Summit, and this is #AskAndroid.
Okay, so joining us right now are Vineet Modi and Trevor McGuire, who are going to be fielding questions about Camera X. Vineet is the product manager for Camera X, and Trevor is part of the Camera X engineering team.
All right. So Kalahandi M asks, so when will you release the stable version of a Camera X API? Everyone wants to know this.
So we're pretty excited to share that Camera X will be beta end of this year, and then with the beta release, developers will be able to use Camera X in production.
That's great.
Yeah, that's a good thing to point out, because sometimes with beta versus stable, there's questions about that. But,
exactly.
Yeah.
Exactly.
Anything you can point to that could encourage developers to use in production, or I guess some evidence of that?
So as you said, the milestone can be fluid.
Yeah.
One of the reasons that we declared beta as to be ready for production is actually the amount of testing that we do.
Okay.
So one of the things is we have a device lab with 52 devices. They represent 200 million active devices in the market. And so everything from taking a picture, rotation, etc., is all tested real time on those devices. In addition, we test across hundreds more devices for things like just stability, crash testing, all that sort of stuff.
Awesome. So yeah, the test lab is really cool. It's like if you ever get a chance to see it, it's amazing. Okay, let's see. What else you're going to ask the next question?
Sure,
actually.
I will ask the next question.
Sorry.
So I think a question that might be on everybody's mind is they're on camera 1. Should they be migrating to camera 2? Should they be migrating to camera X? What are the things that you should be thinking about when you make this decision?
So I think if you're using camera 1 today, then camera X is going to be much easier for you to use because it's not quite as steep of a learning curve as camera 2 is. If you want your app to be like a more fully featured camera app, like you want to make use of a lot of camera controls like you would expect in like a DSLR or something like that. Camera 2 is the more flexible API that's going to give you that control.
Yeah, I mean, in addition, one thing is if you have users that are in API 20 or before, API 19 or before, right, then they should keep on camera 1. For the majority of the users, then you can move to camera X. So camera X will work for 90% of devices that are in market today.
Awesome.
Excellent. All right, so let's see. So a question from Pranay Patel asks, is there any inbuilt way that camera X have or will have for developers to easily switch camera from front to back and vice versa?
Yeah, so today you can actually do this. With use cases, you configure them with a specific camera in mind. So you say, I want to use the back camera, and then you bind it to a lifecycle. Now, lifecycles don't always line up with when you want to switch cameras. So you might be in the same activity and you want to use the back or the front camera from the back camera. And so what you can do is you can actually unbind the use cases from that lifecycle, and then bind new use cases with the front camera as the configured camera. So that'll help you switch cameras easier than you could do with camera 2 or camera 1. In addition to that, we also do have the camera view module. This is something that you can include into your build.gradle file, and it provides a drop-in view called camera view, which would allow you to show a preview on screen easily and take pictures and save those to disk. And that has an API where you just set which direction you want, which camera direction you want to be shown in the preview and for the pictures. And so it's a simple API, set lens facing.
Cool. It's what I've always wanted, just a drop-in view so I can put my camera in.
Yeah, we got a lot of questions from developers. Rahul Raj and Hussein Khan both were asking about this. So basically the intersection between camera X and MLKit or sort of other machine learning stuff. So what is, I guess, the plan involving MLKit and camera X?
Absolutely. So we're super excited for this. So in general, a lot of developers are asking for this. And what we want is camera X to be a seamless stack where we take care of all the hard stuff of configuring the camera. And then at that point, it's easily able to slot things like MLKit plug and play on top. That's now coming more into next year. But we are building up towards that, so I think that'll be a super exciting direction for developers.
Awesome.
So one of the questions that Rahul Raj asked was, we are experimenting with camera X and machine learning, and our TensorFlow Lite model needs a 3D array of RGB values, but the camera X analyzer returns YUV. Is there an easy way to do that, to get an array to RGB?
So it's not as easy as it could be, but using the image analysis use case, you can get YUV images. And there are ways that you can convert that to a RGB image. And you can use the YUV image class to actually encode that image and then decode with Bitmap Factory to get an RGB bitmap. Or if you're a more advanced user, you can actually use RenderScript. There's a script intrinsic to
I'd say RenderScript would have been my thought,
yes,
on that one.
Yeah.
It'll be fast. That's the important thing on that one. Cool.
Okay, so from Twitter, Telvik asks, basically, can we use camera X without Jetpack? And I'm interpreting that as like without the other Jetpack libraries. Like, can it be?
Or without migrating to Android X? I'm not sure.
Or without migrating to Android X.
Yeah,
sure.
I mean, I think Android X and Jetpack are like core components for camera X. I think some of the things is like there's the lifecycle management, right? So we rely on Android X for that.
Okay.
So it's really tightly coupled with it. So I think our recommendation to developers is to really consider migrating to Android X as part of camera X.
Okay, so you migrate to Android X. Do you need to be using like view model and live data, or are those separated from that?
So no.
Okay.
We do want to expose some of these new features or these new sort of programming paradigms in camera X if we can, but you will need to use life cycles right now. And live data is something that's optionally going to be available as well. But
yeah, so it's like very compatible with kind of this latest and greatest stuff, but you can use it without it.
Yes.
All right, cool.
So Magic Dex from the YouTube live stream was asking how or if Camera X is going to handle multiple camera streams at once.
Yeah. So I think today a majority of the use cases require just one camera being active at the same time. We are kind of overall on the platform. We are exploring how do we enable kind of multiple camera streams, especially for front and back. In addition, though, starting with Android P, we have a new API called the Logical Camera API. That Logical Camera API, what it does is it combines all the physical cameras into one easy API for developers to kind of access all the different physical sub-cameras. Camera X will be able to work with all the framework APIs that are existing.
I presume that's supported on Pixel too, like with the two rear cameras, like is that?
Yes, so the Pixel is using a Logical Camera API for both the front and the back.
Oh, great. Excellent.
Cool. Okay, so we talked about front and back. We have Cyprian asking, is the handling of screen rotation fixed in Camera X? Maybe I could phrase that a little bit different, but basically screen rotation could be easy in Camera X.
Yeah, so screen rotation is a very hard problem because developers have to worry about what's the orientation of the sensor on their phone, what's the natural orientation of the device, and like what's the current display orientation. So we have a sample Camera X Basic that they can take a look at, which does show how to use it with Camera X. And we have a few new things coming up soon, so keep an eye out.
I think calling out the sample is great because we're actually almost up. Is there anything else for getting started with Camera X that developers should know or go to?
So there's the Camera X website on developer.android.com, and I think that's the best way to get started with Camera X.
Okay, great.
Excellent. Well, Trevor, Vineet, thank you so much. If you want to learn more about Camera X, of course, we also, in addition to the website, we have the Camera X Code Lab. And again, we'll be back soon. So thank you very much. Hello, we're back with hashtag Ask Android, and we'd like to welcome Kenneth Ford and Neto Marin to the next session of the live stream. Now, Kenneth is a developer advocate for Chrome OS, also focused on foldables, while Neto is a regional DA and a LATAM expert based in Brazil, and he's also an expert on Android TV and things like billing and other stuff.
Sure. Okay, so if you couldn't see from the way that we described our guests, we were talking about form factors, which includes things like auto, Wear, TV, foldables, Chrome OS, and that is a bunch of topics. So we're going to try to do our best to get your questions. Again, if you have questions, just use the hashtag AskAndroid in either the live stream or on Twitter, and we will try to get to those. So, Dan, do you have your first question?
Sure. So, I guess this is a question that's probably in the mind of a lot of developers, but why or when should you care about using all these different form factors?
So I think when you talk about like Chrome OS and foldables and tablets, it really just comes into what kind of experiences can you bring to your users that are different from on a phone, and if you feel like those are valuable, then that's kind of when you should think about actually targeting these kind of different devices.
And developers actually have a lot of success with apps on Chrome OS, right? I mean, this is it may not be something you think about, but developers are building whole businesses built on getting these apps to work really well in these large form factor devices.
And we see like increased engagement rates and stuff like that because these devices are meant for longer experiences, more kind of in-depth usage patterns and things like that.
Yeah, the same for TV, because you need a very specific experience because you're using a remote control, you're not using your fingers to touch and everything. So if you are thinking about onboard and a TV, and for example, in some regions TV, the house is built around TV, so that you have the family room, so you need a really good experience.
Yeah, I know people who watch their TV all the time.
I have two daughters, two small daughters.
Some people out there might be, watching the TV.
Thanks for watching.
Yeah, thanks for watching. Okay, so another question that we get a lot is, do you need a separate APK for different form factors?
So for things like mobile phones, foldables, Chrome OS, and these kind of Android-based desktop environments, it's all the same APK. I think you have more information on the TV APKs and stuff.
In TV you have two options. If you are using app bundles, you can have just the same APK with the bundles because it's not actually an APK, right? It's the bundle that the Play Store will deliver. But if you are not using the app bundle, then you need a different APK. And a good thing to measure is that the version number must be always higher than the mobile version number, because instead of that, if you update your mobile with the higher version number, the TV will get this mobile version. It can mess up with your application. So yes, so you need the multiple APKs if you're not using bundle and a higher version number for TV.
The best answer is just use the app bundle.
Well, about that, like most Chrome OS devices are x86 architecture,
right?
And they're different densities a lot of times than most phones. So app bundles really allows you to ship like a substantially smaller APK, specifically for using native code.
Okay, cool. So.
Use app bundles.
Yeah, the same for TV because you have 4K, Full HD, you have different resources, and they are big in this case, right? So.
And app bundles just sort of takes care of all that complexity for you. So,
exactly.
All right, cool.
So one of the questions that came in from the Twitter stream is, and this is I don't know if we can really answer this, but it's kind of a fun question. So why does Android TV have the model view presenter pattern in lean back? And is there any way to upgrade it? As it's really hard to design for things like MVVM?
Yeah. It's because the way we have on TV, because it's a simplified pattern if you think about for presenting media content, because the Android TV apps, they are more focused around media content. So when you have the model where you get your information about the stream, then you have the view that is specifically about how you display this on TV, and the presenter is because you taking care about the media transmitter, the stream, etc. So in this case, we thought that it's an easier way to start doing Android TV apps. But yes, we are continuously working our libraries and probably going to have something in the future updating according to the community feedback. And if you have a feedback, send to us. And because it's important to know how developers are using and what are demands. This is how, for example, Architecture Components was born, right?
Yeah, exactly.
You heard the feedback.
So, you just mentioned if you have feedback, send it to us. What is the way that you like getting feedback?
We have the Android Dev Twitter handle. We have the we can send one of the DA, so at Neto Marine, but you also can send to our.
DM Neto.
Yeah. But you can send some. There is a bug tracker, so you can open an issue there and put your feedback there.
Okay, so Twitter handle and bug tracker are good ways to get some face.
And if it's something with the samples, you always can use the GitHub issues to register that.
Yeah, or send us PRs.
Okay, so Avi12641 asks, what is the best and easiest way to optimize the app for all screen sizes?
So I think a lot of that really just comes down to building out different layouts and finding ways of taking advantage of the different screen sizes. So making sure you have layout files for kind of all the different screen sizes that you feel like your product should change at. And then really caring about the larger screen you generally get to, the more landscape first it is. So just thinking about kind of not only how your layouts work in portrait, but also kind of testing landscape and rotation changes and things like that.
Is there any recommendation around like art assets and things like that as you're dealing with larger screens?
You should think about kind of not only like the screen size, but maybe how far away the person is going to be from the display. So on a phone, it's usually really close. Where on a laptop or something, you're a little bit further away. So just thinking about maybe you should scale these assets up, provide bigger assets, and just kind of that really comes down to testing on these different devices, because that's really where you'll see for your product and your app kind of what kind of breaks down.
And also think about the navigation, right? Also on TV and this kind of device, sometimes even though you are using on a laptop, you don't want to touch. For example, you are using the keyboard or some navigation. So pay attention to navigation is also very important, and for TV is even more important because people using remote, using other ways to control that.
We talked a little bit about this in our session too, of like bottom nav bar kind of breaks down as you get to wider screens, and so thinking about how you can pull that out to a left side nav or something like that, just to give people more intuitive experience that they're used to on these kind of devices.
So you mentioned your session. Do you want to give some key points that you went over in the session, or maybe why folks should watch if they haven't watched it already?
Really the thing we drilled in our entire session is just handling configuration changes. You can't really run away from them anymore. You can't really just lock to portrait and kind of move on and not worry about saving state and things like that. If there's one key point that we can kind of take away from that talk is handle configuration changes. And we talk a lot about kind of what configuration changes you'll see, whether it's folding or unfolding a device, resizing and things like that. So if you kind of want more information on what to look for, we talk quite a bit about that in our session.
I was going to say, and also the speed of handling configuration changes becomes really important, especially when you're on a Chrome OS device and people are trying to resize the window. Do you want to ask that one? Does that sound?
Yeah, sure. So Adrian asks, should the multiple form factors be used to continue a user's experience or as a standalone experience independent of each other?
I think it depends on what form factors you're talking about, right? So I think TV is probably a pretty separate experience.
Yeah, totally different. Like, again, repeating, you are using remote, or sometimes you're using the Google Assistant to ask for something, so the experience is totally different.
And something that we talk about in our session too is just from a desktop to a phone or foldable. In that world, it should be the same kind of experience, but think about how you can surface more options and things like that for specific contexts.
All right, well, I think that's all the time we have. So thanks, Kenneth and Neto, for all your form factor insights, and thank you, Android community, for submitting great questions. Make sure to check out our guide on developer.android.com for more about targeting your app to different form factors, and of course, catch the rebroadcast of their talk.
Okay, so this concludes this particular portion of the Ask Android live stream. Next up, we're going to have some pre-recorded content, and our next speaking session will start at 1:40 p.m. PST, so you can convert that to your local time. Hashtag Ask Android will be back in about 2.5 hours at 3:35 PST. We're going to be answering your questions about the Android community, Google developer experts, Google developer groups, what the difference between those two things are, getting started with Android, and more. During this whole period of time, we're going to be monitoring the live stream, so just make sure to keep asking your questions with the hashtag AskAndroid hashtag. All right, see you soon.
Bye.
Thanks for watching the ADS livestream. Ask Android will be back soon. In the meantime, post your questions to the live chat with the hashtag AskAndroid for a chance to see them answered live. And if you like what you're seeing, don't forget to subscribe to the Android Developers YouTube channel. See you from the conference floor.
Free Android samples. Hi, my name's Jeremy Walker, and I'm an Android developer advocate at Google. That's right, they're free. Android samples have moved to a pull request friendly location at github.com. But let's take a step back. You may have noticed in the past that while some repos accepted pull requests, Architecture, Sunflower, others did not, like their CyclerView or Watchface repos. Why? The origin of repositories that didn't accept pull requests is within AOSP, and GitHub acted as a mirror. This system was made some time ago to help us easily update library versions and separate UI code in samples, mainly around the Holo theme if you remember those days. While it made our lives easier when we launched it, it restricts us more than it helps us now. I mean, we can't accept pull requests. We decided earlier this year it was time to move away from that system, audit all existing Android samples, and move them to a central location on, you guessed it, github.com/Android. As part of the audit, we are bundling simple related samples together into a single repository. For example, if you visit the camera samples repo now, you will see all the samples related to the camera APIs in one location, which is great for discovery. And if you forget and visit the old locations, don't worry, we'll point you in the right direction in the README. For larger established repositories like Sunflower, we simply transferred them to github.com/Android. That means if you go to the old link, you're automatically redirected to the new one. We've now migrated all the repos, so review your contributing file and start creating some pull requests. Thanks again for your contributions over the years. We look forward to many more at github.com/Android.
I am David, I'm from Mexico. I have been traveling around a lot and I have experienced different things, meet different people, and I still have the feeling that I want to see many more things. I have been either teaching or learning languages all my life, and of course I need to find a way in which I can travel and work at the same time. I was looking for a way to consume written content in which whenever I found the word that I didn't understand, I could easily get it translated. My first instinct was that this product already existed. I searched for it, I didn't find it, and then I realized, okay, well, I'm a programmer, I'm just gonna build it. Bilinguap is a language learning app with which you can read text and listen to audiobooks in both the language you want to learn and your native language. It has 13 languages supported, and we are thinking of adding at least 2 or 3 more this year. So you select the text that you want to read, and let's say you want to learn English.
Down on an old farm lived a duck family.
And anytime I don't understand something, I can just look down and see the same text in my native language to compare. So the business model in Bilinguap at the moment is a freemium model, but most of the money that comes from the app comes from subscriptions. Setting up subscriptions with the Google Play console is really, really simple. One of the biggest benefits is that you allow Google Play billing to take care of all the payments. You get to see all of these very detailed reports of how people are paying, who is paying, where they are coming from, the conversion rates. You can even see why they cancel if they do, so that you can tweak or change your products. The introductory price, it really helps to get users subscribe when they get the first time cheaper. Most stay for the second period of time, so it's been a really, really helpful tool. Having the Google Play console app is basically like having a whole team in my backpack. It allows me to see a lot of information. For example, how much money I made the day before, how many installs I had, how the reviews are. I get to see everything in just one place, and then based on that, I can make business decisions. Traveling really opens your mind, even if you have a plan. Every day is different. It's very exciting traveling, building a product, getting to know people, test the product and see how it evolves, and being able to live off that, but at the same time helping people improve their life by learning a new language.
讯联科技成立于1996年，致力于多媒体软件的开发，其中威力导演 PC 版长久以来一直是 Content Creator 最喜欢的软件。近年来 ，YouTuber 和 Video Blogger 的崛起是媒体界不容忽视的趋势。对于这些需要频繁更新内容的专业用户来讲 ，Video Editing 作业的方便性可以大幅影响他们是否可以经常更新内容的方式。多年前，我们看准这个趋势，把多年来广受好评的威力导演从 PC 版移植到 Android 平台，满足新的 Content Creator 的需求。Android 系统专属的威力导演里面包含很多专业功能。对于不管入门新手或者专业玩家，提供了最好的 mobile 的创作解决方案。威力导演提供强大的 video editing 功能，例如视讯的稳定，或是画面的缩放、定格、平移、快转、慢动作，或是色彩的去背，以及 4K 影片的输出等等。威力导演 APP 在 Google Play Store 上的下载量全球已经超过5400万次，使用者的评价一直维持在4.5颗星，并且在2017年获得 Google Play Store 的 Editor's Choice 大奖。
We are very happy to work with Google, and through all the Google events that we have learned so many optimization tips from Google itself and also other developers, which have been implemented very successfully. From March 2018, PowerDirector has switched from IAP completely to subscription model. Other than premium features, we also offer premium plugins, effects, music, and also filters. This is our commitment to the premium subscribers. We continue to offer unlimited content for their maximum creativity. We are very happy that Google introduced the free trial approach. With free trial, we actually see the new subscriber is growing by 3x. And also the revenue upside is 40%. Another example is subscription account hold. With account hold, PowerDirector see the involuntary churn is dropping by 28%, and we see the revenue uplift by another 10%. We also use Firebase remote config a lot for A/B testing. This is for the optimization of our subscription and also ads monetization. For PowerDirector subscription, we also constantly monitoring the conversion rate and also retention rate in different countries. This is for us to calculate the lifetime value and feedback to the upstream CPI campaigns. Localization is very key to our global success. So for example, in Indonesia, we are using Google Play Console store listing to optimize our pricing, our rate plan offering, our messaging, and as a result, we see that Indonesia has become our top 10 country.
结合训练科技在技术引擎以及新功能的持续开发，并且与 Google 团队的密切合作，我们期望带给全球 Video Creator 一个最强大也最便利的影片创作解决方案。
Free Android samples. Hi, my name's Jeremy Walker, and I'm an Android developer advocate at Google. That's right, they're free. Android samples have moved to a pull request friendly location at github.com. But let's take a step back. You may have noticed in the past that while some repos accepted pull requests, Architecture Sunflower, others did not, like the Recycler View or Watchface repos. Why? The origin of repositories that didn't accept pull requests is within AOSP, and GitHub acted as a mirror. This system was made some time ago to help us easily update library versions and separate UI code in samples, mainly around the Holo theme if you remember those days. While it made our lives easier when we launched it, it restricts us more than it helps us now. I mean, we can't accept pull requests. We decided earlier this year it was time to move away from that system, audit all existing Android samples, and move them to a central location on, you guessed it, github.com/Android. As part of the audit, we are bundling simple related samples together into a single repository. For example, if you visit the camera samples repo now, you will see all the samples related to the camera APIs in one location, which is great for discovery. And if you forget and visit the old locations, don't worry, we'll point you in the right direction in the README. For larger established repositories like Sunflower, we simply transferred them to github.com/Android. That means if you go to the old link, you're automatically redirected to the new one. We've now migrated all the repos, so review your contributing file and start creating some pull requests. Thanks again for your contributions over the years. We look forward to many more at github.com/Android.
HelloTalk 致力連接全球外語學習者，讓外語學習變得更輕鬆有趣。我係 HelloTalk 創始人兼 CEO Zachary， 出生喺中國海南，香港長大，留學美國，之後喺韓國工作，多元文化嘅背景帶俾我全球化嘅視覺，所以創辦咗 HelloTalk。我希望每一位語言學習者就可以接觸到外國朋友。擁有真正嘅外語環境。自13年推出以來，深受全球外語愛好者嘅歡迎，至今已經擁有超過1200萬名用戶，並喺2017年獲得咗 Google Play Best of Social 嘅獎項。開發一個全球化嘅即時通訊 App 難度非常之大。Google Play Console 幫助我哋大幅提升 App 嘅品質。
Android Bytos 幫我哋提供咗精細到每款手機應用嘅應用表現性能數據，咁我哋可以迅速針對每一款手機作出優化，減少崩潰，提升整體用戶體驗。通過 Android Bytos，HelloTalk 將即時應用未反應嘅機率減少咗60%，同時 App 喚醒率都減少咗95%。
HelloTalk 借助 Subscription 建立了稳定的商业模式，在推出 Subscription 模式后，收入比过去1年增加了3.5倍。HelloTalk Subscription 的续费率接近75%。另外，我们针对用户自动续费失败的情况，给予了7天宽限期来解决付款问题，使得我们多恢复了约13%的 Subscription 用户。另外，在提供了 Play Store Subscription Introductory Offer 后，短時間內我們的收入增加將近3倍。
HelloTalk 從第一日開始就係全球化嘅交流平台，用戶可以同接近200個國家嘅語言夥伴學習交流100多門語言。通過 Play Console 嘅數據分析，我哋發現日韓兩個用戶嘅流傳率遠高於平均，促使我哋喺日韓兩個本地化嘅語言同埋運營做得更精細、更優秀。借助 Google Play 平台。HelloTalk 嘅應用商店評分從3.7提升到4.3，堅定咗我哋使用新技術提升用戶體驗嘅決心。我哋衷心希望每個人都能流利掌握至少3門外語，有嚟自多個國家嘅好朋友，通過 HelloTalk 體驗多元文化交流帶嚟嘅美好生活。
MercadoLibre es la plataforma de e-commerce más grande de América Latina, con soluciones para pagos, envíos, créditos y clasificados para todos los usuarios que operan a través de nuestra plataforma. Incrementamos un 75% las descargas en el último año, principalmente por 2 razones. Una, porque fuimos agregando muchos features, pero creo que el más importante es que le pusimos mucho esfuerzo y nos pusimos como objetivo reducir el peso de nuestras apps y mejorar la performance.
Tenemos un 65% de usuarios con menos de 2 GB de memoria RAM y aproximadamente un 20% con menos de 1 GB, por lo tanto nuestra base de usuarios tiene dispositivos de muy baja gama en su mayoría y por lo tanto tenemos que programar nuestras aplicaciones pensando en ellos, ya que son la mayoría.
Lanzamos la versión de Android Go. Primero lo que hicimos fue focalizarnos en las herramientas que nos proveía la plataforma Android, siendo Split por densidad, Split por arquitectura y ProGuard. Con ProGuard lo que hacemos es eliminar todo el código que no se necesita para la app final. Después nos focalizamos en los recursos y las imágenes. Las imágenes las convertimos todas a WebP donde pudimos y el código sacamos todas las librerías externas que no nos hacían falta.
Logramos reducir un 70% del tamaño de nuestra app, de 38 megas a 10 megas, aunque este tamaño es dinámico. La baja de peso de nuestra aplicación tuvo efectos increíbles e inmediatos. Ni bien subimos esta nueva versión al store, nuestros installs crecieron un 43% y nuestros uninstalls crecieron un 18%, lo cual nos dio un 25% de crecimiento en nuestro user retention rate. Para nosotros, la experiencia del usuario es lo más importante. Cuando un usuario tiene un crash, no solo es una operación menos, sino que es un usuario que no se va contento de su experiencia con Mercado Libre. Por eso es que miramos muy de cerca la información que nos provee Android Vitals en lo relacionado a los crashes para poder atacarlos. Haciendo foco en toda la información que nos provee Vitals, podemos mejorar el user retention rate, bajar los uninstalls, bajar la cantidad de reviews negativas y subir increíblemente las positivas.
El día que empezamos a ver Android Vitals en la app, detectamos que teníamos un wake clock que afecta directamente a la batería de los usuarios, bastante alto, y gracias a esto lo pudimos solucionar. Y en un caso particular que afectaba a muchos usuarios, logramos bajar el crash rate de 0.3% a 0.15%. Con Android Vitals tenemos una visión concreta de la calidad de la app en todo momento.
El consejo que le daría a cualquier desarrollador que está pensando hacer alguna aplicación para el mercado como Latinoamérica, que preste atención principalmente al peso de la app para descarga e instalada y a la performance de la app. Hoy Android dispone de un montón de herramientas para poder hacer eso de una forma mucho más fácil y simple, así que está al alcance de todos.
Kefir was founded in Volgograd as a traditional startup. A small apartment and several guys that had a great passion for making games. Today we have a big team, more than 150 people, and they are really enthusiastic about what they do. Last Day on Earth, it's our most famous game. It's a zombie survival game. We took the best from big survival games and added a lot of features that hadn't been in mobile games before. And thanks to the reach of the Google Play platform, we were able to achieve global success. Now the game has 80 million installs and has reached $47 million on Android.
We have a lot of communities around the world. The top countries are US, Brazil, Korea, and Russia. We intentionally made the game universal for all the players. We use a universal language for telling our story. No one can really tell where action takes place. We also use common tools that every player can recognize. For example, every player can tell that stone hatchet is for chopping trees. Though the game is globally appealing, we always try to engage our players, and that's why we have dedicated community managers and tech support that work with different languages. We also work with a lot of YouTubers from different countries, making content in various languages. Our marketing team is using various approaches in user acquisition, in pricing in different countries. We do a lot of testing in the game store page. It helps us boost our conversion ratio. But our main focus from the start of the game was increasing engagement, retention, and revenue. One of the first updates was customization screen. So the game starts with creation of your character. And when we added it, it boosted the retention ratio of 6%. We introduced dogs, which can accompany you in your travels. That update boosted revenue. We started using Android Vitals to take a look on app performance, battery consumption ratio. There was a bug, and we couldn't track it down for a long time. But using Android Vitals, we managed to find it. We felt the mobile lacks some good quality survival games, so we weren't totally surprised, but we didn't expect such success.
I'm very proud that Kefir is globally successful. It's not enough to be a specialist in your field. You have to love games with all your heart.
Hi, I'm Ning Yuan, and I'm a software engineer on ARCore, Google's platform for building augmented reality experiences. I will be showing you how to implement face effect using the Augmented Faces Java API in ARCore. Links to Unity and iOS versions of this video can be found in the description. Augmented Faces doesn't require special hardware, such as a depth sensor. Instead, it uses the phone's camera and machine learning to provide 3 pieces of information, in real time synchronized with the camera feed. First, a center pose for the face, which helps you to do things like render a head. Second, region poses, which are useful for placing assets on or near the forehead and nose. Third, a 468 points dense 3D face mesh, which allows you to paint detailed textures that accurately follow facial movements. To get started with Augmented Faces API, we need to create a session that specifies using the front camera. Next, we need to create a config object and then enable the Mesh 3D Augmented Face mode on it. We use this config object to configure the session object. We will also need to provide a pre-allocated texture ID, which ARCore will update each frame with the latest camera image. Next, we need to update our main render loop to call session update each frame. By default, this call blocks the calling thread until the next camera frame is available. We can now use session getAllTrackables to get a list of detected faces, although currently the API returns at most 1 face. Like all trackables in ARCore, each augmented face object has a tracking state. To make sure we are only rendering effects on faces that are currently detected in camera image, we ignore faces that aren't currently tracking. The augmented face object provides you many useful methods to retrieve information about the detected face. You can use getMeshVertices to get a 468 point dense 3D face mesh for the detected face. The mesh vertices are connected by edges. Use getMeshTriangle indices to determine the connectivity triangles between these vertices. Each vertex has an associated normal vector. You can get vertex normals using getMeshNormals. In addition to the mesh, ARCore provides 4 3D poses, which can be used to place objects on or around the face. In ARCore, poses include a position vector and a quaternion, which represents rotation in 3D space. You can use getCenterPose to get the center pose, which is the origin of the face mesh, and is located behind the nose. You can use getRegionPose to get a 3D pose for a named region of the detected face. Currently, ARCore defines 3 regions: nose tip, forehead left, and forehead right. Now you have everything you need to get started with ARCore's Augmented Faces API. You will be able to use your own asset to create custom face effects. For more information about this tutorial and ARCore in general, check out our sample app source code and documentation at these following links. We can't wait to see what you build and hope you share it with using the ARCore hashtag. Thank you for watching.
Hi, I'm Kamina Vincent and I'm the producer at Mountain Studio based in Melbourne, Australia. For me, this program has been very eye-opening, and seeing how other countries are making games and collaborating has been really great. I think for me this program is really important because it does bring very different teams together and people can share what they've learned and help build each other up. It's great to see the support network that's been built here. I would highly recommend this accelerator program to indie developers. What you get from something like this is knowledge that you just can't pick up on your own, or it's accelerated. You get a vast amount of information all at once. You get access to other developers. You build a community and a network around you that you can then lean on. And I feel that's one of the biggest things that we need in game development, is this sharing, this support. And this is a program that really does fast track that.
Hey, I'm Wojtek, an Android developer advocate at Google.
And I'm Ray, a cloud developer advocate at Google.
Together with our friends from JetBrains, we've been working on getting more Kotlin-related guidance into the hands of developers.
That's why we're excited to announce Kotlin Everywhere, a new series of community-led events taking place between May 15th and November 30th.
To help communities around the world organize events, we will provide you with code labs, slide decks, and training that you can use to learn about running Kotlin across the stack on Android, the cloud, web, and other platforms.
And if you're using Kotlin already, you can help your local community by sharing your knowledge, experiences, and use cases at the Kotlin Everywhere events.
And if you're an event organizer looking for speakers, make sure you invite Kotlin experts from your community. Or you can reach out to one of our Google developer experts in your area.
And for selected larger events, you even get a chance to hosting developer advocates and engineers from JetBrains and Google.
We welcome events of all types and sizes, from small evening meetups for beginners to all-day conferences, as long as the theme is Kotlin Everywhere on multiple platforms and devices.
So check out the site and organizer material and sign up to host an event.
See you at Kotlin Everywhere.
Android Q has updated the text classifier API with Smart Reply, new actions, and selections based on understanding the meaning of text. Smart Reply supplies short message replies. Suggested actions include deep links for tracking numbers, opening addresses, links, and more. It's automatically used with messaging style notifications. You can add these features to other parts of your app using the Text Classifier API. You can analyze a list of messages to see if there are any suggested actions or replies by calling Suggest Conversation Actions with conversation text on a background thread. This feature is powered by an on-device machine learning model so that text never leaves the user's phone. Now, if users select text, they can get definitions and translations using Smart Selection because of the new Define and Translate actions. Users can retrieve a definition by highlighting the word and selecting the Define option. Similarly, users can translate foreign text by selecting the text and then choosing Translate. If they click on one of these options, it will trigger action_define or action_translate. These actions will trigger apps such as Google Translate or Google Search. If your app is a dictionary app or a translation app and you want it to show up in the toolbar, you'll need to make a couple of changes to your app's manifest. First, add an intent filter for android.intent.action.translate or android.intent.action.define. Second, your app will receive the word to be defined or translated using getintent.getStringExtra intent.extraText. Third, you will be able to present your app's definition or translation through your activity. The Language Detection API helps you identify what language your users are using from over 120 supported languages. It also uses an on-device model. To use this feature, pass a request on a background thread to the API, including the foreign text, and the response will contain the corresponding language. Using conversational suggestion and smart selection can make your app more intuitive and helpful. Check out the documentation in the video description to see how to add them to your app. Make sure you subscribe to the Android Developers channel for more informative and fun Android videos. Happy coding!
right, welcome to our session on what's new in Android Studio. My name is Jamal, and I have with me Tor today. Today we're going to talk about all the latest new features inside of Android Studio, plus take a deep dive on some things you heard about during the Android Developer Summit keynote. As a framework for our session today, we'll talk about features that are available in stable today, all the way to the bleeding edge features you'll find in the Canary channel. All right, to get us up to speed, let's take a quick step back. At Google I/O, we launched Android Studio 3.5 into beta. There we focused on system health, feature polish, and our bug backlog. Just this past month, we launched Android Studio 3.6 into the beta channel. That had things like view binding support, emulator with integrated Google Maps, design tools improvements, and Kotlin and JNI support. And today we're excited to talk about a little bit more about Android Studio 4.0. Okay, with this context, let's talk about what's inside of our stable channel today. To recap, Android Studio 3.5 focused on three main pillars: system health, feature polish, and our bug backlog. Now that all culminated in something we called Project Marble. Now specifically, Project Marble included a number of smaller projects that our team worked on across the board. Things like crashes, improvements to apply changes, hangs, CPU usage for the emulator, R8 improvements, and our bug backlog. Now I want to talk about some of the improvements, but also the successes of Project Marble for your awareness. Okay, one of the first issues we talked about and worked on was around hangs and latency. For this specific example on the screen, we looked at XML typing and data binding. What we found is there's some critical bottlenecks we had in typing. So we analyzed and improved those things. We did that not only for XML, we did that for Java and the Kotlin programming languages as well. Another pain point we heard from you is about memory. And the symptom of this is that, hey, the IDE is slow and not responsive. And the root cause of that is actually the memory issues itself. So the first thing we did is actually create a new set of infrastructure and dashboards to catch these issues as we checked in code into Android Studio. And of course, we can't catch everything. So then we added a new set of client-side analysis for you. So if you notice if Android Studio is slow or sluggish, you can now create your own heap dump and have a sanitized version of heap dump you can share with us, so we can understand what's going on with your machine and how to best solve those problems. Then lastly, we heard a lot of people complain about sort of the overall speed of Android Studio. And what we found from the opt-in data is that a lot of people are using the default settings of Android Studio. Well, this is fine for intro projects and beginning projects, but as your project expands, you add more functionality, you can actually increase your heap size for better performance. So if you ever see this pop-up menu come up in the bottom right-hand corner of Android Studio, please look at that and accept those settings. We've actually applied some analysis and some models to understand how to best configure your Android Studio and your Gradle plugin to have better performance. So speaking of the build speeds, so we spent a lot of time during Project Marble to look at how to improve build speeds. So before Project Marble, we had about a 12.5 second average build speed, and we drove that down to about 9.5 seconds post Project Marble. Digging a little bit into the data you saw this morning, specifically, we're actually working on build speeds along the way from 3.0 all the way to 3.3. But what's happening, we notice, is that projects are just becoming more complex. Either if you added annotation processors or more features to your build speeds, it's just slowing down and you weren't able to keep up. So in the 3.3, 3.4 timeframe, we now were able to stabilize that. And what we're excited about is with Android Studio Gradle plugin 3.5, we actually have seen a decrease in build speeds. So if you haven't moved to Android Studio Gradle plugin 3.5, I highly encourage it to take advantage of all the major improvements for build speed. And the last thing we looked at for us is on deployment speed. So deployment speed is the time it takes for you to make a change on Android Studio and see it on a running device or emulator. So the median before Project Marble was about 7.9 seconds, and we drove that down to about 3.6 seconds. And that was all around the feature called Apply Changes. And Apply Changes, if you don't know, is the replacement to Instant Run. And Apply Changes is a fast, iterative way to make changes to your application. So if you haven't been using Apply Changes, I highly encourage you to use that as well, because that will dramatically improve your incremental change and workflow in developing with your app in Android Studio. All right, so recap, we've done a number of improvements for Project Marble, and we're really excited about those things. And thank you to all of you who filed bugs and shared with us opt-in data. Without that information, we wouldn't know what to prioritize to make things better for your development. But quality is definitely not done, but we set a new quality bar for ourselves that we want to maintain going forward. So with this quality bar set forward for ourselves, we want to continue working on new features for Android Studio. So today, we're going to give you a preview of a lot of new things we're working on inside of Android Studio. But before we migrate those features from Canary to Stable, we're going to prioritize and assess those features and match them to the quality bar that we set during Project Marble. So instead of talking about all those cool features we added to Android Studio, I'm going to have Tor walk us through some of the cool things we have inside of Android Studio.
All right, thank you, Jamal. So one thing we hear over and over again is that you want your builds to run faster. And as you just saw, we've been making some good progress. But as you'll see shortly, just speeding up the Android plugin is only part of the puzzle. So when you want to write your apps and make them faster, you run a profiler, right? Well, what we've been working on is a profiler for your builds. So I'm going to show you what that looks like. So this is the Santa Tracker project with some deliberate build mistakes that I've added in. And after you build now, you get this new build speed task, one for each build that you run. And this gives me a breakdown into what happened during the build. So for example, here I have a breakdown of all the tasks that determine the build duration. Right? So this is showing me the tasks that are on the critical path. There's no point in trying to optimize a task that is not on the critical path. You make it faster, you're still waiting for a longer task. Right? We also give you a breakdown of the build time for each plugin. So you can see here, I have a plugin that's taken up 40% of this build. This happens to be a third-party license plugin, so what it's doing is very valuable. It's fetching license files over the network and inserting it into the help menu. But maybe I don't need to do that on every single full debug build, right? So I can maybe investigate doing it in release builds. So this gives me an insight that I can then go and do something about. We also tried to surface a bunch of problems in the build. So for example, always run tasks. Tasks should only run when their inputs have changed. But as you can see, these tasks are not actually declaring their inputs, and that means they're going to have to run every single time. So if this is your task, then you know you should fix it. Otherwise, you should contact the author and ask them to fix it. Another problem that we pinpoint for you here is task setup issues. So if you configure multiple tasks to share the same output directory, then they can't run incrementally. So if you do that, you're breaking incremental compilation, and again, we're surfacing that to you right here, listing the tasks that are conflicting. Non-cacheable tasks, this is pretty important if you want to use the distributed cache. These are not going to work. And then, of course, non-incremental annotation processors. So if you use an annotation processor that's not incremental aware, it'll force a full rebuild. And they all have to be incremental aware. Now, we've been working on a lot of them and working with annotation processor authors to actually update to Gradle support for incremental APIs. And so in some cases, it's as easy for you as updating to the latest version. So when we know, for example, here, we're telling you auto value, switch to version 1.6.4, and your build will run faster. And then there's configuration time. So configuration is where tasks are created, whether or not they're going to run. This is supposed to be a very fast operation. But some plugins will actually do a lot of computation during configuration. I've actually created a slow one here that waits for 2 seconds. That's, it's simulating, doing lots of computation that you shouldn't. But this gives you a chance to sort of dig in and see exactly what's going wrong. So as I mentioned, you get one build speed tab each time you invoke the build. So I did a full build here for about 3 minutes, 2-3 minutes. I then did an incremental build. So now I can see the breakdown of what happens in my incremental build. You can see the licensing is no longer the issue here. And so by breaking this up for each build, you can decide whether you want to optimize for CI, the full build scenario, or if you want to optimize for your incremental build in the IDE, or preferably both. But you're probably going to have more value out of the incremental build since you do those over and over and over again. So that's the new build attribution feature that we have in 4.0. It's not actually in Canary 1, but hopefully we will land it soon. All right, so while we're on the topic of Gradle, we now support the Kotlin Gradle DSL. So that means that you can write your build files in Kotlin, and that's really good for the IDE because we can reason about Kotlin. It's statically typed, so the editor support is better. And so, for example, code completion now, if you've ever wondered what you're allowed to configure inside default config, well, wonder no more. You can see the exact list here. Similarly, lint options. If you want to know what you can invoke and what you can customize, they're listed here. And you can also pull up docs for the DSL, which is pretty handy right from the IDE. We also run lint on your KTS files. And in 4.0, the biggest amount of work for us was to implement the ability to read, analyze, and write these build files. So the product structure dialog now also handles Kotlin DSL. So I can go in here and I can accept these suggestions to update to the latest version of these libraries, for example, and then hit update, and then it's going to rewrite the build file and run another sync. Okay. Let's see, let's go to number 2. So let's take a look at the compile options section. You'll see this new flag here called core library desugaring enabled. So this is for a new feature in 4.0 called library desugaring. And this lets you access APIs that normally require a higher API level on an older API level. What we do is we rewrite those calls into a backport library that we bundle with your app. So let's take a look at what that looks like. So here I'm using Java util stream, and lint tells me that this is going to crash prior to API level 24, right? So you can't use it, right? Well, now if you turn on library desugaring, it's actually complaining in this module because this code isn't in the module where it turned on library desugaring. But if I switch to the same code in my library desugared module, you can see lint is happy because this is going to work. And let me show you the bytecode to see how this works. So this is the same method I just showed you. And if we look at the bytecode, you can see that Java util stream has been replaced with this $util stream. That's basically the backport library. And it's good to be aware of this because you might see these package names in stack traces and debugger and so on. And note that this is not limited to Java util stream. You can use this for java.time. You can use it for java.util.function, java.util optional, and we even rewrite references to concurrent hash map because it turns out that on some devices, concurrent hash map has a really bad bug. And so by using this feature, we will just replace your concurrent hash map usages with the safe one, and you won't be bit by that bug. All right, speaking of DEX and D8 and R8, for code shrinking, we still use ProGuard files to drive the process. And so in 4.0, we've improved our support for ProGuard files. We have better code completion. We have go-to declarations. And the most important part is that it is now find usages and refactoring aware. So if I, for example, rename this class that happened to be referenced from a ProGuard file, and I apply that refactoring, you can see that the ProGuard file is also updated. So no more stale ProGuard files after this. All right, so back to our Gradle file again. I've also turned on view binding. So view binding is very much like data binding, but it is easier to use, and it has a smaller impact on your build speed. So once you turn this on, it'll create a binding class for each one of your layouts. So here's a class that first does things the classic way, right? So we have a set content view where we pass in a layout resource. Then we fish around in the view hierarchy with these find methods. We apply a cast, that'll hopefully work. And then we take our chances accessing that object. With view binding, what we do instead is we access or inflate the layout with this generated binding class. And now we get this binding instance which knows exactly which views are present in the layout. So in this case, text view is present in all versions of activity main. So that means that we know it's non-nullable, and it's safe to access. I will have no null pointer exceptions with this one. View binding knows that button is actually missing from one of the layouts, so it's marked as nullable. And if I hadn't used the Elvis operator here, Kotlin would have refused to compile. So view binding is great for catching nullness, and it's also pretty good performance. All right, so view binding makes it really easy to access and update your views. But we're working on a brand new framework to make it even more powerful and easy, and that's Jetpack Compose. So this is Hello World from Compose. So what we do here is we can take an existing composable or a widget, and we can wrap it in our own function and customize it with some arguments. And as soon as we put a composable annotation on it, voila, we've created our own widget. And we can also mark it with this preview annotation, and then it shows up in a preview pane inside the Kotlin file. This is a bit like our sample data support in the old layout editor, but now applied for Compose. And so we've created our own widget called greeting here. We can take that further, and we can throw a for loop around it and other conditionals, and we can wrap it inside another composable. So you compose new widgets by adding composables. So the name makes a lot of sense. So we have the preview again, and note that this preview is not limited to one. So here I have a button widget that I've created. It has 2 states, on and off. And notice how I can preview all the states, including in dark mode as well, which is pretty handy. And here's an even more complex example from our newsreader app. So this is a card we use to show available stories. And here you can see we're also showing you, for example, what this looks like with a larger system font. So the embedded preview is really great for tweaking your views, as well as seeing what they'll look like across different dimensions, like theme and font size and things like that. But sometimes you really want to run the app to modify the behavior. And so I'm very excited about this next feature. If you watch the keynote, you've already seen it, but I'm still excited about it. This is a feature I've wanted since before Studio 1.0, but it was very technically challenging, but the team is in the process of pulling it off. And that is, of course, the ability to have the emulator embedded inside the IDE. Yeah, I love this. So this is the real emulator, right? It's not just simulating the app in isolation. I can install accounts, I can launch intents, and all that. And what's nice about having it inside the IDE is that it participates in window management, right? So if I'm the source editor and I want to focus, I press the key binding, I'm in my editor, and I can bring it back very easily. So it's super convenient. So this is my Compose app running. We can drill into it here. And let's click on the bookmark icon. And when I do that, I'm launching an intent. And that's actually not what I wanted to do. So I've introduced a bug in the app. So let's just go and fix that. So I'll jump to the related code. This is the toggle bookmark code. Oh yeah, I had a to-do here. And a stop ship marker too. Let's try apply changes. And it's now reloaded the app, and I can invoke the bookmark, and it works. So this combination is pretty productive right here running in the IDE. One last thing I'll mention about our Compose support is we're working pretty hard on making the editor experience better, right? So for code completion, for example, we are ranking composables to the top. Notice that we're also, normally you'll have types on the right, but we are removing types from the right so we have more space to show you all the parameters. We're hiding defaults. And we also have a special code completion insert handler. So if I, for example, insert a row, if I don't enter anything as a parameter and I hit enter, we remove the parameter list and so on. So we're trying to make this editor really smooth as you're working on Compose. OK, we're also working on the classic view system. So let me switch over to the layout editor. It's the Sunflower app. So here's an XML file. Now, do you remember how in the Compose file we included the preview right there in the source editor? We've done the same thing for layout XML files. We used to have a separate tool window, and in the layout editor we had design and source tabs. What we're doing now is instead we have these 3 buttons at the top. This works in Compose, it works in the layout editor, and you can use key bindings to quickly map between them. So if I press Control-Shift left here, hold on, I'm in pure source. If I go to the middle one, I can have them side by side. And if I go all the way to the right, I have the full layout editor. And this also works for custom views. So here I have an Android custom view. And I now, within the Java or Kotlin editor, I can see my custom view. When I'm tweaking the painting code, it's right there. It makes it a lot easier to work with. All right, so let's look at the layout inspector. So I'm going to run this app. And again, open up the emulator. All right, so this is the layout inspector. And actually, that's not. That's the app running. This is the layout inspector. And it's going to attach to my running app. Let's see, OK. It's already connecting. So what it's doing now is it's going to pull down the whole view hierarchy. There it is. Let's give ourselves some more space. So the first thing I can do here is I can click on various views, and I can see their values. We had that in the old layout inspector. But what's new is this declared attributes section. So here you can see resources that are coming from binary resources or XML resources. So let's take a look at the label add plant. Where's that coming from? Well, I can expand that, and I can see that it was actually specified right there in the layout file. And I can continue with the whole resolution stack and see the exact line and language that it came from. Now, normally, it's not difficult to find where a string came from. You can just search for it. But what about colors? So you can see that this button has a green color. Where's that coming from? And again, I can expand, and you can see we have multiple alternatives here, and it's probably too small for you to see. I mean, I can barely see it from here. But there's strike-through on all the theme references for material, where this color would normally be specified as gray. Instead, we have some other attributes that have higher priority that are winning. So I can see that the real green is coming from this local layout reference to a theme attribute, which again, we can chase down the values for. So this is a bit like the Chrome DevTools, right? Where you can sort of investigate the whole resolution to figure out why, oh, why is this text, whatever font or color you're concerned about. One other thing to point out is that this inspector is not just a static dump of the view hierarchy. It is optionally live. So if I go up in my running emulator, click, for example, on the plant list, you can see that it's now going to fetch all the surfaces and stay up to date. So I can continue to see what's happening in the app. And one really nice thing about that is that I can now drag this in 3D and see the full view stack here. And the really useful thing is, look, we have a full texture sitting back here. And notice how we're showing you textures that are hidden, right? So this is not just a screen grab from the device. We're getting all the surfaces because this is running on Android 10. So we had to actually add some support to do the value tracking and this bitmap fetching. But now we can see that we have this texture hidden by this screen. So this is overdraw, this is bad, and this tool makes it easy to track down those kinds of bugs as well as issues with clipping. So that's the layout inspector. Right. Let's talk about the motion editor. Right. So here I've created a very simple constraint layout. And what I want to do is I want to animate this so that it's a bit more lively when this layout shows up. So what I do is I open up Convert to Motion Layout. This will migrate my layout into a motion layout plus create a scene file that's going to store all the keyframes that we're about to create. So the first thing I can do is to select the start state. So we have start and end, right? I'll select the start state, and then I'll start changing some of the constraints in the scene here. So I'm going to be deleting this to move the text to the top. Let's also attach this button to the bottom. And now we've already created ourselves an animation. So if I switch to the transition view and I hit play, you can see it's now going to start animating this. And we can go and turn on showing paths so you can sort of see these lines here showing how these widgets are going to move. So the next thing I can do is I can try to make this motion a bit more interesting. So I don't want a linear path for the label. So I'm going to now add a keyframe, a position-based keyframe, on the text view. And I'm going to have the type be relative to parent. And let's move it about 100%. I just learned, by the way, that in Android, we use 1-based percent, which doesn't make a lot of sense. All right, so now you can see now that the motion is a little bit more interesting, right? We can also fade in the button from the bottom. So what I do then is I add a keyframe based on an attribute. So we'll pick the alpha, and we'll put this on the button. So now this is going to fade in from about 0.5, and we can change that to be, let's start from completely transparent instead. So now this button is going to fade in. And let's add some rotations, because I like rotations. So another key attribute. And this time we're going to be rotating the text view. So rotation on alpha. It starts out at 45 degrees. I like to give it a bit more spin, because rotations are cool. So let's do 145. And we should also move it off screen, so it doesn't start in the middle. And so to do that, I will first select the state text view, and then we'll add bottom padding here, let's say 300 or so. All right, let's see how this is starting to look. So when I play, okay, we got some motion. Yeah, so you can see that you can really go overboard. Do you remember the web in the old days with the spinning logos on the web page? Yeah. Don't go too far, but with some tasteful design, you can really accomplish a lot with this tool. So let me switch to a slightly more complex layout. So what you see here is just start and end states, right? Well, that's just the default. You can also create many other states. So here I have a base state. This is just a bunch of cards laid out with different colors. I have this other state where all the cards are on top of each other. And then there's a third state where they're all sort of off screen up to the left. And now you can sort of sequence the transition between all these different states exactly how you want them. So we can have this transition, we can have this transition, we can have, let's see, I chose a state. We can have this transition, and let's check out the translation curves down here too. So you can do really advanced things with this tool. The last thing I want to highlight is that you can easily also create click and swipe handlers. So when you do that, Motion Layout is going to add the code for you to basically add listeners. So if I add a swipe handler, for example, the user can swipe, and then Motion Layout will scrub through the animation, a bit like the quick settings pull down on Android. You can do this through the tool, which is pretty fantastic. There is so much to show here that I don't have time to get into. But the good news is if you stay in your seats for 2 or 3 more hours, there's a whole talk from the design tools team that are going to show you sort of all the goodies that I couldn't show you today. All right, so a couple more quick things to show you. First of all, we have in the resource manager, we've updated the vector asset wizard with brand new clip art. So the materials design website has many icons. We've added them. More importantly, we now support all the different types. So you can switch from, for example, filled icons to outline icons to even the two-tone icons. So hopefully you'll find that useful. Another thing we recently did for editing is we ported all of our Android live templates to Kotlin. So if I, for example, want to add a logging tag into this class, I just type log t, hit tab, and this will create a logging tag for me based on the current file name, right? And more importantly, or more awesomely, if you ask me, log m, this one will basically log the current method name with all the parameters, right? And if you want a block structuring comment in between SBC tab, you can type in your comment, whatever. So what you want to do is open up the Live Templates UI, Live Templates settings, and browse through all of these, right, to learn what tags you can type in with tab. It'll save you a lot of time, I think. All right, next I'm going to show you some stuff in the emulator. So look, it still also runs standalone. So if I pull up the options, Android now supports multiple displays. And so we made it really easy to test multiple displays in the emulator. All I have to do is go in and add additional displays. I can tweak what kinds of density I want, so it's suggesting this layout right here. If I hit Apply Changes now, you can see I have my emulator connected to multiple displays that I can then start interacting with. Yeah. So definitely give that a try. All right, we've also made it easier to test locations. So let's say I want to test motion. Let's say I have some sort of fitness app or whatever. What I can do is say, I want to navigate to the Googleplex. And I'm going to start from where we are right now, which is Google Building MP7, I think. I can now save this as a route. I'll call it demo. Save. And now I can play this route. And let's see what happens if I go into Google Maps here in my, on my emulator. If I click the Where Am I icon, it's now supposed to be showing us that we're moving. And we are. All right, I think, unless I forgot something, I think that's my demo. So now I'm going to turn it back over to Jamal, and I hope you enjoy Studio 4.0.
All right, so some really cool demos. Unfortunately, we don't have time to demo everything, so I'll spend a few moments talking about some additional features we're launching inside of Android Studio. So first, we're updating dynamic features. So as you know today with the dynamic features, I can have a module feature connected to the main module. What we're updating is that now you can have feature-to-feature dependency. So let's say I have a camera module, and I want to add a video module to that. So now I can have a direct dependency to camera module without having a direct dependency on the app module. So that's a cool feature we've added for dynamic features. Another thing we added behind the scenes is actually improvements to the layout editor. So actually what we did, we took the rendering libraries that we have on the devices and put them directly in the IDE. So things like Skia and ICU are now available inside of Android Studio. And what that enables is two important things. One is the performance. So all the demos you saw Tor using, it's that reactive performance that's there. And two, having higher fidelity accuracy. So specifically, things like improving text justification modes now supported, having detailed shadows, or having 3D perspective, or having text path rendering are now available inside the layout editor. So this is all happening behind the scenes and helping you to have a better experience inside of Android Studio. Just as a quick update, we also did a big pass and update on our templates for fragments. So we have a new wizard that's there. We updated all the templates for fragments. So if you use fragments, check that out as well inside of Android Studio. Now, a big update for the Android emulator is something we're calling kind of this dual ARM x86 support. So let's say if you have any C++ code today that had ARM support only, you weren't able to use the x86 emulator because that didn't support the fast experience. And so today we have a special version of the emulator that supports both ARM ABIs and x86. So I can run that legacy or C++ code on one emulator and have that fast x86 experience. So we just released this on one version, and we're really looking for your early feedback to make sure we have all the right use cases and scale this out as we add more features to this going forward. I also have an update on Chrome OS. So at I/O, we talked about having full first-class support for Chrome OS for Android Studio. And one pain point for that is that if you wanted to debug your app or deploy your app, it required you to have an external Android device or boot your Chrome OS device into developer mode. Now that's no longer needed. You can do all your end-to-end development right inside of a Chrome OS device. So with the upcoming release of M80 of Chrome OS, you can now do your development, debugging, and deploy the app right directly into Chrome OS to see it running inside of the Chrome OS laptop. Okay, so we talked about a range of features that we're releasing, things in the stable channel and also things in the bleeding edge features on the Canary release channel. Now let me talk about the Canary release channel. Of course, it is bleeding edge, right? A lot of things are just in development and we're trying to explore things that are going on. And to that end, it's actually very lightly tested. So we do recommend running both stable version of Android Studio and the Canary version of Android Studio. And you can do that as long as you have your Gradle plugin tagged toward the stable version of Android Studio. You can run both in parallel on the same project with no issues.
But for build attribution, you'll need 4.0.
Yes, we do. Yeah, that's true. But as far as feedback goes, we do encourage you to use Canary because it's the best feedback channel for us. If you found an issue or a bug on stable, it's a little too late for us. We've already moved on to the next version. So if you like the features you saw today or want to give us feedback, please use the Canary channel for that feedback mechanism. But even more importantly for us, we're actually very quality driven. Going back to my earlier point about Project Marble, we set a new bar for ourselves for quality. So some of the things you might see in Canary may not make it into the initial version of stable because it may not be ready. And that's okay, because we want to make sure it's stable and has a high quality release before we make it out available to you in a stable release version. Okay, so we talked about a range of things today. And to kind of recap, we talked about some things that are actually in Android Studio 3.6, things like the multi-display mode, design tools updates, and the IntelliJ update for 2018.2. And then things like the Jetpack Compose motion editor support, those are inside of Android Studio 4.0, which is currently available in Canary. So please check those out as you're trying out Android Studio. And with that, please download Android Studio Canary to try these features out. Again, I'm Jamal, and I'm Tor, and this is Tor, and thanks for coming to our session.
Zomato was started as an app which lets you browse digital menus. Now we are this big food tech company that is operational in 24 countries. More than 150 million users visit the platform every month. We are available in 10 languages. And on the delivery side, we have a fleet of around 60,000 delivery riders. If you want to discover great places to go out, if you want to order in, if you want to reserve tables, and if you just want to browse food, you can use Zomato. So Zomato serves a lot of use cases, and that makes it challenging for the development team to fit in a coherent way inside the app.
After all the buzz in the developer community about Kotlin, I was intrigued by how Kotlin was able to uphold the object-oriented paradigm and solve many of the architectural flaws in the compile time itself. I almost instantly recognized that Kotlin will enable me to develop more architecturally sound applications. Kotlin provides us with null safety at compile time itself, and this is one of the most used features by our team. If you convert a Java class to Kotlin, there will be about 15 to 20% decrease in the line of code. But if you take data classes, there is a drastic improvement of about 55% decrease in the lines of code. Switching to Kotlin is efficient and really exciting. At Zomato, now almost every new feature is being developed in Kotlin. We as Android developers have not experienced the functional paradigm like the developers of JavaScript. So Kotlin providing a function-oriented style of coding was a very good feature. Often a use case comes when we are using code of third-party libraries, where we want the class to have another function. Kotlin makes this hassle-free by the support of extension functions. Almost all the new SDKs and APIs that Google is releasing right now has Kotlin support. On top of that, the third-party library developers are also adding support of Kotlin, which is increasing our Kotlin experience.
Zomato is rated 4.3 on the Google Play Store, and we've been lucky with the support of the ecosystem that Android provides.
I would recommend switching to Kotlin because of its interoperability with Java. With recent updates, Android Studio has drastically improved Kotlin support. It is almost frictionless.
We see a lot of growth in emerging markets. A lot of those markets are mobile first, and some of those users actually access the internet for the first time with their phones. Most of the time, the phones that they use are based on Android. Optimizing your application for Android is something that is very important for us as we look forward to delivering a great experience in those markets. App size is a very important consideration for Netflix. It has a direct impact on the install rate. When Google announced App Bundle and dynamic delivery, we were very excited about it. It had a lot of potential for us to leverage and optimize the size of our application.
To migrate to App Bundle and dynamic features, we had to first decide what to modularize. We considered any sizable component with limited usage, for example, language-specific features. We made one of our features contacting the customer support dynamic. So if a user really needs this feature, then they would go to help section, and then this feature will be downloaded for that user. With the migration to App Bundle and dynamic features, we were able to reduce the app download size by 33%, size reduction from 23 megabyte to 15 megabyte. We have few more features to make them dynamic, and we're expecting further savings in the coming months.
Hello, my name is Chris Baines, and I'm an engineer on the Android Developer Relations team.
I'm Rohan. I'm a PM on the Android System UI team. We're going to be talking to you about going edge to edge. So for those of you who don't know what the term is, we'll get into that, but I kind of want to set the stage a little bit and talk about navigation. So about 5 months ago at Google I/O, we talked about gesture navigation, introducing it as an initial version in beta. And since then, we've done a lot of work to improve it, worked with a lot of device makers to basically standardize a lot of that across the entire ecosystem. So just kind of want to give you an update. Basically, with Q, almost all of our major device makers will be shipping with gestures on their device. Just want to give you a quick idea of the scope of the problem. This is super exciting for us, and the main gesture system that they will be shipping here is the one that you saw at I/O, where you swipe from the bottom to go home, you swipe from the left and right edge to go back, and you can swipe and hold from the bottom to go to recents. So what does this mean for Android Q? Basically, you'll be seeing 2 nav modes in Q. So this is the 3-button mode that most Android folks really, really love, and then this new gesture nav mode, which is meant to be a little faster and more responsive. So 3-button mode, one of the big changes for Q, as you may have heard before, is that it will now be required on all devices. There's a lot of accessibility needs around it, and frankly, some people just hate gestures. So we definitely acknowledge that, and I think that's something we want to keep as a staple in Android. Gesture nav will optionally be available, and most of our device makers are picking it up, but it can be the default out-of-box experience, or it can be just another mode that a user can pick from settings. So now kind of putting this into context for this talk, going edge to edge. What does all this mean to you? Why is any of this really important for you? So a lot of the reasoning or motivation behind gesture nav came from users wanting more immersive experiences on their phones. And one way we did that was approaching it from a system perspective by introducing gestures, getting rid of the nav bar a little bit more. And now it's kind of more up to apps to bring that delightful experience to users. It's something that users see as competitive and genuinely a good user experience. A second part of why you should care is gestures. Well, gestures are going to have some level of conflict with your app. So we want to make sure you're well prepared. So this talk will kind of be going into how you can make sure your app is nav ready. There are 2 things that we'll be talking about here. The first one will be going edge to edge, which Chris will go into. And the second one will be handling gesture conflicts, which I'll take over. Cool, so I want to hand it over to Chris.
Thanks, Rowan. So Rowan just mentioned the term edge to edge. Now, it's kind of a weird term, so what does it actually mean? So by this, if you create an Android app using Android Studio and using the new template, you'll get something like this, where the bounds of your app are below the status bar and above the navigation bar. Now, what we want going forward with edge to edge is for that navigation bar to disappear and for your app's content to shine through behind it. So when the user scrolls, it looks a bit like this. Your content scrolling behind the nav bar, drawn right to the bottom of the device screen. So drawing behind the navigation bar is now strongly recommended on Android 10. We're not saying it's mandatory, but really you should be looking at doing it. It's optional before Q. When you run on sort of devices before Android 10, it's optional. But a lot of the work you need to do to make it work for Android 10 is also applicable for before that. So it's your choice, but you kind of already put the work in anyway. Similarly, for the top of the screen, we also want something similar, where the status bar background disappears, again, allowing your content to shine through. Slightly different here. Again, the content showing behind as you scroll, but the recommendation's not quite as strong. It depends on the type of content you have. If you tend to have a lot of imagery near the top of the screen, it works. If you just have lists of items, probably not. Again, optional before Q. So we just talked about what edge to edge is. Now let's talk about how we actually get there. So there's 3 main steps to going edge to edge, which we'll go through now in turn. The first one is changing the system bar colors. So the first thing to know is that the system, as in Android 10, the system, will help you going forward. So here you can see that as the user scrolls, the navigation bar behind it is actually changing color based on the content behind it, allowing the user to actually see that bar behind that dark content. That is what we call dynamic color adaptation. So it's one of the forms of protection for the contents, which the system provides for you. The second type is the translucent scrim, which you can see here at the bottom. So as the user scrolls, there's like a translucent background behind the navigation bar to protect the content, allowing the user to see it. Now, this is shown on button mode. So if the device is set to button mode, this is what will be shown. But the one gotcha to this is that the translucent screen will only be shown if your target SDK is 29 or above. So this is one reason that you also need to start testing on all navigation modes, as well as the different API levels. We also then need to tell the system that we actually want to change our system bar colors. You as apps are in control of that color, and by default, it goes to color primary dark or black for the navigation bar. So to actually see that content behind, we need to tell the system that we want it to be transparent. We can do that using the navigation bar color attribute. Now, because we're only talking about really Android 10 here, and that's the strong recommendation, we've set it in our values v29 folder. But if you're supporting back to pre-Android 10 as well, you might use it in your values. Now, before Android 10, because the system isn't responsible for that background protection, you need to do it yourself. And you can do that using a transparent color, a translucent color. In your light theme, you'd use typically a translucent white. Or in your dark theme, you'd use a translucent black instead. 70% tends to be a good value to start from, but it depends on the content that you have in your app. If you have a lot of imagery, you might need to bump the alpha value up. If it's just text, you can probably bring it down, but play with it as you need. The second step is that you need to request to be laid out full screen. As we said earlier, normally you'd be displayed below the status bar and above the navigation bar, and we want to go full bleed to the whole device height. We're going to use the Set System UI Visibility API, which has been around for many, many years, using 3 special flags. There's layout hide navigation, which tells the system that we want to be laid out as if the navigation bar wasn't there. So behind it is what it results in. The second one is layout full screen, and that's a similar story, but for the top of the screen, the status bar. And then there's a special flag called layout stable. I'll point you to the docs and look at what this special flag does. But the API, as in the Set System UI Visibility API, takes a number of flags, and it can affect how it works. So have a look. But the key takeaway from this is that these 3 special flags are what you need to use. So once we've done that, we go from this to something like this. But you can see that the fab, the floating action button, that bottom right, is now being displayed behind the navigation bar, which isn't great. And that leads on to step 3, which is avoiding overlaps with the system UI. And that brings us on to the topic of insets. Now, insets as a term tends to strike fears into the hearts of developers. Insets, at their most simple, are just a collection of values that tell you how to move something in by. Kind of the inverse of an inset would be like a safe area. And what content to move depends on the inset type. We have a number of types, which we'll go through now. How you use or how you actually apply them changes. So let's go through them. The first step is called system window insets. Now, these have been available in the framework since API 1, very, very old. And they tell you where on screen the system UI is being displayed above your app, as in the Z order. They are typically used to move clickable views out of the way. So that fab example we spoke about earlier, we typically have this. So here we've got a fab at the bottom right, and you typically have 16 dips of margin on it, which are denoted by the arrows. Now you can see here that it's slightly overlapping the navigation bar, which isn't the end of the world, but it's not great. Really, we want to move it up, and so that the fab is nowhere near the navigation bar. It's much more obvious in button mode, as you can see here, because the fab is being pretty much overlapped by the navigation bar in its entirety, and the user can't click on it. So really what we do is push it up. And we do that using the system window insets. That's the value you use. The next gesture inset type is called system gesture insets. And now these are new in Android 10. And they represent the areas of the window where the system gestures, the gestures that Rowan spoke about earlier, take priority over your app. So visually, they look a bit like this. On the vertical edges, we have the back gesture. So as you swipe in from the left or right edge, the back arrow comes in and the user can go back. Or from the bottom of the screen, the user can go home by swiping up from the bottom. In terms of how you use them, they're typically used to move draggable views out of the way. But we'll go through an example of that later. The final gesture system inset we're going to talk about is the mandatory system gestures. Now, these are a subset of gesture insets, and you wouldn't typically use them directly. But apps, which Rowan will talk about in a bit, apps have actually effect on where the gestures can work. They have APIs where you can actually tell the system, I don't want it to work here. The mandatory system gesture insets tell you where that API doesn't work. The system keeps these gesture areas available only to the user. Currently in Android 10, that represents the bottom area, the home gesture. And that is because it should always be an escape hatch for the user. An app should never be able to trap a user in their app. So as a quick summary, system window insets, clickable views, gesture insets, draggable views, mandatory system gesture insets, you wouldn't typically use directly. So we just talk about gesture insets. Now let's talk about how you actually avoid overlaps. So we're going to use the ViewCompat API, specifically for the apply window insets method. So window insets is an API which has been around for a while now. Now you can set a listener on a view, and then the next inset traversal, what will happen, that listener will be called. And from there, we can do something with those insets. One tip is that you should always try and use the ViewCompat method. The API for window insets has changed over the years. The API now matches what we have on Android 10. So you'll get the same API from the framework that you would all the way back to API 14. And it also has some fixes for bugs in the framework. So make sure you try and use that. In terms of window insets, there are 3 main methods you're going to use, and they map directly to the different types of insets we spoke about earlier. The return type is an insets object, which is just a value type which has a left, a top, a right, and a bottom. The values are ints, and they represent pixel values of the size of the inset from the edge. So the top one will be, say, 40 pixels from the top edge inwards, and same for the other edges. So let's go for a very quick example. Here we have a very simple app, and we're going to go apply all of our changes. So the first thing we're going to do is change our navigation bar color, and we get this. So you can see that the navigation bar is gone. Secondly, we're going to go edge to edge. We're going to want to be laid out full screen, so we're going to use the system UI visibility method. And then we get laid out behind it. But you can see that the bottom navigation, the view, is being overlapped by the navigation bar. So we want to fix that. So we're going to set an on-apply window insets listener. And from there, once we get some insets, we're going to just add some padding. And once we've done that, we go padding. And then once we've done that, we'll go from this to this, which kind of looks good. Padding tends to be what you want to use on a view because you want to move the content in rather than the actual view itself. But you could also use margin. So in the fab example we showed earlier, you probably want to move the whole view up rather than actually use padding. So yeah, you can also use layout. And it will look a bit like this. So let's go for a slightly more complicated example, which is a button bar. Typically, you might have seen this from like Google Photos. Visually, it looks a bit like this in terms of its background. And how it's implemented is a very simple horizontal linear layout with 32 dips of padding. But after applying all of our steps, we get this instead, which obviously doesn't look the same. We've lost all of our bottom padding. And the reason for this is that because we're using update padding in our on-apply window insets in our listener, we're actually wiping out that 32 dips from the layout, which is not what we want to do. The 32 dips of padding from the layout is our intention. It's what the design is. So we want to keep it. So one way around this is that you could actually record the padding outside the listener and then just add them together within the listener. And we get this instead. So once we've done that, you can see that the 32 dips of padding is still there, but we've also moved the view up from the actual navigation bar size. We actually wrote a blog post that goes into far more detail over the kind of ways you can work around this and better things like you can use data binding or even Kotlin extension functions. So make sure to check out that article if you want to know more. Then hand to Rowan to talk about gesture conflicts.
Thanks, Chris. Cool. So Chris quickly talked about edge to edge. I'm going to cover the second part of it, which is handling gesture conflicts. So it's going to be hyper-focused on gesture nav now, as opposed to just any sort of nav mode. But the one I want to talk about is the left and right edge conflicts. Those are the most interesting ones for devs. There's a lot of conflict that folks have called out in our beta. So I want to make sure you get a good picture of this. So in gesture nav, as we kind of talked about, swiping from either edge will take the user back. In immersive mode, it's a little interesting too, and I'll cover that after this. But basically, any sort of UI that you have at the edge can become a problem. So in the case of this example here, I have photos with 4 crop handles. If a user wants to crop a picture, they would suddenly start going back instead of being able to crop a picture. So this is kind of the core idea. We wanted to make sure that some small swipeable elements had some way of taking over the back gesture space. So Q in the exclusion rect API. We're introducing this in Android Q, or Android 10. And basically, it allows you to opt out a small part of each edge for app use. So in this case, it might look like this, where you have the green rectangles as the areas that you may opt out of. Now, one really important note is this API should be used super sparingly. This is not meant to be like a free-for-all or meant to be used for like carousels. It's more for drag handles, seek bars, little small toggles where the user will want to swipe. There's a lot of reasoning behind this, but roughly, users love back in Android. I think users go back over twice as much as home, almost 300 times a day. And that's super important, or per user, of course. It's super important for us, and we want to maintain that consistency and keep back as a staple of Android. So what does this look like? It's a new method in the view class. It's set system gesture exclusion rects, kind of a mouthful. But roughly, it takes in a list of rectangles in the view's coordinate space that reflect or relay which areas the view should get touch events for, instead of being used for the system. And you can use this in on layout. And if you want more of a per frame update, you can also use this in on draw. Now, I want to talk about that restriction from earlier. I mentioned that we don't want this to be used for every single large-scale UI. So one of the things with Q is there is a restriction on this API. Basically, apps can only opt out of 200 dips on either edge. Or rather, on each edge, you can opt out of a total of 200 dips. So if apps do opt out of more, then only the bottom 200 would get respected. I did want to visually explain this really quick. So in the photos example, you can see the blue areas are where I, as a developer, decided to put in those, or use that exclusion rect API. What the system will do is it'll only count, it's updating, here we go. Here we go. It'll only count the bottom 200, which are highlighted in green. The top blue part, the rest of what I requested, will just get dropped off. Okay, now switching tracks a little bit, I want to talk about immersive mode and how back and this API kind of interact with it. So in gesture nav, here's kind of how immersive mode behaves. Any swipe from an edge will first trigger in the status bar and navigation bar. So what this looks like is if you swipe from the left, right, top, or bottom, you'll notice that the status bar and the gesture nav bar will come in. After these bars come in, any subsequent swipe will actually do the gesture itself. So swiping from the bottom will go home, swiping from the left or right will go back. Now, how this kind of works with that back API, basically, the restriction still kind of applies here. So, for example, if you're in the Photos app, you can use that 200 dip API, and that'll also stop the user from swiping in the navigation bar and status bar. Sticky immersive is a bit of a special case here, though. There are a couple of use cases that Chris will go into in his blogs, but basically they need that entire edge to be used for their app. So sticky immersive, it has unlimited exclusion on the left and right edge. So apps can utilize the entire length of it for things like games, mainly. Cool, and then I want to let Chris talk about the blog super quick.
Yeah, let's finish off. So we released a number of blog posts in a mini-series on GestureNav. It goes much more into detail about all the stuff we talked about today, so going from edge to edge, but also the gesture exclusion subject. And so we've got a flowchart which you can easily read and actually define what you actually want to do. So go check that out. And as a quick TLDW, we've got a little one here. So yeah, read this in your own time on live stream later. And yeah, thank you very much.
My name is Nick Rout. I'm from South Africa. From a young age, I was drawing, painting. My favorite subject was art. I took it all the way till the end of school, but because I had mathematical science ability as well, someone whispered in my ear and said, you should try into computer science. And when I discovered Android or mobile development, this creative side came back because we were exposed to the design of UIs. And my interest was sparked. I sort of went on to teach myself and make use of the documentation online, do a lot of code labs from Google, and at first I must say I experienced this sort of sense of like, I'm a bit scared about this, but then it grows into excitement. You've got a massive community of people to reach out to, something that you actually depend on for your career. And then, especially when I met Rebecca, who is also an Android engineer and GDE based here in Johannesburg, she unlocked this sense in me that it's not all about take, it's also about giving back. And just putting yourself out there and having the confidence to speak, to write, to publish blog posts. Got more involved in my local Google developer group, and then I was encouraged to speak there, which at first to me seemed like such a big thing. But I took the leap. I then moved on to speaking at conferences about UI-related topics around Africa, then eventually overseas as well. The Android community has been hugely influential to where I am today. The work is never done. It's a continuous learning process. Find your niche, and if there's something that you're particularly interested in or good at, go after that, hone your skills in that area and become a source of knowledge. Giving back to the community and being involved in it as you can is vitally important to this whole ecosystem of Android.
Hi there. My name is Jose Alferrica. I'm a developer relations engineer working on Android.
My name is Zied Boyer. I also work on the Android team.
And today we're going to talk about live data again. We were here last year with a talk titled fun with live data. Today, we're going to talk about its integration with coroutines and with Flow. So since API, we've struggled to understand Android's life cycles. We've all studied the diagrams and more diagrams, and then Fragments came along and generated more diagrams. So, we Android developers tried to isolate ourselves from having to deal with this problem. We created a layer architecture in which only the presentation layer would know about the life cycle. And then even inside the presentation layer, we found some patterns and some rules that work well, like, for example, having an object that would survive an activity or a fragment recreation. We use this idea in the ViewModel class in architecture components. So let's look at that animation a little bit more in detail. So a view is created, and a ViewModel is obtained. So it's created as well. It exposes one or multiple live data, and then the view subscribes to these live data via data binding or manual subscription. Then there's a configuration change, a rotation, for example. The view is destroyed, and a new instance of the view appears. It subscribes again to the live data, and the ViewModel doesn't know what just happened. The ViewModel doesn't even have a reference to the view, it just exposes data. So why are we talking about this? Whenever you do an operation, and an operation can be something like fetching data from the network, preparing some text, you have to choose the scope of this operation. This means when this operation is going to cancel. If you cancel too late, then you might be wasting the user resources. If you cancel it too soon, you might have to restart your operation. But in a real-world app, and this is the Android Dev Summit app, we have way more scopes than that. For example, we have a schedule screen with potentially multiple instances of the fragment schedule, the ViewModel that is scoped to the screen, the agenda, the info screen with fragments and ViewModel as well. Then we have a main activity and a ViewModel that is scoped to this activity. And then you can even have custom scopes. With the navigation component, for example, you can create a scope for a login flow or for a checkout flow. And then we even have the application scope, which is a special case we'll talk about later. So there's going to be a lot of operations happening at the same time, and we have to manage the cancellation somehow. We need a way to find something that helps us structure this concurrency.
What would that be? That's, of course, our new best friend, Kotlin coroutines. Now, we don't want to go through and make an introduction to Kotlin coroutines, but we want to talk about why we like it for this particular use case of Android development. Briefly, there are like three main nice things. First one is it's very easy to get off the main thread. Like, this is a problem we tried to solve with like 20 different technologies, albeit. With coroutines, you just launch it, and then you can change your dispatcher. It's very easy to write. And while writing that, you don't need to write boilerplate code. This is probably the best thing about Kotlin coroutines. You write it as if you're writing like blocking code, and then it's all compiler magic and becomes asynchronous. But these two are nice properties, but they're not the reasons why we like coroutines for this case. The main reason is the structured concurrency it provides. It's a little bit complicated, but basically you can consider structured concurrency as a garbage collector for your jobs. So when something doesn't need to run anymore, it is killed for you automatically. And this is why we like it. So if you like coroutines on Android, how do you launch them? Luckily, in the Jetpack components, we provide scopes for related Android components. So for example, if you're in a ViewModel and you want to run something in the scope of a ViewModel, there's a ViewModel scope. You can use it to launch your coroutines. Or if you're in an activity or a fragment, you can use the lifecycle scope, which gets canceled if the lifecycle is destroyed. Now, in this lifecycle case, there's one more thing. Sometimes you want to run certain operations when the lifecycle is started, like a fragment transaction. For those cases, you can use this launch when started, resumed, or created methods. What this does is it runs your suspend block only when the lifecycle is in the desired state or greater. And if let's say you said launch when started and the activity stopped, we suspend that computation until the activity resumes. Now, the third layer is your application layer, where things get a little bit more trickier. Like, assume you want to run something that's not tied to any screen. In those cases, you need to figure out whether you should be using Work Manager or not. And the question you ask is, does this thing has to complete? Like, if you're writing a Twitter client and you need to send it to your server, please use Work Manager, because if you lose that tweet, that will be a shame. But if you're trying to do something where you're going to clean the local database, it's fine. You can use the application scope. Like, if that doesn't complete, it's not the end of the world. You can do it next time the application starts. Now let's look at how we can use that view model scope with a live data. Here we have a common pattern where you have a private mutable live data that you provide as a public property to your UI. Inside here, we launch our view model scope. We do some suspending computation. And when the result comes, we update our private mutable live data. And notice that I'm just setting the value there. I'm not calling post value, because this runs on the main dispatcher by default. Since Lifecycles 2.2, there's a much nicer way to do that pattern, which is a new builder called Live Data. This Live Data builder gives you a coroutine block, which is like a scope for your live data. It starts executing when the live data is observed and canceled when live data is not used anymore, and inside there, you can emit. Another very common pattern is, like, imagine you have a UI where, like, user selects some item and then you display the contents of that. A very common way to do is that you keep that item ID in a mutable live data, run a switch map transformation on it. And again, for those cases, you can use this live data builder and just do a coroutine computation. This live data builder also receives a coroutine context, so you can tell it to maybe run on the I/O by default. And it doesn't matter, you can still call emit, so you don't need to think about which thread or which dispatcher I'm on. You can always call emit. There's one more function called emit source, which receives a live data. This basically says, whatever these other live data dispatches, send them as my value. So how do we cancel them?
All right. So how do you cancel a coroutine? Well, I'm not here to talk about how to actually cancel a coroutine that you just started. We've been talking about scoping our coroutines so that this is done automatically for us. There's some use cases for this, but normally you won't be canceling your own jobs. What I want to point out here is what happens if you are designing a suspend function, and that function, for example, has an infinite loop. How does Kotlin know when to stop that loop? Well, it turns out there's a little bit of magic here. All suspending functions in Kotlin X coroutines are cancelable, and delay is one of them. So when delay is called, it's going to check if the coroutine is canceled, and if it is, it's going to stop the execution. So what happens if you're not calling any cancelable functions in your suspend function? Well, you have to cooperate. We say that cancellation is cooperative. You have to check if the coroutine is active regularly with the isActive property. So before we see some patterns, there's an important distinction that we have to make, and that's between one-shot operations and operations that are going to return multiple values over time, and we're going to see this with an example from the Twitter app. So in order to load the data needed for this screen, you have to perform some one-shot operations. Downloading the profile picture, the Twitter handle, the tweet itself, because tweets are not editable in 2019. Mike? But there's another thing. There's an interesting thing at the bottom, number of retweets and number of likes. This UI is observing a data source, because if you keep this screen open, those numbers are going to change over time. So that's the difference. So how does a one-shot operation look like in the big picture? We use live data between view and view model for the reasons that I explained in the introduction. And then in the view model, we're going to make this bridge between the live data world and the coroutines world using the live data coroutine builder. Super easy in the repository, because we are in suspend functions. We can just call suspend functions in the data source. We get the result. We're done. when we have to deal with multiple values, things get complicated. And we can solve this with live data. We can use live data beyond the view model, and our talk last year was partly about this. But live data was never designed as a fully fledged reactive streams builder. So it's a little bit awkward to use. So luckily, there's a new API called Flow. Flow is part of Kotlin coroutines. And we're going to see some examples of some code examples, and we're going to look at view model, repository, and data source. So first, we're going to see some view model patterns. We're going to compare two view models side by side. One is going to subscribe to a live data or consume data from a live data, and the other one is going to consume from a flow. So the first pattern is about emitting multiple values. If we're not doing any transformations to the values, then we can just assign a live data that we're observing to the live data that we're exposing. That's very easy. In the case of flow, we need to convert from a flow to live data somehow. So we could use the live data coroutine builder. So we collect each item from the flow. That's how you consume a flow. And then we emit to the live data coroutine builder every item. Now, this is more or less readable, but if you have to do this 15 times in your view model, it's going to be a lot of boilerplate. So we created this handy as live data extension function that is going to convert any flow to live data, and we're going to use it in the rest of the examples. The next pattern is emitting one initial value and then emitting multiple ones. So we already saw this pattern. We use emit and emit source from the live data coroutine builder. In Flow, we could use the same pattern. We pass the flow converted to live data with as live data. But this is not very readable, and well, it's super awkward, and we're creating a live data twice. So it's much better if we embrace Flow's API, and we use this thing called onStart that is going to let us define what the initial value of that flow is. And then at the end, we just convert to live data. And this is where Flow really shines. Normally, you want to do a transformation on each item that you are observing or that you are receiving. If we do this with live data, then you might want to try map first, but this would be main thread, and it would be awkward to use a coroutine from here. So it's much better that we use switch map, and we return live data created with the builder, and because we are in a coroutine context, we can call this heavy transformation function, which would be a suspend function, and emit its result. With Flow, this is much, much better. We just call map on the flow. And because we are in a coroutine context, we can call the suspend function. And at the end, we just convert to live data.
All right, so how do we use the suspend functions and Flow library in our repositories? Now, repositories usually where you have a lot of custom code, like you're making APIs, collecting data, filtering, whatever business logic you have. In these cases, you may want to do a lot of transformations. And as Jose mentioned, like we never intended live data to do these things. Luckily, with Flow, you have all these operators on your streams that you can use. So just go ahead and use Flow or suspend functions in repositories. Similarly, for your data sources, suspend functions and Flow are great fit. But here, things get a little bit more trickier because this is usually the part of your code where you're talking to other libraries, remote sources, whatnot, so you don't control all of it. So let's look at all those cases, see how we can integrate them. The first case, the best case, is you have one-shot operation. So you have one-shot operation to get some value, like let's say from a network request. So if you're using retrofit, just mark the function as suspend, and you're done. Retrofit already supports suspend functions since version 2.6. Similarly, if you're using Room for your database, since version 2.1, it supports suspend functions. So you tell it to return a suspend function, done. You don't need to care about it anymore. But if you're dealing with a library that's not updated for the coroutines world, maybe it's a Java library and it has callbacks, sounds super old, callbacks, now you need to do some work. For those cases, we have this thing called suspend cancelover coroutine builder. This thing is basically the adapter between the coroutines world and the callback-based world. What you do is when you call this function, it gives you a continuation that you are responsible to call. So we make our API request. If the API gives us a value, we resume the continuation. Or if the API tells that an error happened, we resume the continuation with an exception. This is all you have to do. Once you do this, rest of the coroutine machinery works, and you can abstract this somewhere outside of your code. Notice that if you happen to call this continuation much later, like after it's canceled, it's just ignored. And you can also change this code a little bit better so that if the coroutine is canceled, you can eagerly cancel your API request. Now, the third case is where you have a lot of values, like you want to emit multiple values. And Flow Builder is a great thing. It's very similar to the Live Data Builder, except you build a flow, and you can emit values. So we have an example here that like infinitely every 2 seconds dispatches a new weather value. It's also super handy when you're writing tests, actually. Just like say, oh, this is this other flow. But if you're working with an old library again that doesn't support flow and is a callback, you can use this callback flow builder. It's very similar to the previous one we saw. So let's say we have an imaginary API here that receives an imaginary callback, and that callback has 3 functions. It's like next value, on error, and on completed. We registered that callback with our imaginary API, and every time we receive one of those callbacks, we just say, OK, offer that value. If a new value came, offer it to the flow. Or an error happened, basically close the flow with this error. Or if it closes nicely, same way, close the flow. Now, you need to be careful here, because this callback flow builder, once it returns, flow is closed. So you cannot dispatch values to it anymore. We don't want it to return. So for those cases, we have this function called await close, which basically suspends until the flow is not collected anymore. There might be any reason you close it here, or maybe the collector just stopped collecting. And in that case, we simply unregister from our API. Now, testing. So we would like to talk about testing, but we don't have that much time. No. Test. No, we have time. Testing is important, so we have a full-fledged talk on testing by Sean and Manu tomorrow at 5:15. Please go watch the thing to see how you can effectively use coroutines in your tests. Before we leave, there is one more thing. With the introduction of Flow and the lifecycle scopes we have shown, you can actually get the benefits of live data without using live data. So if you could be doing this, where you say lifecycle scope, launch when started, and start collecting on this flow. This will behave exactly the same way a live data behaves for your UI. Now, it's not 100% the same thing, because live data has this caching behavior, but it's close to there. So this is something you may want to consider. And for any questions, we'll be upstairs for the Q&A. Thank you.
All right.
Cash App is the fastest and easiest way to send money. You get a personalized debit card with great rewards, and you can buy and sell Bitcoin. So we launched the Play Store in 2013, and as of December, we had 15 million active users. In 2015, one of my coworkers wrote this document using Project Kotlin in Android, and it got us all really excited about it. Ever since Android Studio and the Android team have embraced Kotlin, things have gotten even better. Whenever we want to change a new feature, we always convert it to Kotlin first. One of the things I really like about Kotlin is Lambdas. It really makes programming with RxJava very easy and fluent, and it was something that allowed us to take 2 different technologies that we really liked and use them together. With Kotlin, we're able to eliminate many builders, and we're able to really cut down on the amount of code we write. In some cases, we save 25% of our code. I really like Kotlin's fantastic deprecation features. It allows us to evolve our API as our business problems change, and quickly update all the call sites. We're constantly improving our business model and solving more problems. And with that, we need to migrate new code to the latest model. Replace with it makes that very fast and easy. One of the features we're really excited about is Kotlin multi-platform. It's going to give our Android developers the ability to ship code on iOS, and our iOS developers the ability to ship code on Android. With sealed classes, we can create loading, error, and content screens all in a single sealed type. And this allows us to move faster, to make changes, and really understand our data model in a stronger, type-safe way. On Cache, we ship the app every 2 weeks. With Kotlin, we're able to get more code with higher quality in every release. I think it's time to dive in. I think Kotlin is ready. I think that when you use it, you'll see just how much it transforms how you think about your code.
Go beyond the basics of building Android apps in Kotlin with advanced Android app development. A new course brought to you by Google and Udacity. Learn how to send notifications along with best practices for keeping them relevant and useful. Create cool effects using customized views, along with clipping graphics and transforming text. Convert what the user traces on the screen into a colorful drawing in your own painting app. Learn 2 different ways for creating compelling and fun animations. Add maps to your apps and learn to style them. Learn to test your apps and zap those bugs. Enable users to log into your app with their existing accounts. So advance your Android skills and come learn with us.
Hi, everyone. Welcome to Work Manager Beyond the Basics. My name is Samir Kataria.
Hi, I'm Rahul Ravikumar.
And we're going to be talking a little bit about Work Manager, which is Jetpack's deferrable constraint-based background processing library. And we'll be covering a lot of intermediate and advanced topics, so we're kind of counting on you to know a little bit about Work Manager. So let's talk a little bit about sort of the release highlights of Work Manager over the last year or so. So we released Work Manager last year, 1.0 and 2.0. So 1.0 is a support library version in the old world. 2.0, which is what we're currently developing, is the Android X version. 2.1 brought you on-demand initialization. We'll be talking a little bit about initialization later today, because that's an important topic. 2.2, which is our latest stable version, is introducing support for GCM Network Manager, and it's optional, API 22 and below. So that adds a lot of reliability to your Work Manager. And then 2.3, which is what we're currently developing, and we hope will be stable later in the year, brings you progress and set foreground API. So that should be very important. We won't really be talking about that today. So let's dive into some topics. And we're going to be covering a broad swath of things, but they'll all be sort of focusing on things that make you understand how Work Manager works under the hood. And this is the first topic, which is how does Work Manager interact with the OS? So you all probably have a simple worker like this. And this is very simplified. It's a worker that uploads images. So this is the basic unit of work. And you'll probably create a work request using this. You might add some constraints. In this case, since it's uploading, it'll probably be network constraints of some sort. You'll build it, and you'll enqueue it. So this is the basic Work Manager workflow. And what happens at this point? This is very important to understand because it'll have repercussions throughout the rest of your code. So first is, how do we persist your request? And the first thing we do is we store it in the Work Manager database. This is our source of truth for everything. Nothing else that we talk about is actually controlling the source of truth. So if we want to know if your work is running, has finished, has failed, has retried 5 times, whatever it is, all of this is stored here. After that, if you're on a newer API, API 23 and up, we'll store it in Job Scheduler. Sorry, we'll send this request to Job Scheduler. For API 22 and below, we'll check. If you have Google Play Services on your device and you're using the Work GCM dependency, we'll send it to GCM Network Manager. Otherwise, we have a custom alarm manager and broadcast receiver implementation. So after all of this is done, how does your work request run? And we talked about Job Scheduler, GCM Network Manager, and Alarm Manager. So these are all things that are outside of your app. So it's either the OS or it's Play Services. Something else now knows about your work. And that thing can wake up your app, if needed, and ask Work Manager to run your work. So for example, if you have a network connectivity constraint on a newer device, Job Scheduler will wake up your app and tell it, hey, you have a network, you can do this work, and then Work Manager will run it. We also have this thing called Greedy Scheduler. Greedy Scheduler only exists within your app process, and it does the same stuff. It'll keep track of some of the constraints, and it'll opportunistically ask Work Manager to run the work, but since it's in your process, it's not going to wake up your app. It's just an optimized way to eagerly run your work. And this is very useful because it doesn't depend on the rest of the OS, so it's just opportunistically and quickly running your work. So let's take a brief detour, and this will tie right back into this concept right here. So somebody came to me, an internal team at Google, and came to me and asked, hey, we want to run Work Manager experimentally. We're introducing it in our app, and we'd like to make sure that we can experiment and do A/B experiments with it. So the first idea they came up with was, what if I stop calling Work Manager for an experimental population so I can do like this A/B test? What happens here? So let's go back to that first part of that flowchart. Your old work will actually still run because you've enqueued this work in the past. Then you say, OK, I'm stopping using Work Manager for this user. Well, all of this work is still remembered by the OS. And it'll start the app process, and it'll ask Work Manager to run the work. So that's not what they wanted. So the second idea was, what if I don't initialize Work Manager for that experimental population? OK, so your old work will still run if you use on-demand initialization because that'll initialize Work Manager on demand. And we'll talk about initialization a little bit more, but that's one thing. And with auto-initialization, it'll just throw an exception because it will say, hey, wait, you wanted to run this work. I tried initializing Work Manager, but it's not initialized. OK, well, that's an exception. So they came back with a third idea. What if I remove Work Manager for that experimental population? Well, now things are looking right. So your old work will get ignored because your components that are supposed to be in your app are no longer found by Job Scheduler, GCM Network Manager, and Alarm Manager. So they may print something out in Logcat saying, oh yeah, I couldn't find this thing, and it'll ignore the work. But there's a problem here, and it's subtle. It'll still use system resources. So I said, for example, that there's a connectivity constraint. So Job Scheduler is still tracking when do I have network. Oh, I have network, I better go tell this app to run. And this app, in this case our app, doesn't have Work Manager anymore. So you've used a bunch of system resources to do nothing. And that's not good citizenship either. So the answer here is you should cancel all your work requests to clean up after yourself. That's what I gave to that team. And the reason I'm bringing this up is because you should always realize that Work Manager is something that exists within your app, but there are repercussions outside your app. The rest of the OS also knows about it, and it's important to know that. So a common question people come to me and ask is, why is my work not running? And there's a wide variety of reasons for this, and I want to remind you about a few of them. One is unsatisfied constraints, and that's very simple, right? Like, that's the most obvious answer. If your constraints aren't met, your work won't run. If you're on a newer device, you can always dump this Job Scheduler because we do store our jobs in Job Scheduler, and it'll tell you what the constraints are that aren't met. Another answer might be you're in doze mode. Remember that Work Manager is for deferrable processing, so your jobs can be delayed in doze mode to preserve battery. Similarly, battery saver mode, which is on like Pixel devices when, by default, when your battery gets below 15%, background jobs don't run in this case. So same thing. It could be that your OS or your app is just doing too much work. So Job Scheduler only allows a certain number of active jobs at a time. So you might be exceeding that, and that's across all apps. Work Manager is also limited by the thread pool you give it at the beginning when you configure it. And by default, that's between 2 and 4 jobs. So if you're trying to do 10 things at once, some of them will be in the queue for later. And you could also have failed or incomplete prerequisites. So you should always check, are your prerequisites finished? Have they all succeeded? If they haven't succeeded, a failed parent job will fail all its descendant jobs. So that's very important. If you haven't realized that yet, if you haven't hit this yet, you should always make sure that happens. That's the expectation in Work Manager. And if you're using a unique work with the append policy, make sure that the parent job hasn't failed, because if it fails, everything you keep appending will keep failing. And we'll be giving APIs to address this soon, because we know a lot of people sort of struggle with this one. And then the final reason is your app could be force-stopped. And a force stop is something that you usually go from your settings and you say force stop this app. It wipes out all jobs and alarms. So Work Manager handles this fairly gracefully. The next time it's initialized, it'll just reschedule everything for you. But since this is considered a destructive action, we can't really control it when it's force stop. We can't wake up your app for you at that point. That's the intent. And some devices we know force stop your app very aggressively. If you're running into this, come talk to us. We have some ideas. And the corollary to the last point is, why is my work running too often? This is one thing that also people ask me. Let's take a look at an example. So here's an activity on create, and you're enqueuing a periodic work request. And this is something we run into fairly often. This is wrong. The reason this is wrong is because every time you enqueue that work request in the onCreate, it creates a new periodic work request, and you just keep having more and more periodic work happening. This is the right way to do it. So you enqueue a unique periodic work request. And a unique periodic work request, you can specify what happens if that work request of that name already exists before. So we're saying, keep the old work request in this case. So if we've enqueued this before, don't create it again. Just keep using the one we already have. And this is the right way to do it. And over to Rahul.
Yes, thank you, Samir. So Sumir touched upon how to experimentally use Work Manager, and he talked about initialization before. So let's look at initialization in more detail. There's two types of initialization, the first one being automatic initialization, and the second one is on-demand. So let's look at automatic first. Automatic initialization is useful when you just want Work Manager to be initialized automatically with the default configuration. That is, you don't want to customize anything, you just want the defaults. The way this works is we have a content provider called Work Manager Initializer, and that gets manifest merged into your app. And the way content providers work is content providers get initialized first, before application onCreate happens. So in work manager initializer's onCreate method, we will call work manager.initialize and specify the default configuration. And so when application onCreate happens, work manager is already initialized. And so when you call work manager.getInstance, at this point, it will always give you a non-null work manager instance. So that's good. However, if you notice this flowchart, we are actually gating your application onCreate. So we are adding the cost of initializing work manager to your application create, which is not great. So to fix that, we gave you on-demand initialization. On-demand initialization is useful when you want work manager to be initialized lazily. So you don't want it to be initialized the moment application onCreate happens, and you want to also possibly customize the default configuration. So let's look at that in more detail. So the first thing you need to do is you want to disable the default initializer, because if you don't, then we'll still use the content provider to initialize work manager, and that's bad. So now when you call work manager.getInstance and give it the context, we'll check if it's already been initialized. And if it has, then we'll give you back that instance. If it hasn't been already initialized, then we'll synchronously initialize work manager at that point in time and give you that instance. And going forward, that will be the instance that everybody gets. So that's how on-demand initialization works. So how do we discover the configuration, though? Because work manager needs the configuration. So the way this works is your application class, the subtype implements a configuration.provider. And that has a single method called getWorkManagerConfiguration. And that gives us the configuration we need to use to initialize work manager. So first thing we do is get the configuration from the application, and then we use that to initialize work manager. If your application class does not actually implement that interface, then we'll just use the default configuration, but still initialize work manager. So let's talk about some pros and cons. So pros are obvious for on-demand initialization. It can lead to a more performant app startup. That's because we don't actually block your application onCreate for initializing work manager. We'll initialize it lazily. It can also work around a lot of device-specific problems. And so we have noticed that some OEMs play fast and loose with content provider initialization protocols. So sometimes you do encounter cases where work manager has not been initialized correctly, or you have too many jobs. And this is normally because the content provider the initialization protocol is not correctly followed. So for that, you can use on-demand initialization. One of the cons is sometimes your application does get force stopped. And remember, when a force stop event happens, all your jobs and alarms get wiped out. And so usually this is not a problem because remember, as Sumir said, work manager has its source of truth, which is the internal database. So we know what workers exist, and we know how they need to be scheduled. So we'll just reschedule everything. However, that rescheduling only happens when work manager is initialized. So if you're delaying work manager initialization, the rescheduling is also getting delayed. This is usually not a problem because you can just lazily call work manager.getInstance after the application onCreate, and you have the APIs to do that. So switching gears, let's talk a little bit about testing, because unlike Yeat's talk, we actually have time to talk about testing. So when work manager was a 1.0 stable and a 2.0 stable, it had very limited support for testing. And we know unit tests are very important. So in 2.1, we revamped our testing story a lot. So I want to talk about that. So let's take a worker, for example. So here I have a test worker, which extends the coroutine worker, and has a suspending do work. All it does is delay for a second and return a result.success. Now, in an ideal world, if I was testing this worker, forget the fact that this is a worker. I would just create an instance of this class, and I would just call do work and assert that it returned a result.success. It would be really that simple. However, you know that you can't actually create instances of workers really easily because you have to use worker factory, and you have to use, you have to provide work manager the configuration, and you have to go through the full worker initialization. So we made that easy by giving you a new class called test listenable worker builder. So in a test, if I want to test the test worker that I defined, the first thing I do is use test listenable worker builder, give it the test worker, and supply the context that I want. And then I set some input data, and I set some other additional arguments as needed. And when I call .build, it really gives you a real instance of listenable worker that you can use for testing. So at this point, I can just call start work, which is a method on listenable worker, and I call the suspending await. Await is suspending. It'll suspend until you get a result from listenable worker, and then once you get that, you can always assert on the result. Because await is suspending, I just wrapped my test in a run blocking block. So now my test became so much simpler because I don't have to initialize work manager. I don't have to initialize all of the infra needed to initialize a worker. So let's look at what testing a synchronous worker looks like. So just like the previous example, unlike instead of extending coroutine worker, I'm extending a worker, and I have the same do work which returns success. Now the key difference in coroutine worker and a test worker here that extends the synchronous worker is that this runs in a pre-configured executor, because this is always executed on a background thread. And so for that, when I'm testing this test worker, the first thing I need to do is to define the executor that it needs to run in. So here I'm defining a single-threaded executor. And then instead of using test listenable worker builder, I'm using test worker builder. And I give it the executor. And the rest of the code remains the same. I set some input data. I set some additional arguments. And when I call .build, I just get an instance of listenable worker like I did before. And I call start work and await. And the whole thing is surrounded in a run blocking block because await is suspending. So my tests became, again, very elegant and very easy to write. Sometimes, however, you want to test delays and constraints, and you want to test how your worker is reacting to changes in constraints. And in that case, you want to initialize Work Manager in test mode. So that is still the one use case where you want to initialize Work Manager for testing. So let's look at an example to do that. So in my test, I have a setup. So I define the configuration that I want to initialize Work Manager in test mode with, and I call Work Manager test init helper, and I call initialize Work Manager, giving it the context and the configuration. At this point, Work Manager is initialized for testing. So I can now use workmanager.getInstance like I would in a normal application. So this is what my test would look like. So I would first create the constraints that I want to test my worker with. Then I would create a real instance of one-time work request. So I would use the one-time work request builder, and then I supply the constraints, and I would call .build. At this point, I have a real one-time work request, and I call workmanager.enqueue. Because this is a special instance of Work Manager in test mode, this worker is actually not going to run until the constraints are met. And by default, the test Work Manager instance will treat all constraints as unmet. So we have to mark those constraints as met, and for that, you need an instance of test driver, which Work Manager test init helper will give you. At that point, you can use the test driver, and you can mark all constraints for the worker that you just defined as met. And now you can just use all the rest of the APIs like you would normally. So you can just call get workinfo by ID, give it the request.id, and then you could get the work info, and then assert that the state of the work request was success. And that's it.
And yeah, just to finish up, these are some resources for you. So if you need to know any documentation, we have a lot of it at developer.android.com/workmanager. And these are your artifacts. So the work runtime, RxJava 2, testing, and GCM artifacts are all there. And thank you.
Thank you.
Hello, live from the floor of the 2019 Android Dev Summit, and welcome back to today's next session of the #AskAndroid livestream. I'm Dan Galpin, and this is my co-host, Lila Fujiwara.
Hi everyone, it's great to be here at ADS 19, and we are straight in the Android sandbox.
There's lots of sand everywhere, you can tell.
Yes. So next up, we got a topic that I am pretty biased about, and I added to the list. So it is Android community. We're going to be learning about how to start figuring out your Android journey and how to join the Android community. Remember, if you want your questions answered live, please tweet using the AskAndroid hashtag. With me, we've got Murat and Ben.
Now, both Murat and Ben are former GDEs that have found a home here at Google. Now, Murat formerly led the Istanbul and San Francisco Android Google developer groups, while Ben led the Android Berlin GDJ.
Cool. And I think we're going to just get started. So we've been saying GDE a lot. What exactly is a GDE? How did you become a GDE? Should anybody else decide to be GDEs? Like, what's up with that?
If you are starting, let me put my hat on.
Okay.
Oh, there we go. All right, excellent.
Now I'm ready.
Now you're in costume.
You're
Wonderful.
thinking cap.
Wardrobe is done.
That's great. So GDE is one of the TLAs we have at Google. It's a three-letter acronym,
Yes.
and it stands for Google Developer Expert. So Google Developer Experts are people within the Android community that have stood out over time with their exemplary contributions towards that community by providing the community with resources that is far above and beyond what we provide as documentation and the videos that we create out there with real-world experience with real apps.
And really give back to the community where they
And help to foster and create that community. I think is really the key thing.
And I think as Dan mentioned, you were both GDs before joining Google. How did you get involved with the program?
So this goes way back for me. If it's okay, I'm just going to start on this. So in Berlin, I was studying there, and the community was really non-existent. And the first couple of Android phones came out, and I got one of those phones. I stumbled across a community meetup. I went to that meetup, and over time, that meetup continued to grow. And I started speaking at these meetups. Back then, there wasn't a GDG. It was, we called it Stammtisch, which is basically round table. We just sat there and we talked about things related to Android development. And at some point, I started presenting my own things that I learned and continued doing that over time. And I started sharing code that I wrote. And I got invited to conferences over time. So people asked, do you want to come to this conference? And at one point, I was asked to apply to become a Google Developer Expert, which I then did. There were a couple of people that I met with that. And then I got the tag of being a Google Developer Expert.
Well, I remember meeting you early on when you were working on Blinkandroid, which is this very, very cool app that allows you to synchronize a whole bunch of phones' displays together for these really, really cool. And it was just awesome the work you were doing. So I think it was clear how you ended up getting noticed. You know, just by that itself. And
yeah, I also have a similar story. I was actually in Istanbul, again, gathering meetings, and things started growing, and I started traveling, doing talks at different GDGs, and then one day I applied to become a GD, and
the rest is history.
Yeah, exactly.
Yeah, so both these guys have basically done the entire journey from starting to get involved in the community to sort of leading it to some extent. I mean, you're leading the GDEs right now, which is pretty cool. Okay, so listener question. Maybe this guy? This one?
Yeah, sure. So one of them is Mohammed 044695969 asks, should I start my Android development journey with Kotlin and totally ignore Java?
Well, definitely Kotlin, we are going Kotlin first, so Kotlin is a good place to start. We have updated trainings, code labs. If Java is okay and you can do what you want to do with Java, it's perfectly fine. We support Java, you can write Java, and if that's enough for you, that's fine. But as things progress, Kotlin is a good place to look at and catch up new features.
Any thoughts on this one? Or?
So I have written Android applications in Java programming language for a long time, and when we announced support of Kotlin on Android, I started rewriting one of the sample apps that I wrote in Kotlin, and the amount of fun that you have with that, yes, that pun is not intended, but it provides itself.
Functions are called fun in Kotlin.
And the productivity that I have with that, comparing it to Java programming language, I'm just so much more happy with that. So if you have the choice to go with either one of the languages, I personally would go Kotlin straight away.
Yeah, and this isn't like an official Google recommendation, but I think honestly I feel the same way. Like So
Plus, you don't need semicolons.
Yeah, so the phrase Kotlin first was mentioned, and I think that what that means, at least from our perspective, is a lot of the samples and documentation that we're doing is, we're writing it in Kotlin first. So it's not to say it's not in Java, but if you want the freshest material,
And we also keep Kotlin in mind whenever we're designing our things.
Yeah.
All right, cool. So next question. Anil KR, a lot of numbers here, 0306 asks, why is there no tutorial on Dagger 2 on the Android developers page? This was asked a week ago or something like that.
Yeah. Well, the good news is a couple of days ago we made a push on our developer site. So now you can see dependency injection tutorial that a colleague of ours wrote. It's a very good and long tutorial that goes very in depth. We also provide all this. So you go on developersonandroid.com and search for dependency injection, and you will find all the answers to this question.
He's technically right. It is not actually on the Android developer site. It's technically on our CodeLab site. So, but you definitely can find it.
Yeah.
So it's CodeLabs.
Yeah.
There's also documentation coming out about dependency injection, and I think it also does mention Dagger 2. We also have an advanced Android course that includes modules about testing that get into dependency injection. It's not Dagger 2 material, but it leads great into the CodeLab about Dagger 2. So plenty of Dagger 2 testing material if you're getting started with Android and you want to start with DI and testing.
All right, so Brett Whitney 11 asks, what is the best way to start learning how to write programs on Kotlin and programming in general?
Since you've been doing a lot of work on that.
Yeah, we have lots of trainings, and we recently launched a new one. We also have lots of code labs, documentation. Take a look, and we also have the Kotlin Bootcamp training. So
that sounds good. Another thing that I would like to add to that is what helped me grow a lot is a lot of the communities that are out there, they run study jams and things like that. So that means that people in the community come together and do these courses and these code labs together as a group and go above and beyond and advance on their own in their own time and doing those things and learn together and share their experience afterwards. So it's a really good point to also come together as a community to grow on this.
Yeah, there are GDGs everywhere, so go take a look. There's probably a GDG nearby, attend one.
Yeah, and I think that so sort of bouncing off of that, I don't know if you mentioned the Kotlin Everywhere campaign that is currently going on. That is specifically for GDG groups, that stands for Google Developer Group, where you get together and you're specifically learning about Kotlin topics.
Yeah, it's another TLA.
Yeah, it's another TLA. There's GDG, GDEs. If you have GD, there's probably another letter after it that means something.
And GDGs are amazing because you can find every level of people, and there will be someone who can help you.
So speaking, do you want to ask this one?
Yeah, totally. So we just got a question from the YouTube live stream from Kwaku, which is, how do I join a GDG community in Ghana?
We actually have one in Accra, right?
Awesome. Yeah.
So if you live in Accra,
so I actually was watching Dan as he was looking up how to answer this question. So how do our viewers at home answer this question?
Firstly, look it up on the GDG site. So you go on Google and you search for Google Developer Groups, and there's a site that leads you, that shows you a map with all the local communities that are there. And usually they have meetups every so and so often, and you can join one of those meetups, or you can also find them on Twitter, for example, and ask them when the next meetup is, if it's not scheduled already. And if there is no community around you, the best place to start is literally just put yourself out there and sit together with a couple of people, talk about it, and do that more and more frequently.
Yeah. Now, in the particular case of Accra, there actually is a meetup page where you join the group.
Do they have a meetup coming up?
They do. I don't know. That's good. That's a different question.
Maybe in a second we'll be able to answer that question.
There was an event just a couple weeks ago, so it looks like it's active.
It's active. So yeah, I guess one of the questions I was going to ask is, you guys, you've definitely been involved in, you've both been involved in GDG groups.
Yes.
So maybe a little above and beyond, but did you start your GDG groups or did you join on?
I did not start it, but I made it after a while. I converted it to be a GDG.
Okay.
So it was a community before. There were a couple of people that sat there before and started doing it. And I took it over, and we then converted to being a GDG.
So yeah, I mean, if you have a group of community members who you're like, hey, we're already kind of doing GDG type stuff, how do you then turn it into a GDG group?
So you probably have the best answer on this, since you did this from the get-go.
Yeah, I mean, if you're starting, and actually if you don't have a GDG around, you can easily start one, and it's not actually really that complicated. How I started one was, I was actually coming here in Bay Area to attend Google I/O, and I attended a GDG event a week before Google I/O, and at the time it was called GTAG actually, Google Technology User Group.
Which is an FLA, four-letter acronym.
Yes.
And then a week after, I saw the same guys in Google I/O, and they all remembered me. I was like, that was really touching. They remember me, and they even remember what I was talking about.
And you didn't even have a hat back then,
Yeah.
right? Yeah.
Yeah, I wasn't that recognizable, I guess. Then I went back, and I really wanted to have something like that, but there was no real community or any user group events. I gathered few people. We started meeting at coffee shops, then more people started showing up. My company sponsored to have a small room, which was really not much. Again, we didn't really need much resources, but then we started meeting there, and things grew large enough to hold DevFests over thousands of people. And again, it basically happened on its own. I didn't do something a lot on my own. People started showing up, people stepped in, organizing stuff. So don't be shy, go ahead, and people will come next to you.
So from nothing, I was going to say, how big is the DevFest this year and projected to be in Istanbul?
This year, I guess they're expecting over 1,500 people.
Wow, so that's amazing.
Which is crazy. I mean, 1,500 people. Even the registration is like.
Yeah, that's
crazy.
I guess besides being put on the GDG website as an official GDG group, what do you get from becoming a sort of official GDG group?
What I always suggest was go and do an event. You don't need to be called an official GDG. If you want to do it, start your own, and then contact Google, or maybe Google people will find you, because we have regional leads everywhere. And the main thing is do something sustainable. Don't try to organize an event for 100 people, then run out of resources and stop doing it. But start slow, small, and
coffee shops are great. People love coffee.
Yeah.
So
and the thing about community is it's people that do things that matter to them. So every community can be different, where an Istanbul community comes together with a DevFest with over 1,500 people, which is amazing. Your community might be small, but this number of people usually is driven by the people that are in the area that you are in. So if you have 2 or 3 people that come together regularly, and I think that is the most important bit. That's what I saw in Berlin. We come together and still do every last Wednesday of the month. And when this conference here is done next week, I'll be in Berlin as well to speak at that at the event there, because it's awesome to do that as well. It's still every last Wednesday of that month, and I think having one specific set time makes it easier for community members to show up and do their things. And over time, people will then, like Murat said, show up and create their own content, provide it there, because they feel like they want to give back to that community.
Cool.
So at the keynote today, there was some talk about the Kotlin GDE program, I think. Can you shed some light into that?
Sure. So we did have GDEs for Kotlin for a while now, but that was tightly coupled to being an Android GDE in the first place. But our investment in Kotlin is growing, and so we decided to decouple that from Android as a category. So people that are not Android GDEs can now apply to become a Kotlin GDE. So for example, that might be interesting for people that work on the web or in cloud and don't do anything with Android in the first place.
Yeah, I mean, there's no reason why Kotlin is only useful on Android.
That's literally true.
So.
And we've seen people do that, share a lot of great content on Twitter, for example, that are very invested in Kotlin as a language and in the things that you can do with the language, but not necessarily as Android. And we wanted to make sure that we also give those people the possibility to get the recognition from us in that case.
Great. Okay, we have a question live coming in right now. Okay, so, and it's something that I did actually want to talk about. So Ollie asks, are there any new courses in Udacity for Android? Murat, maybe you like to take this one?
Last I/O, we released a fundamental Android course, and just today with this event, we released the advanced version. So we have a new Udacity course which talks more about the advanced topics we wanted to cover.
What kind of topics?
Oh, there's a bunch of, it starts with notifications, maps, testing, what else?
Animation.
Animations, yeah.
Trying to think if we're
And
missing
login,
anything.
I
You
think
say
something-
login?
Yeah, login is also.
So like doing conditional login.
Yeah.
So that's.
There's Firebase Cloud Messaging.
Yeah.
And if you're not familiar with Udacity, it's an online learning platform with videos and interactive quizzes and things. So you should be able to see that live soon.
And we also have
It's
code-
completely free, by the way.
Yeah, and we also have Code Labs up for most of those topics as well. So you can either learn through video, or if you'd rather learn through kind of traditional web learning, you can also do that as well.
Or you can come together within your community and do those courses together.
Yeah, and it's actually a really great thing, because you both of you have done that, right? Have done
Yeah,
Code
that's
Labs.
actually how StudyJam started. We basically take some content, and it was really amazing because although Google provides some content, some GDGs decided to use their own content. So they either pick other Code Labs or write their own apps and work on it.
So they're like full boot camp-esque, almost training courses.
And I think that's one of the things when you're doing kind of learning on your own, it's really hard to keep yourself motivated. But you have a whole community around you, that all of a sudden you get more excited about doing and learning, and suddenly you're working at Google. So these things happen.
Okay, so Moe Din asks, is the course in Kotlin? Yes, Kotlin first, it is all in Kotlin.
Yeah, we actually have an advanced Android app that was written written in the Java programming language, and so this is a full update and a really very, very substantial update to the app. It's also taking advantage of all of our latest patterns.
All right, awesome. Okay, so I am going to go to, actually, Dan, do you want to ask this next one or pick the next one?
Sure. Yeah. Oh yeah. So it's an interesting question. This comes from. Big Yan 4424. What are the most common anti-patterns in Android application development?
Not following our guidelines.
Not following what Ben says.
Well, it's not just me. It's a lot of people that create content. We spend a lot of our time to make sure that we do stuff in a way that it's beneficial to you as a community, and it's beneficial that we try and fall into pitfalls so you don't have to. And we created, for example, the Android blueprints, which is a repository with a set of samples that provides you with architectural guidance, for example. We do have the Udacity courses. We do have a lot of these things. Another thing is, as an anti-pattern, is getting stuck in one way just because you have done it like this. You will always do it like that. So I know that we put out a lot of content in very quick succession sometimes, but that doesn't mean that you have to follow everything on that sense. But don't get stuck with one API because you have done it like that. Make sure that you expand your horizons.
Yeah, and I think if you look at blueprints, what's great about it is that it's not just a single pattern. It actually shows a whole bunch of patterns. Well, I guess that's it. We were out of time. So that's going to be the last word. Thank you both to Murat and to Ben for joining us.
And just as a sort of repeat, you can look up GDG groups on the GDG website. GDE program, I also believe, has a website out there. We mentioned Code Labs, which are online training tutorials, Udacity courses, the new Advanced Android launched. Anything training-wise I'm missing?
That sounds pretty good.
All right, yeah, so we hope that you take this as inspiration to get involved in your local community. We're going to take a short break right now from Ask Android, but we will be back at 5:10 PDT to talk to Chris Baines and Fred Chung about Android 10. As always, we are actually taking your questions live, so just use the Ask Android hashtag for a chance to see them answered right here. So next up, you're going to learn about the Android X WebKit library.
Thanks for having us.
Yeah, thank you.
Thanks for watching the ADS livestream. Ask Android will be back soon. In the meantime, post your questions to the live chat with the hashtag AskAndroid for a chance to see them answered live. And if you like what you're seeing, don't forget to subscribe to the Android Developers YouTube channel. See you from the conference floor.
Hello, my name is Lais. I'm a software engineer in the WebView team in London, and I'm here to talk about our AndroidX library, AndroidX WebKit. So, what is it? AndroidX WebKit is a library in Jetpack. Jetpack is a suite of libraries, tools, and guidance to help developers write high-quality apps easier. AndroidX libraries are independent from the platform APIs. This means that they are updated more frequently. They also offer backwards compatibility. In our case, APIs work back all the way to L+ devices. That seems great, but why should you care? WebView has dozens of APIs introduced after Lollipop. By using our AndroidX library, you can use all these APIs and target older devices as well. Let's say you want to use an API from SDK28, which is Android Pie. If using the Framework API, you only target roughly 10% of devices. If using the AndroidX WebKit API, you target almost 90% of devices. You can check out the full documentation on how to use AndroidX or how to migrate an existing project to AndroidX in Jetpack's AndroidX overview, linked here. For WebKit specifically, you want to add this line in your app's build.gradle file. Our current stable release is 1.0.0 and our current release candidate is 1.1.0 RC01. No matter what kind of method you're swapping, first replace the version check for a feature check. To swap static methods, simply replace WebView with WebView compat and you're done. To swap out non-static methods, replace your WebView object with WebView compat, then pass your WebView object as the first parameter. That's it. Let's talk about some of our most recent APIs. Dark mode. We are introducing new APIs to control dark mode in your WebViews. There are 3 modes. Off, which means your content will never be dark. On, which means your content will always be dark, and auto, which means it's going to follow system settings. This allows app developers to choose if the content should be light or dark. This snippet shows you how to query current force dark settings or change it. Remember to guard these calls with a feature check. It's as simple as calling getForceDark, passing in the WebView settings, or calling setForceDark, passing the WebView settings and the setting you want. Improving on the Framework APIs, we are adding new methods for developers to choose how the content will be darkened. There are 3 strategies to choose from. User agent only. Content will be darkened by a user agent and the page's dark theme will be ignored if it exists. Web theme only. Content will be darkened by the dark theme provided by the page. If the page doesn't have one, content will be rendered with a default theme. Prefer web theme over user agent. Content will be darkened by the dark theme provided by the page. Or, if the page doesn't have one, content will be darkened by a user agent. This snippet shows you how to get or set the force dark strategy with the 3 options we discussed before. Here are some examples of what a WebView looks like with dark mode off or on. Proxy controller APIs allow you to override Android proxy settings for all the WebViews in your app. You can set multiple proxy and bypass rules and also specify whether these apply to HTTP, HTTPS, or both. This snippet shows you how to use proxy controller. First, get an instance to the proxy controller. Then, create a proxy config object. You can add as many proxy rules or bypass rules as you need. Note that the order of the rules matter. When loading an URL, the first proxy rule that matches that URL will be used. If any URLs match a bypass rule, then it will be loaded directly instead. In case you want to clear these settings, just call clear proxy override. It's important to note that both these methods are asynchronous, so you might want to pass in a listener to know exactly when the settings were applied. Asset Loader is a helper class to load local assets, resources, or files. This doesn't have any Chromium dependency, which means, unlike other APIs discussed here, you don't have to guard these calls with a feature check. Asset Loader allows you to securely integrate local content in your app with web content. Always use a domain you have full control over or the default domain reserved for this. This snippet shows how to load an asset. First, create an asset loader. Then, override should-intercept request in your WebView client, and call into asset loaders should-intercept request. Then, load an asset concatenating the domain, in this example the default one, and its path. What else is coming into 1.1.0? Tracing controller, that helps collect tracing information for debugging, and render process, that enables you to control WebView's render process starting in Android O. Thank you for listening. Stay tuned for more stuff coming into Android X WebKit. Check out our documentation on Android developers, and if you have any questions, reach out to android-webview-dev@chromium.org.
雷亚成立于2011年，今年第7年，而刚好我们也推出了7款游戏。那像玩家比较熟知的 Citus 系列、Demo、Voice 等等，所有的游戏都在100多个国家和区域拿到第1名。那其他类型的游戏包含了像休闲类的 Mandora、动作 RPG 类的 Implosion， 几乎所有游戏我们都在商店的总榜上面拿到了第1名过。我觉得创作游戏本身它也是像在玩一个游戏，它具有在感性层面上非常艺术性跟主观的成分在。那在理性上，你又必须要对商业性深刻的分析，然后在作品推出之后可以养活自己之外，然后做出一个可以让自己的创作欲得到满足的作品。一款游戏的开发，如果有良好的工具的话，它其实是可以大大减少在沟通上的成本。以 Citus 2在刚上架的时候，我们的 crash rate 是8%。那因为有一个很便利的 Android Vitals 的 dashboard 后台，那我们可以监控到在哪一种版本的，或者说哪一些机型上面的问题，所以在及时调整之后，我们最后降到了0.12%，那它取得了一个非常好的稳定性的成绩。那 Google Play Console 提供了一个很棒的分阶段发布的功能，像是 Internal Test， 它可以让我们内部的 QA 人员在每天都可以玩到最新的版本。那 Closed Test 跟 Open Test 可以让我们对全球所有的玩家限定我们想要让什么样的人可以玩到。我们在 Play Console 就可以直接看到所有不同的语系的玩家给我们的回馈，而且会是直接翻译成我们开发者使用的语言。那更进一步的来说，它去归纳了不同的 feedback， 可能有针对宕机的负评，它就会集中在一起。那或者说针对说美术上的表现有问题，可以大大增进我们开发的效率。Google Play Console 提供了一个 A/B Test 的功能，透过不同的商店图素设计或是 icon 的设计，那我们就可以收集到大家对什么样子的图素会有更好的转换率。那最终的成果，我们游戏页面到下载转换率提升了10%，那也比所有的同类型游戏要高出了4.8%。那我们认为这会是一个对开发商非常好用的一个功能。其实我们不把雷亚只单纯当成一个游戏开发商，而是把它当成是一个内容提供者。其实平台会随着时代以及科技而改变，但真正会让玩家留在内心里的，其实是在创作过程之中以及游玩过程之中所得到的感触。所以我们也会期望说，真正去创作出让玩家可以留在心底的感动以及 IP， 这才会是雷亚持续以及未来会要做的事情。
So welcome everyone. My name is Nicolas.
Hi, I'm Oscar. I'm a software engineer in Design Tools.
Hi, I'm Paris. I'm an interaction designer for Design Tools.
Hi, I'm John. I'm in Design Tools as well.
So today we are going to talk about design tools in Android Studio and a large section devoted to Motion Editor. And we have a lot of content to go through. So you may remember we introduced the layout editor in Android Studio 2.2. Since then, we made a few changes. We released Constraint Layout, a library to help you create your UI in a simpler, more efficient way. We improved constantly, release after release, the layout editor. We released Motion Layout as well in Constraint Layout 2 to help you create not only UI, but animation and motion. And we released in 3.3 the navigation editor in collaboration with the navigation library to graphically create your navigation graph, the resource manager to let you import and manipulate your resources visually in 3.4. And a lot of work has been done in Marble in terms of quality, memory improvements, speed, performance, etc., etc. And of course, the bulk of today is to talk about what we've been doing for 3.6 and for 4.0. So just a couple of things to place where we are standing in terms of what we are trying to achieve here. So the idea is, of course, to be user-centric, to do something that serves you, the developer. And in order to do that, we try to listen to you. We run user surveys. We listen to social medias, bug fixes. Please file bugs if you find them. And we can only deliver good tools if you communicate back to us. The other important characteristic is we are trying to make those tools easy to use, right? It should be that any developers, whatever their knowledge, could use those tools very easily, very quickly, be able to create stuff quickly, right? And on the flip side, we're also trying to do tools that are scalable. And what we mean by that is essentially that when you get more proficient, when you are trying to get stuff more complicated, the tool should not fall apart. The tool ideally would grow as well as your knowledge. And the last characteristic we are trying to have in those tools is to be transparent. Because at the end of the day, they are going to be used to generate something. And that something should be very similar to what you would have done by hand, just with the help of the tools. And that means, in the case of the layout editor, for instance, that you can go and edit the XML by hand, and the layout editor can still operate on it afterward and back and forth. The other important characteristic is that now that we have all those different tools, they actually play well together, and that creates a more coherent, powerful environment for you as developers. So keep that in mind. You can really leverage all of the different tools to help you in your process. And to talk a little bit about the process and how we improve things, Paris.
Thanks, Nicholas. So as Nicholas mentioned, Android Studio 3.4 focuses on Project Marble. So you probably know performance, stability, quality. But one of the things that we also wanted to address was a lot of the usability issues that we found during our studies. So today I just want to walk you through a little bit of that process. So here's actually an example task that we asked during our user study. So people will look at this spec on the right, and they just try to create this layout solely using a layout editor. And throughout this entire process, we were trying to note down different observations, we asked questions. We just want to know what you liked, what you didn't like, what was frustrating. Probably most importantly, are there places in this flow that actually broke down and you cannot accomplish the task? So here's some examples that we found during 3.5. So the first one was you told us that you were really frustrated by visual clutter. So before, when you tried to create constraints on the design surface, we used these like green flashing dots to tell you where you can constrain to. Now, this is a useful information, but it's a little bit messy. So for 3.5, we actually decided that we're going to provide you only the relevant information that you need. So instead, we use a more subtle change between unfilled and filled dots to represent the same information, and use the blue overlay to actually show you exactly the one that you're interested in. Another example here is you told us that you dislike lack of helpful context. So we actually have this cool feature before where if you drag to overlapping components, it gives you a nice context menu that has a list of options that you can constrain to. However, it doesn't actually show you exactly what edge it's actually connecting to. So for 3.5, we just created different ghost anchors, so you can see that as you work through that different options, it actually tells you exactly where it will be connected to. And the last example I just want to show, which is probably the most important one, is that you told us that you liked when a tooling actually mapped to the XML. So a component tree is a great example here, where people told us, hey, that's actually my layout file, and I can really see that hierarchy, and I can navigate in and out of my nested layouts. So for 3.5, we created a very similar feature called a constraint section on the attributes panel. What that does is for any design components that you select on the design surface, we show you that list of constraints you have, and that maps one-to-one again to XML. So all these kind of design principles and just things that we heard from users, we carry them forward to different iterations of our tools, as well as new features that we developed. So here's Oscar to tell you a little bit about things we have with 3.6.
Thank you, Paris. So let me walk you through then some of the new exciting things that we're bringing to 3.6. So let's start with the layout editor. So when you're editing the XML file, well, you're probably very familiar with this workspace. We found through our user studies and, of course, user feedback that it could be a little bit frustrating when you feel forced to change into the design mode and back to the text mode to make some changes that are easier to do with the layout editor, for example, especially for things like constraints, which can be a little bit hard to do with the XML editor. So in 3.6, when you open your layout file, you have something like this, and you're going to see these 3 buttons instead. And as you can imagine, the first one and the third one are where you're already familiar, the text and design mode. So these are just exclusive text and design mode. And what we have in the middle is something we're calling the split view. And this is just much more than just the text editor with a preview on the side. Let me show you what you can actually do with this. So for example, when you change into the split view mode, you can actually see how you get the full layout editor and the XML editor, and you can see how they both interact together. So you can see things getting highlighted, and it can be very useful for making changes, again, like would otherwise be kind of difficult to do in the XML editor. And the cool thing about this feature is that it actually extends to other tools on our system, for example, the navigation editor. So this is something we didn't really have before. You either have to use the text mode or the navigation editor. So this is how it looks like with the split view. As you can see, again, it interacts with one another, so you can scroll to your XML file, and the navigation editor gets updated. It highlights your components, and you can also even go to your nested graphs, so you can see how it really works really nicely with the XML editor. Now let's move actually into the navigation editor. Naturally, we've been doing several bug fixes and, of course, improvements that have come from Marble, especially performance and memory usage. But one of the bigger things, or I would say one of the more obvious things, is that we updated it to use the attributes panel. And this is something you're already familiar with. You actually see it in the layout editor, and you're also going to see it on the motion editor, but that's for later. As you can see, it has some array of information about the navigation editor. And in case you didn't know, the reason why having this attributes panel is important is because actually it has many features that maybe you weren't aware of. So for example, things like autocomplete, or surfacing, or surfacing lint errors and warnings, as well as go-to declaration, which are very useful and common things to do when, for example, working with attributes. It also, you can actually now invoke the resource manager from it, and I'm actually just going to talk about that. So for the resource manager, when we released it in 3.4, it was more of a tool to visualize and manage your visual resources, things like drawables, color, layouts, and we included some really useful features like easily importing images in different configuration into your project. So for 3.6, we decided to take it to the next logical step, which is supporting more resources. So when you open the resource manager, you're going to see like these 3 little dots, and you're going to get a list of more resources. So you can manage more resources, things like strings, fonts, navigation, styles, menu, and of course, many more. And also, you can expect to have previews for some of them. For example, menus, which is very similar to layout. You can also get previews for fonts. and even font families, so you can see how all your fonts look into your font family without having to actually go into the font file or trying to hunt for it. And of course, for things like strings, plurals, dimension, and you can get a really nice preview of what there's actually in the resource. The resource manager will also now aggregate the tools that we have in Android Studio for each of these resources, specifically for creating these resources, for example, durables, or things like colors, and even fonts, which maybe you didn't even know that we have a tool that makes it really easy to import downloadable fonts or actually download the font into your project. One of the things that we also added was a couple of vector view options, so you can see resources from the Android framework as well as theme attributes, so you can really see how really the resource manager becomes really useful to know to easily locate these resources as well as see what the resources are and where they're coming from. And again, going back to the idea is that these tools can be integrated into your development workflow, so you can do things like copy and paste or drag and drop, and you can see how the drawable gets updated in the preview. And as I mentioned before, you can also now get the resource manager from the attributes panel. So you get this really nice view when you can see some extra information about your resources that maybe can be too abstract when just working with autocomplete. So you can see what library is coming from, what type of resource it is, how does it look like, as well as some extra information for your different configurations, like having one adaptive icon and a PNG for all the other configurations. Now, before moving into what we have for 4.0, let me just quickly mention this thing. So, material icons is a really nice collection of very useful vector drawable icons for basically any app. And we updated these icons in Android Studio 4.0. And as you know, this is a list of just a little bit over 1,000 different icons in 5 different styles. And in case you didn't know, well, one quickly way to access to this tool is one is the resource manager, or another really easy one is just going to the resource folder, the new vector asset, and you're going to get this really nice dialog with all the available icons in their different styles. So now let's actually jump into what we are working on, or we're working on for 4.0, and I'm going to leave you with Nicolas.
Thank you, Oscar. So as you saw, lots of refinement in 3.6. You can download it today. It's in beta. Check it out. There's a lot of cool stuff. But in 4.0, a lot of the stuff we've been working on in this past year, maybe sometimes a little more than that, are finally coming in. And I'm going to talk about a couple of things. First, you heard about Compose, and we bring the Compose preview. So you see that here, if I modify the text, it reflected in the preview. If I go and I change the theme, it will be reflecting in the preview as well. So we are bringing a lot of the tooling that we built for the existing Android framework, and we are making it available to Compose. And the story doesn't end there. There's a lot more stuff we want to do in Compose. So it's very, very exciting, I think. And you can try that on 4.2 today. The other thing that we're introducing in 4.2 is something we call the multi-preview, and you can access it simply by bringing this tab and opening it. And what it does essentially gives you a way to visualize your layout in different configurations without having to bring up your emulator or your different devices. So here, by simply opening it up, we load a specific set of configuration, and you can see what your layout looks like in tablet, in different form factors, etc. But we go beyond that. First, you can do the same things for your languages that are defined in your project, which is very convenient. We continue. We can do more things. We can let you create custom configurations, so you can actually select the configuration you are interested in. And you can see that, everything is pretty configurable. And the last thing I'd like to highlight here is the last configuration, which is, let's see, okay, is the color blindness simulation. And I'm really happy that we finally got that one. Thank you. Specifically, it's such a common thing to forget when you do application, but it has a lot of, a strong impact for a lot of people. And now you can directly put it in Studio and see if your contrast, for example, is correct or not. And you can see here the title is not ideal. The last thing that's pretty nice is that because everything is linked together, if I modify something in the layout editor, everything reflects live in the preview, and that works regardless of the configuration. So you can see here, I move the button, and you can see the configuration updating. So it's a very useful tool. I encourage you to check it out, and please give us feedback. The other improvement that we made in your workflow is when, a little bit like what we did for the Compose preview, but when you create your custom views on Android. So you can do that today by creating, you have your custom view here on that left panel. I can create an XML file, and inside that XML file, I can put my custom view, and it will display in the preview using the new split view mode, the result. But it's a little cumbersome. So now what we offer is we bring up a panel immediately next to your code. And you can decide the configuration, match parent or wrap content. You can go and modify something, and it will correctly replicate what you've been doing. So here I'm just changing the string here, and it applies the correct things. So we hope that's going to make your life a little easier. And the last thing I wanted to cover is the layout inspector. And if we've seen the demo this morning, you had a good taste of it. But essentially now, we have something like Hierarchy Viewer, but on steroid, right? We can basically have a live update on what's going on in the emulator or your device in Studio. And it's very powerful. We get the information of all the views. If I click on the emulator, the screen changes, you can see it reflected back in Studio. And we also support showing you the different compositing layers, the different views, in fact. And that gives you like an idea on overdraw and things like that. It's all selectable as well. The other thing that we can do with this tool is when you select an element, we are going to show you the different attributes, and you get attribution. And that allows you to know where a specific attribute has been defined, and you can simply navigate to it in Studio. I'm going to show you something a little cool as well, is that if I go to that file, here that's a color, I bring up the new color picker that we recently introduced as well, and I'm going to change the color to something else. I'm not a designer, so it's probably going to be a little clashing, but if I do that and I use apply changes, you're going to see it replicated very quickly. So that's a very convenient tool to improve your workflow. And last but not least, in 4.0, we introduced the Motion Editor. And to talk to you about Motion Editor, Paris and John.
Thanks, Nicholas. So yes, it is a very exciting day. Today, Motion Editor hits alpha, and it's available in Android Studio 4.0 Canary 1. Before we dig a little deeper into Motion Editor, I would just like to take you down the trip of memory lane for the Motion Editor. So it starts out of last year of I/O, when we first announced that we're going to support tooling for animation for Motion Layout Library that was built by John and Nicholas, who really sets out to produce these libraries and tooling to really help you create layouts and animation easier and quicker. And so they first showed you the first UI that we worked on for Motion Editor, and at the time, it focuses on single transition editing. So you can see that it's really just one timeline, and you can play the animation and add some different keyframes. That brings us to ADS of last year, which we actually got an upgrade for some of the API features. From early motion layout adapters, John and Nicholas made some changes. We have this new feature called multi-state transitions. So we also ran multiple usability studies at the time for the first UI that you saw. This is also the time that we first announced Project Marble. And so this actually halted the development of Motion Editor, but it gave UX some time to really think through, do some design sprints on how we can represent these different multi-state features. And so that brings us to I/O this year, where John Nicholas was able to show this kind of like crazy sticky notes animation playing in the second iteration of the UI. And it's really because of Project Marble we were able to kind of have that performance. And so it was also the day that John announced that his sole job from then will be the Motion Editor. So today, we're happy to show you our first iteration of the new UI, our Motion Editor. We ran multiple studies, and hopefully this can really help you with your workflow. So I'm going to go straight into it and give you a little quick demo of what it works, how it works. So this is a layout editor. I have a constraint layout. I have an image that's centered constraint, and then I have a button. Now I'm just going to right-click on this constraint layout, and I'm going to select Convert to Motion Layout. This dialog tells you that we'll convert this motion layout and actually add a separate scene file in your XML directory. So when that's done, voila, the motion editor shows up because you now have motion layout. So we actually kickstarted the scene file for you with a start constraint set, an end constraint set, and a transition going from start to end. So what I'm going to do is I'm actually going to click on the start constraint set, just going to move this droid to the top left corner of the screen on the design surface. And then I'm going to go to my end constraint set and just move it somewhere else. So now that I have the beginning of my animation and then the end of my animation, if I now click on this transition, you can see that we've already drawn the path for you and interpreted the path. If I play it, the droid is moving. And I can actually scroll through different paths along the lines of this animation, and that just says at midpoint, I would like to alter the position a little bit. So I'm gonna just change the path to the left a little bit, and you can see now the path has altered. And if I play this animation, I'm like, this looks pretty good. So I'm just gonna do one final thing and add a click event on the button to initiate this transition. So once I've done that, and if I play it in the emulator, and if I just click on this button, yay, the droid is moving. So you see I've done that without any code. But speaking of code, I'm going to bring John to tell you a little bit about motion layout.
And we'll dig deeper into all the pieces after this. But first, let's have a small view of what is motion layout. So first, we have constraint layout 2.0 beta 3. And if you're going to use the editor, you need to use beta 3. They're designed to work together. And in fact, we'll be evolving the two of them together to a completion within the next 2 quarters. Who knows? So what is motion layout? We call it motion because it's not just animation. When you open a swiping opening bar, or you're scrolling up, or you have a view pager, there's sort of animation happening, there's motion happening, but it's not just a straight linear animation. It can go backwards and forwards. And in fact, you can make animations that sort of have 2 dimensions to it. You're moving, and when it's moving, it's also bouncing or something like that. Motion layout works in that kind of environment, but essentially, motion layout is a subclass of constraint layout. So it's in your layouts. It's everything you're familiar with constraint layout. It has it in motion layout. But we do it a little bit different in it. The layout file is like your normal layout file, but it has a layout description, which is pointing to the motion scene file. The motion scene file contains your constraint sets, which are essentially capturing the elements of your layout. It has things like the wrap content and the margins and things like that, everything that you're used to using in constraint layout. But now you can have multiple of them in your scene. So you can have as many constraint sets as you want. And you can think of the constraint sets then as the state of your UI. So now you have this thing where you're having one file that has multiple states for your UI, and you can you can use those states in different ways. You can have checkboxes and not checkbox, something connected, not connected, things like that. But the other thing is, besides the states, now you have transitions between states. So a transition is really a connection between a starting and an ending state of a transition. Now, in a transition, you have on-clicks and on-swipes, which are really how to trigger your transition. And then you have keyframe sets. Keyframe sets can be one of 5 different types of modifiers to the animation. So the animation is going from start to end, but you might want it to do something in between that's a little bit different than a simple linear interpolation. And here you see in the editor, you'll be able to graph them and see how they're going. We'll go more about that later. But another thing you'll see here on the right, the code, it's manipulating a table. And this whole program was done purely in code. So this is not using XML and all that other stuff. If you want to write motion layout directly in code, And in this case, it's a sort of graphing, charting app written in code and making a custom component. And a detailed tutorial on this will come out soon. OK, now let's go for a little deep dive and see all the little different parts. Paris?
Yes, so now that you're all experts on motion layout, we're going to bring you back to the UI that you just saw on Motion Editor. So you can see that the demo that I showed you was a very simple example. The Motion Editor actually wants to support motion layout, so it can be really powerful and complex. So let me walk you through the UI a little bit. So let's start with the palette and component tree, which you're probably familiar with today if you use the layout editor. It's where you can drag and drop different components, where you can look at your hierarchy. The design surface now, besides previewing the layouts, it actually previews your animation, the different transitions. It's also where you can do a lot of the authoring experiences like create constraint, delete constraint, alignment, and center, create change, all the good stuff. Now I'm going to move on to one of the newer panels. This we're calling the overview panel. The overview panel really have two different sections. One is the creation icons and the other overview graph. So for the creation icons, these are really just really simple actions that we created to help you quickly build a graph and the elements that you have for your motion layout. So if you see them in action, here I have just the graph that I already started, but I can actually create more constraint sets. In this case, I'm going to create another N2. I'm also going to create another transition that goes from just start to the N2 that I just created. And once I do that, you can see a transition arrow actually goes through that, and I can select it. One final thing I'm just going to do is to add a swipe event on that transition. You can see a different legend for that. And so I'm going to move on to that second section, which is the overview graph. This overview graph is really our attempt of trying to give you a very visual representation of your scene file. So this is actually where we kind of place the different components. We have motion layout, constraint set, transition, and gestures. And these are kind of the legends that we come up with to help you navigate through that scene file. I'm going to just show you a little bit as well, the actual code behind that.
So in this particular case, this is a simple example, and you're seeing the XML that it came from. And there's a one-to-one correspondence here. The start is shown as a constraint set ID start. The end is constraint set ID end. The transition, you see the on-click is written there. That's the little dot there. Now, if you look at a more complex example, this So the topmost line of the transition is the topmost transition in the file. It's going down top to bottom. And the left to right of constraint sets is top to bottom of constraint sets. So you kind of have a sort of mental map of what your file looks like.
Besides being kind of the visual graph for your scene file, this overview graph is also really what we call the state control unit for your motion editor. So if I see this right here, I'm just clicking on different constraint sets. I'm also clicking on different transitions, and you can see the surrounding panels actually correspond to that state. So when you approach the motion editor, that's really the first step I want you to see. That's actually representing of the entire state of your tool. So that is actually the overview graph. Now I'm going to move on to the second panel, which we're calling the selection panel. So as I just mentioned, because the overview graph kind of controls the different state of that everything else. So the selection panel actually really has three different states. When motion layout is selected, when constraint set is selected, and when the transition is selected. So let's go through them. If a motion layout is selected, this is pretty kind of familiar. It's like your component tree. So it really just tells you what components, what type they are in this motion layout. We added a little more information for you here, whether it's properly constrained vertically or horizontally, just so you can know which components you might want to focus on. When a constraint set is selected, you see a different table. So in here, we want to show you just kind of a little information on what component is actually constrained in this constraint set, and where is it coming from. And here's actually the code that's behind that particular panel.
Yeah. Now you'll notice that the bottom button 3 has a gray check mark. That means it is constrained, but just not in this constraint set, not in start constraint set. And that's because it's in a derived constraint set named common. And so that you can actually use this to get a picture of what that particular constraint set looks like and how the different buttons and widgets and views, how are they being constrained. Now, this is for when you're trying to get very big, complex ones, and we'll see more of them later.
Yes. And the final state that the selection panel can be in is when the transition is selected. And you can see that this is actually pretty similar to the first UI that you saw when Motion Editor first came out, because this is focusing on single transition. So when the transition is selected, I can play the different animation toolbar, I can click on the keyframes, I can look at the graphs I've created for cycles or attributes, and I can also add keyframes and scruff the animation. This is where you can really fine-tune your specific transition. So that's the selection panel. I'm going to move on to our final panel, which is the attribute panel. And you'll probably know a lot about it because Oscar kind of just talked about it. So we use the setting attributes panel across all our tools. So I'm actually just going to focus on a couple things that are specific to Motion Editor. So the first thing is that it's really reflective of whatever is selected. So from anything that's as big as constraint set, transition, and component, or as small as a keyframe on a transition, the attribute panel is where you can look look at declared or potential attributes that you can manipulate. A second thing of the attribute panel is that it shows the inheritance relationship for your motion scene file and the layout file. So you can see here that I have the constraints are coming from the inherited motion layout, and that's why it's gray out. When it's black, it means that it's actually defined in this current constraint set. A third thing that we want to show you is authoring constraints. So you saw me do the demo with just moving this droid to the top left corner directly on the design surface. I can actually do the same thing using the attributes panel. So if you see that I select this droid, I'm going to change that derived constraint bias to 0.1. And once I've done that, everything is black because we copy over the constraint for you, and it's now defined. And you can see that the droid can be moved up in this place using the vertical bias. We can also use the single widget view.
One of the things to know is that on the design surface, you can right mouse click, and they have a bunch of controls like constraint to the left or the right. There's also some toolbar controls. So all of those will work properly with a constraint set. So if you have a constraint set and you make a change, it will constrain in that constraint set.
Yes. So now the final thing I want to show you about the attribute panels is that it supports adding custom attributes, which, as you probably know, it's a motion layout do have. So in this case, I'm changing the background of the droid to a different color. So I just kind of pick a random color background here, color accent. So it's not pretty, I know, but the idea is that you can actually kind of manipulate different custom attributes, and we do some checking for you. You can see once I change the color, and if I click on the transition, it actually interpolates the colors really nicely for you. So this is one of the power of the tool and the layout. So John has prepared a fun demo for us.
Yeah. So last week, Andrew tweeted this video. And it's a constraint layout. It's a motion layout. It's interesting. It has two constraint sets that are, so it has 3 states, and there's cycles, key cycles, oscillating between them. So you see the first one is a cycle that's just bouncing it like this. And then the next one bounces like this in size. So it's pretty neat, but I thought, why not take it to 11? So now so we kind of reproduce the same kind of behavior, but a little more stylish. And then we go crazy with it. Now let's see that inside the motion editor. So you see all the cycles that are producing this weird wobbling motion of the pen. Are being controlled by that. Then the next cycle, and then the next cycle that is producing this spinning, and then the fly-in of the other view. So it was all designed in this. Now, interesting, in blueprint mode, if you press Control, you can actually see the paths of all the objects. So you can actually see what you're actually doing with all of them. So it's a very easy, powerful way of seeing your layouts. And I did this over the last few days, this week, just sort of to show it's very capable of doing complex animation designs in a very little time. Hopefully, you don't get this carried away in your real applications. Okay, now Nicholas, to close us out.
All right, thank you, John. So, as you can tell, there's a lot of stuff that we've been working on, and we're super excited about them. We would encourage you to try them, give us feedback. The Canary is out, beta is out, and of course, it's going to be an iteration. We're going to improve them. We have lots of ideas, as you can imagine, but we really think that as it stands today in 4.0, it's already a very, very powerful tool, and we can't wait to see what you're going to create with it. As I mentioned, 3.6 beta 2, I think, maybe, is out, so give it a try for those refinement that we talked about. 4.0 is available today, and 2.0 beta 3 for constantly out has been released today as well. So the other thing is to keep in mind that we have all those different design tools now, and it's starting to build up a pretty large picture, and they really work well together. They really, if you use one in isolation, that's great, and they are really nice, but keep in mind, you have all those other stuff that will help you during your work. And on that note, to help us, please do file bugs. There's the issue tracker. I promise you, we do look at those bugs, and sometimes we do fix them as well. And, but it is, as I mentioned earlier, we try to build tools that have values for you as developer. We try to make your life easier, and that's how we can make it happen, right? To make sure that we do something worthwhile. And on that note, thank you very much. We have Motion Layout Code Lab a little after.
20 minutes.
Yeah, so you can pass by, we can answer questions, you can do the code lab with us. We're more than happy to have questions answered. Thank you.
Thank you.
Robinhood's an investing platform that lets users buy and sell stocks, cryptocurrencies, options, and ETFs, all commission-free. Robinhood believes that everyone should have access to the financial markets, so we built Robinhood from the ground up to be fast, simple, and easy for all investors. People love Robinhood's simple, beautiful, intuitive design, and they love that they're able to place trades on the go.
Here at Robinhood, we have a team model of the less code we have to write, the less code we have to maintain, which means the better off we will be. So that goes hand in hand with adopting Jetpack components to be able to do a lot more things that we as a small team would not be able to do. Jetpack in particular is really great because the libraries are really reliable and really well tested. They're actively being maintained, and they solve a problem that the Android community often have. One component we were really excited about was definitely Room. It's probably one of the libraries that best utilizes annotation processors. It just hooks up to our UI. Our UI can listen to the Room database changes, and the network layer can be abstracted away. It also allows us to reduce a lot of boilerplate around database serialization, deserialization. One of the newer libraries we adopted was Work Manager. And in fact, we have been using Work Manager ever since the very first alpha because it solves a pretty big problem for us. Prior to Work Manager, we had quite a few periodic jobs that we want to do, and we decided to not do them because it was just a huge pain to maintain. With Work Manager, it offers us a very simplified and unified API and allows us to define exactly what we want and have everything just work. As a developer, I think writing clean and maintainable and readable code can be poetic, so it's definitely like one of the joys I get out of my work.
The Android team at Google has always been super involved in the community. Jetpack is a perfect example of responding to what the developers have been asking for and making our lives easier by letting us focus on just our core business challenges. Robinhood has more than doubled our customer base since launching on Android, and we hope to continue growing.
It's nice that we get the opportunity to reflect back on the last 10 years of Android and really offer some targeted answers to problems that people have been having.
Yes, we looked at what hard problems there were and then created Jetpack as a way to help people make high-quality apps easier. One of the areas that we never really solved well, though, was UI, and we really wanted to look at how could you make it super simple to build a UI.
The right pieces are in place to put forth a very different model of development. Not only do we see Kotlin gaining a whole lot of momentum, but we also see reactive UI frameworks getting a lot of momentum. And Kotlin provides this connective tissue that's really part of what enabled Compose, is that Kotlin's so powerful.
And I think once people start seeing Compose in action, it really becomes like a delightful thing to program.
Even with Compose and this new way of building UI, it needs to work with all of your existing apps. It's so important to make sure that when people adopt Compose, you can adopt just a part and it's compatible with your existing views.
If you want to get started very small, it's very easy to do that.
You just want to iterate an idea quickly, you want to see it live, you want to make a change and see it automatically.
I think I'm pretty excited about just writing a whole lot less code when I'm writing UIs. When there's less code, there's less places for bugs to hide too. So.
The core consideration when it came to ergonomics was not just code size, but understandability.
It's going to be easy to get high-quality apps that work natively against Android.
I'm looking forward to us learning from our users to like show us what they think is really nice to work with.
Yeah, the best parts of Compose won't come from us, and that's really the most exciting thing about it.
Hi, everyone. My name is Nick Anthony, and I'm a program manager with Jetpack.
Hello, everyone. My name is Tim Song. I'm a developer programs engineer on the Android DevRel team. Today, we're going to talk about migrating your app to Android X.
Great. So before we dive in, it's important to ask ourselves, what is Android X? We throw a lot of terms out there. So by a show of hands, who here has heard of Android X? OK. By a show of hands, who here has heard of Jetpack? By a show of hands, who here has heard of the support library? OK. By a show of hands, who here knows what the difference is between all of those? Great. So for those of you, I think I caught most of the people in the room, but for those of you who need some more clarification or may not know, Jetpack is the set of libraries, tools, and guidance to help you, developers, write high-quality apps easier. So we think of that in terms of three things. That's best practices, eliminating boilerplate code, and simplifying complex tasks. So you can focus on the code that you really care about. So how does this relate to Android X? As you can see on the slide, Android X is the package name for all libraries within Jetpack. So we think of Android X as this is the open source project that we use to develop, test, version, and release Jetpack libraries. Now, how does this relate to support library? So if you remember back in I/O of 2018, we announced that we'd be refactoring the support library to the Android X namespace. So we did this with support library 28. We also announced Android X 1.0. And so we'll touch on that a little bit about why that's important. Great. So we've gotten to the point now where we kind of talked a little about what these things are. And now this next question we want to ask ourselves is, why should I migrate? Why is this talk important? Why are we here? So there's kind of 4 points we want to bring up. One is that the support library is done. 28.0 was the last release of the Android.support namespace. So this is a namespace we're no longer maintaining. So if you want bug fixes or new features that normally would have gone to the support library, you're going to need to go and migrate to Android X. The next thing, you get some better package management. So these are kind of the reasoning why we made the refactor. That's the standardized and independent versioning, as well as the better naming and standardized naming and more frequent releases. These are kind of what you get out of the box with Android X. The third thing is that you're going to, some other libraries have migrated to the Android X namespace. So there's some notable players in there, as well as Google Play Services, Firebase, Butterknife, Mockito 2 in some cases, and SQL Delight. And we're going to touch on migrating these dependencies in just a minute. The final thing we want to point out is that all new libraries are coming out in Android X. So we're really pushing forward on the Android X namespace. And so some of you might have heard of things like Jetpack Compose or Camera X. Those are going to be in the Android X namespace, and a precursor is going to be migrating to Android X. So now we've talked about what these things are. What is Jetpack? What is Android X? We've also talked about why you should migrate. I'm going to pass over to TM now to talk about the specifics of actually going through this migration.
Thanks, Nick. So let's go ahead and talk about how we want to migrate. But before we do that, here are some things to do to prepare your project for migration so you can have a more smoother experience. First, back up your project. Now, many of you might be using source control, so that's probably OK. But just in case, make a backup of this project because the migration will change many of the files in your project. Next, we want you to try to minimize feature development during this time, and we'll cover this more in a little bit, and also try to make these migrations on a separate branch. Now, we have a recommended approach on how to migrate. Now, I know these are a lot of steps, and we'll explore these one by one. I'll explore steps 1 through 3, and then Nick will talk about steps 4 and 5. So first, we want to update the support library to version 28. Now, if you're on an older version of the support library, say 26 or 27, and try to make the migration all the way to Android X, well, you're probably going to have a bad time. That's because not only will you need to address the namespace changes, but also the API changes between 26, 27, 28, and Android X. So what we suggest is first try to update to version 28 and address all of those API changes and get your app compiling with 28. And at that point, make them jump over to Android X. Now, support library version 28 and Android X 1.0 are binary equivalent. So what does that mean? That means only the package name changes between those two versions. All the APIs are the same. So this way, you'll have probably a minimal set of things that you need to fix between migrating from 28 to Android X. So now that you've migrated your app to support library 28, we next want to enable Jettifier. So what is Jettifier and why is it necessary? So Jettifier will help you migrate your third-party dependencies to use Android X. What this means is that Jettifier will actually change the bytecode of those dependencies to be compatible with your project that's using Android X. Now, Jettifier won't do a couple of things. It won't change your source code, nor will it change your migrated, nor will it migrate your generated code. So here's how to enable Jettifier in your app. You add a couple of lines to your Gradle.properties files, and in here, use Android X is set to true along with enable Jettifier. Now, the use Android X setting turned to true means that when you do code auto-completion and you're importing libraries, you'll import the Android X version of that library instead of the old support library version. All right, so moving on to step 3. Once you've enabled Jettifier, we'll need to update your dependencies. So a lot of third-party dependencies may need to be updated before you actually start the migration. So here are some of the dependencies that we covered earlier, and I want to highlight a specific example. One of our flagship sample apps is called Plaid, and it uses the Glide image loading library. We wanted to use Plaid as an example of how to migrate over to Android X, and we discovered when we did the migration without first migrating our Glide dependency, we ran into a bunch of compilation issues. And we looked and we found that version of Glide that we were using was not Android X compatible. So what we did was we first updated Glide and our other dependencies, and then ran the Android X migration, and then that error no longer appeared. So if you can, try to update your third-party dependencies first before starting the migration. Now, if you're using a code generation library, Jettifier won't modify these. So you might need to check if the code generation library actually is compatible with Android X. So let's look at some common errors that might happen if you skip steps 2 and 3, one of which is the third-party code that you're using is not compatible with Android X. You'll see that it's trying to pull in the old version of the support library. Also, if you have a project that's partially migrated, you might get a duplicate class error where it's trying to pull in the same code from both the support library and Android X. So back over to Nick to talk about step 4.
Thank you. So now at this point, we're going to talk a little more about the actual source code. So we've gone through, we've got support library 28, we've enabled Jettifier, we got our dependencies in order. Now we're going to go in and as of Studio 3.2 stable and above, there is a handy migrate to Android X button. So you can see under the refactor, highlighted in blue here, there is a migrate to Android X. And what that will do is migrate your source code. And this will work for a majority of cases. Now, however, we do realize that some teams may not use Studio, or there is some more sophisticated app architectures that our tooling can't exactly automate. So that leaves you with 2 options here. So these options include just migrating the source code itself. And one option is use a bash script. So this is a grep and sed, and we'll see the script in just a second here in the next slide. And before we dive in there, we want a special thanks to Dan Liu for picking this up. You can follow this Go link, gol.gle/AndroidX migration script. And that'll link you to the GitHub source page where you can see that script as well as more community contributions. So how about that script? You can see here we have the class mapping as well as your project, and what is effectively just a grep command followed by a sed command to replace those package names. One thing to note when using this script, it's pretty brute force. It is a bash script. So it may do some of those migrations incorrectly in some cases. So just be aware of that when you're using this kind of methodology. The other option is get your hands dirty and do it by hand. So if you go to developer.android.com, go to our Migrate to Android X page, we have an artifact mapping from the support library packages to our new ones, as well as a class mapping with the same support library to Android X. And that'll let you do kind of on a case-by-case basis, so you know it's right. So at this point, if you've kind of managed to follow us along this long path, you get your project compiling again and fix any tests that may have broken along the way. You'll have a project that's running on Android X, which is awesome. So before we end this talk, I think it's also important to talk about some issues that the community has run into. And so I'm going to pass over to TM now to dive into those so you know about them ahead of time.
So here are some issues that you might run into for your migration. So there are some things that we cannot automate. So your version control files may require some manual intervention. Now let's go ahead and see that in action. Here is your build.gradle file prior to migration. Now you'll note that we use the old support library, and in here we actually extract out our version variables into its own separate section. Now after running the migration tool, we now have our drawer layout and recycler view using the new Android X packages. But you'll notice that the version numbers are now inlined, and the variable numbers are not yet changed. So the tool does not modify this. So you'll need to manually update this as such. Let's change the drawer and recycler view versions manually to 1.0, and then we'll need to inline those variables back in. So something to be aware of. Next, the tool is enabled to migrate your ProGuard and any build scripts. So if you're using these and have package names in them, you'll need to go in and manually edit these as well. Now, earlier we talked about trying to slow down development or working on separate branches. And we'll talk about this a little bit more. Because so many files will need to change, we suggest that, if possible, try to slow down or stop development entirely. I know this is like a very, very big ask, asking an entire development team to stop development. But this definitely reduces the amount of merge conflicts that will happen. If you can, have a few people on your team just focus on the migration, and then have everybody else to say, like, hey, there's a big merge conflict that will happen in your future. So let them know about this ahead of time. Also, try to do the migration on a separate branch. When you're doing this migration, it's good to just focus on addressing the errors and getting your app to compile and all tests passing again. Don't try to do refactoring, or don't try to pull in new features during this time. It'll just make this a lot more difficult. So when you run this migration tool, you may have an alpha version or a stable version of the library, depending on the most recent release. Now here we have the support library version of AppCompat, and we run our migration tool, which migrates our AppCompat to an alpha version of the library. Now, depending on your particular needs in your project, you may want to use the alpha version, or maybe you prefer stable. So this is something that you'll need to go back and manually check to see which version it migrated to, and make sure that you select the version that's appropriate for your needs. And you can find more about these particular versions in the table, and we'll cover that in our resources section. So we have our Android X documentation on our developer.android.com website. This covers the overview of the Android X project, our migration guide, the mapping table of the old support library to the new stable and alpha versions, and also the CSV files if you want to script your migration. We also wrote an article detailing our migration to Android X in the Plaid sample project. And in here, we uncover the steps that we took, some of the problems that we ran across, and the solutions to those problems. And you can access that via goo.gle/plaid-androidx-migration. And finally, we have the issue tracker, where you can go to see the issues that we're currently working on with the migration tool. Or if you like, you can create a new issue using the button at the top left of the page. So we wish you the best of luck in migrating your app to Android X. And if you're attending the conference in person, please stop by our Jetpack sandbox with any questions or tell us about your experience in migrating. Thank you very much.
Thank you.
Hello from the floor of the 2019 Android Dev Summit, and welcome back to today's final session of the hashtag Ask Android live stream. I'm Dan Galpin, and this is my co-host, Lila Fujiwara. Once again, we're here to ask experts questions that have been tweeted to hashtag Ask Android or asked in the live chat.
And those experts are Chris Baines and Fred Chung for your question asking pleasure. So Chris and Fred are both Android developer advocates, with Chris leading advocacy around the system UI changes in Android, such as dark mode, which I have a pin for up here, gesture nav. On the other hand, Fred focuses on privacy changes and China developer outreach in general. Welcome, Chris and Fred.
All right, so first question for both of you, what is your favorite feature in Android 10?
I'm going to go with Thermal API. Yeah, it's an API that on supported devices, if it gets too hot, it's an avenue for the OS to tell the app that, hey, I'm too hot. Don't run high performance stuff on me. Let me cool down.
All right, that's a great, especially for game devs. That's going to be awesome.
Totally.
So I think for me, it's the headline feature of Dark Theme. Like, we've tried to land this feature now for about 4 years. Every time, like, you'll go to a developer option, it'll be taken away. We finally got it landed. So yeah, for me, Dark Theme.
Dark Theme. All right. So speaking of Dark Theme, KimC929 asks, how to determine the dark theme system enable? I need to get it to change the icon color of notification actions. Because notification compat doesn't support changing the background of custom notification with remote view automatically.
Yeah, I mean, with notifications, it's the same process you have for normal views. So Dark Theme is a configuration change. So if you're using values-night to be able to vary those resources, those drawables, the resources system will work automatically with notifications. It should just all work. It's a little bit different with custom layouts and notifications, but as long as you're using the -night resource qualifier, it should all work.
All right. Excellent. All right, so let's see. This is an interesting. Kenneth L171 asked, hashtag Ask Android, with Jetpack Security Lib and the Android X Biometric Prompt Lib, will Google put more emphasis in making use of the Android key store provider and also making sure that OEMs don't break that functionality?
Yeah, I can take this one. I think in general, we are trying to improve the performance of key store providers. And we'd like to, over time, add more and more features to the Android security library.
Yeah, I mean, the Titan security key is actually security chip is actually like a really big selling point for our devices. And I know for a lot of other OEMs, there is a very similar kind of, focus on both privacy and security.
Right, yeah. And we are obviously working very closely with different OEMs to make that support more efficient.
Okay, so from Twitter, this is a combination of letters and numbers. So BJ20XY asks, hey Android team, is it okay to exclude from the gesture areas, the sides of your carousels? There are many apps out there doing so already.
Carousels are a little bit of a weird one, so it depends on how you're using them. We allow the gesture exclusion APIs, so they allow you to exclude parts of the gesture zones and your app takes precedence. The problem is that we have limits on them, so you can only limit up to 200 dips per edge. Carousels tend to be quite tall, and so it depends on what the content is. If it's the primary use case of your UI, then it's probably okay. But if you tend to have large lists of them, say for instance Play Store, which is similar UI, it's probably not okay. We kind of feel that users will get used to where they swipe, whereas in the middle of the screen. The actual edges for the back gesture is like 24 dips wide, so it's not a huge area, and we think users will just get used to it, basically.
Yeah, I've certainly seen that in my own usage. Okay, let's see, what do we have next? So when Colin White asks, when implementing dark mode, what's the recommendation around using dark gray backgrounds versus true black backgrounds?
Dark gray versus black. You might have correct time to answer the question. So the material guidelines have recommendation of using dark gray. And that is because you still get the benefits of battery saving and also a darker theme, but it don't have that harshness that black backgrounds give. The reasons why the Pixel OS has black is to maximum battery saving. So that's the primary reason why it does it. Apps don't really have that issue, so therefore they can use a darker grey. Gives less of a harshness and it tends to be better visually.
All right.
Okay. So we had a couple of questions about IMEI, so I'm going to just ask one of these. Felipe C, a bunch of numbers, asks, hi, how can I get the IMEI number in Android 10?
Yeah, and we had a couple of, another company was providing smartphone insurance, and they want to get the IMEI number.
Well, as people are probably aware, in Android 10, we started imposing the restrictions for developers and apps in general to retrieve what we call non-resettable hardware identifiers for privacy reasons. So I think for apps, it really depends on the use cases. If you wanted to, for example, track daily active users and so forth, you can use UUID, which is currently available in the framework. Or if you want to track cross-app installation or uninstallation attribution, for example, you can use secure setting SSAID, secure setting Android ID, long name, but it's available in the framework. So, yeah.
Yeah, I was going to ask, can you talk a little bit more about why these changes were made, or?
Yeah. So, like I said, the motivation for imposing these restrictions is to improve user privacy, because we don't necessarily want application owners or developers to get a hold of the user's hardware identifier, which are largely not resettable, because those are rather permanent. So we wanted to move towards the mobile industry standard, where different mobile OSs in general have adopted that practice, so that we wanted to move the ecosystem forward to become more privacy friendly. Yeah.
So Cario VMF asks, if a user sets a foreground service notification to show silently and minimize, can the service keep running indefinitely?
Yes, they can. Simple answer. So yeah, it's up to the user what they do with that notification. If they want to turn the app to be silent and minimized, that's their choice, and it's up to them.
Yeah, in some cases, I would say if the application developer has chosen to add user controls to the notification, then the user in those scenarios won't be able to stop the foreground services, for example. Yeah.
Okay, I'm going to do this one here.
Okay.
So Texta, and a bunch of numbers, asks, could a new app I build inherit a dark theme from Android? That is, in the styles. Is there a style created which could make my whole app dark theme automatically?
So yeah, we have the day-night variant of themes. So AppCompat added this a number of years ago. So yeah, if you're using AppCompat, you already have this feature in there, and we call it day-night. So yeah, look at the APIs. We've had a number of blog posts over the years, so look it up.
So one last quick question. What happened to Bubbles?
We weren't quite happy with where it landed. Bubbles, in terms of the way apps could use it. So we made it into a developer option, and that allows apps to actually still play with the APIs and get it working. But we're not quite sure how it's going to play yet. It may come back another Android version, but we're not quite sure yet.
All right, well, thank you so much.
So with that, unfortunately, we're almost just out of time. But before we leave Chris and Fred, if folks want to learn more about any of these Android 10 features that you're talking about, where should they go?
Developer.android.com/privacy.
So for me, Jeshanav, we've released a number of articles on Medium, and Dark Theme as well. There's a number of articles, so yeah, look on Medium.
Yep. All right. So follow us on Medium.
Android developers on Medium.
Yeah.
All right. Well, and thank all of you for joining us from around the world for this very first Ask Android live stream. This concludes today's broadcast. We'll be back here tomorrow for another edition of #AskAndroid starting at 11:55 a.m. PST.
And from me as well, thank you so much for joining us, and we will see you tomorrow. In the meantime, do keep tweeting us your questions with the #AskAndroid hashtag. And if you want a deeper dive, go ahead and subscribe to the Android Developers YouTube channel. All right.
Maybe you shouldn't clap just yet. When you'll see some of the slides, you might change your mind. So, hi, I'm Romain Guy. I manage the Android Toolkit team at Google.
I'm Matthias.
And Matthias and I both work on this project called Filament that's available on GitHub. It's a 3D rendering engine that supports multiple platforms, including Android, and it's used on Android and iOS at Google to run AR. So in this short talk, and we're going to try to speak really quickly, we're going to tell you about some of the performance tricks that we use to make everything run fast. So let's get started.
Okay. So while working on Filament, there was 3 performance metrics that we thought were really useful. So the first one is the instruction count, CPU cycles, and cycle per instruction. So the reason why we like those metrics is because they are very stable. That's because they don't depend on the CPU frequency or the scheduler. So that means each time you're going to run your benchmark, you're going to get really consistent results run after run. So I also would like to talk a little bit about the cycle per instruction. That's a very good metric to give you an idea of the quality of the code. So for example, if the CPI is really high, let's say above 2 or 3, that might mean that your code is running into cache misses or mispredicted branches. So that gives you kind of an idea where to look. So if you look in the Filament source code, you will find this profiler class that you can use to access those performance counters. And on this slide, you can see how to use it. It's pretty easy. You create the object on the stack, call start, run your code, and call read counters, and voila, that's it. OK, so now let's look at a few things that we did in Filament to keep good performance. The first tip is, it might sound a little bit counterintuitive, but it's to not use the neon intrinsics. And that's because generally it will prevent the compiler from doing certain optimizations, like vectorizing loops. And most of the time, it'll do a better job than if you do it yourself. On the side of things to do, I think one of the most important things is to keep your code simple. That doesn't mean write all your code without any abstraction or anything like that, but it means that 10% of the code that needs to be fast, just keep it simple. That will help the compiler understand what you're trying to do and do a better job at compiling it. Use fast math, use restrict. Those 2 keywords will help the compiler vectorizing loops again. For those who don't know, restrict is a keyword that tells the compiler that a pointer doesn't overlap another pointer, and it needs to know that to do a good job at vectorizing. OK, so now we're going to look at an example. So that's taken directly from our math library. So here we have a matrix. We take the transpose. We transform a vector by this matrix. But we keep only one component of the result. And as you can see, the compiler did a pretty good job. The transpose operation is completely gone. It's as if it was never there. And even the matrix multiply has only the instruction that's needed for that component. If we had written the code with inline assembly or intrinsics operation, then the compiler would have had no choice but to keep that code and could not have gotten rid of it like that. This is another example. This is taken from our sphere calling algorithm. So first of all, you can see that it performs pretty well. On Pixel 4, we're doing 400,000 sphere per millisecond. But you can also see that from at each version revision of the hardware, the code is running faster. And that's not because of the clock. It's running faster because it's running in less cycles. And yet, when you look at the code, it's very simple. It's textbook my first calling algorithm. We have a loop, we go over the spheres, another loop that goes over the planes, and we check if a particular plane, if a sphere is behind a particular plane. And that's it. And because the code is so simple, the compiler can do a really good job at vectorizing it, and which in turn means that this code is scaling with a new revision of the hardware.
Yeah, in particular, this code runs twice as fast on the Pixel 4 compared to a Pixel 3, and that's probably because the CPU in Pixel 4 has more hardware to run floating point operations. So we didn't touch the code at all. It just goes twice as fast.
That's correct, yes. Now that we help the compiler, let's see how we can help the CPU. So usually what makes our program slow fall into these two categories, data access and branches. So data access because memory is slow and the caches are small, and branches because as CPUs get faster, their pipeline gets longer, and then a branch miss is costly. So one thing we can do to address this is to start thinking about our programs in a different way. Think of how your program accesses data, as opposed to think of it in terms of like the objects that compose the program. And that's what we call data-oriented programming. So here is an example. So for example, we can have a light object. It has some attributes, and maybe we have an array of lights. So now one thing to realize is that when you're going to process this array of light, most likely you won't need all those attributes. So for example, if you're going to call the lights, you don't need the direction, you don't need the color. So what that means is that this data layout is not really cache friendly. And on top of that, it's going to most likely prevent the compiler to vectorize it, because as the structure gets bigger, it might not be able to do it. You introduce some padding, which means we're wasting memory. So it's just not really good. So one thing that we can do instead is to organize the data like on the right, where you have just one structure that has all the lights, but the attributes become an array. And that, in fact, has none of the problems that we had with the first data arrangement. One thing that is interesting, though, is that if you look at the bottom of the slide, the way you access to an attribute is almost the same. It's just where the index went. But from the point of view of the programmer, it's not such a big difference, except for the fact that you can't have pointers, because there's just no pointers, there's no object to point to. That being said, this might not be a problem, because pointers are bad anyways. They are now pretty big. They're 8 bytes. That increase cache pressure, and also you rarely need that much address space anyways. So what you can do instead is design your APIs to take a container plus an index instead of a pointer or reference. And this way you sort of kill 2 birds with 1 stone, and that makes things better. Okay, this one is interesting. So don't be lazy. Lazy computation are usually counterproductive and might also be counterintuitive, but it's often the case. And we're going to look at an example, actually. So here we have, for example, a renderable object. It has a transform, and maybe we want to update its world transform based on only if it's needed. So we'd go through the list of objects. We'll check the flag to see if it's dirty or not. If it's dirty, we'll update the flag, and then we'll update the world transform, and then we finally can use it. So let's see what's wrong with that. It's about everything is wrong with that. So first of all, we've increased memory usage. Because of the padding that's added, our cache line utilization is not as good. We can't do multi-threading anymore. That test right there is probably a guaranteed cache miss. It's also probably a guaranteed mispredicted branch, like 50% of the time. Vectorization is not going to work because of the test. And on top of that, you have to write the result back, which means you're polluting some cache lines and adding more pressure to the cache. So in the end, it's probably not worth it. So it's important to use your own judgment. If the computation is really big, maybe this could be useful, but most of the case, it's not.
And so the nice thing in this case is that the fast code is the simpler code, so you're going to have fewer bugs, it's going to be easier to read. It's very counterintuitive because you're asking the CPU to do more work, but it is faster because these days the latency of accessing memory can be much higher than doing a few operations on the CPU.
Yeah, it's probably 20 times slower or something like that. Okay, so speaking of branches, they're bad too because each time a branch is mispredicted, then it costs about 10 cycles. That's a good number to have in mind. It can be more, can be less. But also, branches can only make your code slower. They will increase the CPI, they can't decrease it. So the best thing to do is to not have branches in the first place.
And 10 cycles, to remind you, when we looked at the numbers on Pixel 4 for the test of the spheres, there was the count of 20 instructions. So it means if your branch is mispredicted, you could be running 20 computations on float in the same amount of time.
Yeah, it can make a big difference, yeah. And so here, very simple code. We have a list of vertices. We go through the list, and based on a condition, we want to store the vertex or not. So first of all, again, that condition is almost guaranteed to be mispredicted at least half of the time. And on top of that, because the ratio of branch to code is really high, this is also a guaranteed CPI that's going to be really, really bad. So how we could rewrite this code to avoid this problem like this. You just always write the result, and instead you update the pointer based on the condition. And even though in the code there's still a branch there, that branch is actually going to go away because the compiler is able to convert those very simple branches into branchless code. And so on this version, the CPI of so its cycle per instruction of that code, of that loop, is going to be much lower. That's another example of the same thing. So this is the code you saw earlier. So as you can see on the highlighted line, we are not using branches to sort of decide if the test passed or not. Instead, we sort of accumulate the result into a variable using Boolean operations. We don't try to do early exit of the loop. And so what that does is that, again, that allows the compiler to vectorize this whole loop. And also that branch, what would have been a branch, is now just kind of a basic Boolean operation. And it is also vectorized. So we run much faster. All right. So now let's look at how we can help the GPU.
So to help the GPU, first we're going to talk about floats. So you're used to float and double, C, C++, Java, or Kotlin. One is 32-bit, the other one is 64-bit. Those are pretty big numbers, and it turns out that on mobile GPUs, on pretty much all mobile GPUs today, there is a type of float called half floats. So they use only 16-bit. And they're really awesome because you can run twice as many computations in half floats as you can versus regular floats. So either your program will run faster, or you will use less power, which is always good for the user and the battery. So how do you use that? So when you write a shader that's with OpenGL, so you have this, I highlighted the word high P. When you say high P, it stands for high precision. That means you want a regular 32-bit float. So the code here I put at the bottom doesn't matter what it does, just a bunch of random math that takes 8 cycles on a GPU I will not name when you do 32-bit floats. Now, if we change this high P to medium P, so medium precision, now we use 16-bit floats. And instead of using 8 cycles to do the same computation, we use only 4 cycles. So we are going twice as fast. And that's all you had to do. But half floats can be a little difficult to use. And to understand why, let's look at how floats work. So I'm going to use 16-bit floats. The explanation works for 32-bit or 64-bit floats as well. So we have 1 bit that encodes the sign, positive or negative. We have 5 bits. It's the exponent or the magnitude of the float. And then we have 10 bits that are the significant or mantissa. It's basically the precision of the float. And the way you use those bits is using this equation. It's not that hard. We're going to look at a couple examples. So if we look at the smallest non-zero possible number that we can encode with half floats, that's this bit pattern, and we apply this formula, that value is 0.00006. any value smaller than that will be flushed to 0. So you cannot represent a number that's smaller than this on mobile GPUs. There's something called denormals. I'm not going to go into the details. If you want, you should look at Wikipedia. So the smallest value we can encode is actually not that small. It's only like 5 numbers after the 0. Now, the largest number we can encode in half float is this one, and it's only 65,504. So it's not that big either. So we have the smallest number is not that small, and the biggest number is not that big. And we'll see why that can be an issue. And the problem, too, is like the way floats work, really, is that we have 10 bits of significance, so that's 2 to the power of 10 is 1,024. So between each pairs of powers of 2, we have only 1,000 numbers. So between 1 and 2, we can encode 1,000 values. Between 0, 5, and 1, we can encode 1,000 values, and so on and so on. So what that means that as you get closer to 0, you have ridiculous precision. The smaller your number, the more precision you have, because you always have these 1,024 values. Unfortunately, when you go far away from 0, it gets really bad, because you still have only 1,024 values. So for instance, if we have a float that is between 1,024 and 2,048, because we have only 1,000 values, our precision is now completely gone. Like our minimum value that we can increment by is 1, which means that if you're writing, let's say, a renderer and your unit for the world is meters, when you have something at 1 kilometer away from the origin, your smallest precision is 1 meter. That means if you try to move that object, it can only move 1 meter at a time. Or even worse, if your object is smaller than 1 meter, you won't be able to render it at all. And I will show you an example. So, we modified filament to show you what happens exactly. So this is rendering a random object. We are at the origin of the world. We're in 0, 0, 0, and it looks great. Now, if I move the object and the camera far away, let's say 1,000 kilometers away, the same object looks like this. And what you're seeing is the precision of the floats like just going away. Like we haven't changed anything else, we just moved the camera. Here's another example. This is a more complex scene. When it's at the origin of the world, it looks great. When we move it far away, look at the shadows or that Vespa right there. Like it's unrecognizable. So there are things you can do. For instance, in filament, what we do, we actually always recenter everything around the camera, so we're always in 0, 0, 0. But I want to show you other tricks we use. So this is taken straight from filament. You don't really have to understand this code. This is Lightning code. What's really interesting is the 2 high P values here. There's a comment that explains why, but basically in this particular equation, if you look at the last line before, the line before the last one, it says float B2 equals A2 divided by D2. When we looked at this code, we identified that D2 can be very small, and if it's too small, it's going to become 0, and we're going to have a division by 0. And the only way we can work around that in this particular piece of code is to force the GPU to use 32-bit floats. It's going to be more expensive, but that was the only solution. Now, sometimes you can do things differently. So here's another piece of code. We clamp our value between 0.089 and 1. And the 0.089 seems pretty random. Actually, what happens is that when we looked at our code, we noticed that somewhere we do a division by that value raised to the power of 4. Which means that and we know that the minimum value for half floats is the one we saw before. And it means that our roughness raised to the power of 4 has to be greater than this minimum value. Otherwise, we're going to have a division by 0. So our solution is to do a bit of math, figure out what is the minimum value that this variable can have so that when we raise it to the power of 4, our division will not be by 0. Here's a last example. So the way we compute lighting in the engine, we have the intensity of a light. We have something called the camera exposure. It's how bright you want the image to be. We multiply those values together, and we multiply the result by the BRDF, which is all the lighting computation. Now, here's the problem. We use physical light units, which means that a sun, like outside in California today, the sun intensity is 100,000 lux. And that's too much for floats, because our maximum value is 65,000. And unfortunately, the camera exposure for this kind of intensity is smaller than the minimum value we can have. So we're kind of screwed here. Like we have values that are too big and too small. So one thing we could do is we could do this math in 32-bit on the GPU, but that's expensive. So instead, what we did is we moved that multiplication to the CPU. So once per frame, we just pre-multiply those two values together. because once we multiply them together, the result is about 3, which fits completely nicely in a half float, and then we save the multiplication on the GPU. And we're out of time, and that was it. Thank you, everyone.
Thank you.